In part 1, we got the core loop working. Ghost suggestions show up, we're streaming from an LLM, we've got intent tracking, caching, and we're pulling context using LSP for the prefix. But we're kind of flying blind. We grabbed code around the cursor, but we don't actually know what that code is. We can't tell where a statement starts or ends, or even figure out what should be replaced versus inserted. So in this part, we bring in TreeSetter for actual parsing, figure out replacement regions, pull types from other files, deduplicate against code that's already there, compute minimal edits, show strike-throughs for deletions, and hook up faster providers like Groq and Fireworks to complete our AI tab completion. In the description of the video, you'll find two repositories. The first one is tab completion, the source code for this tutorial. Another one is tab ahead, the open source extension where you can contribute and make it better. Let's keep going. The next thing we have to do is replacement region, and replacement region depends on TreeSetter, which is essentially AST. What is the AST? Abstract syntax tree. So what we need to do is collect the abstract syntax tree of this entire code base, or not exactly the entire code base, but of the files. I'll just give you a primer on what the AST means, and then we can figure out what to do next. So in VS Code, or in programming, essentially AST stands for abstract syntax tree. As I mentioned, it's just a structured tree-shaped representation of the code that tools use to understand what the code means, not just what it looks like as a text, right? Because if we have a function, let's say the function adds two integers or two numbers, so you have return a plus b in that function. So what VS Code will do is it will treat it as a plain text, but if you parse it, you will get essentially the entire structure, that there's a function declaration, the name is add, the parameters are a and b for it, the body has a return statement with the binary expression that a and b are added. That's the entire tree that AST will give you, instead of just this 3-line function of function add. Now you might say that is quite similar to what we saw in LSP, right? And that's true. LSP is essentially just a bettered out version of AST, but it doesn't give out the exact AST to us, and we need the exact AST when we are doing the replacement range, because when we are calculating the replacement range, things can be incomplete. For example, if I scroll up at the top, you can see our cursor was before return user. I wanted to get this entire thing. The replace region is not always the line after the cursor. It can be 2 or 3 lines down as well. And there can be a syntax error for that. And if there's a syntax error, LSP will not tell us about that particular line. So what I need to do instead is use AST so that I can correctly calculate that, yeah, return user is the next thing in replace region. And then once we calculate the replace region, suffix is the next thing to calculate. And it's pretty easy, right? I just need to find out if there's a closing bracket or not. So let's go ahead and load up the AST, because that's what this says, right? We load the code parser, which is TreeSetter. We'll be using that, and figure out what text after the cursor might need to be replaced, because this replacement region will allow us to delete a thing and add it. That's what replacement is, right? So yeah. Also, let me go ahead and delete these prefix related stuff. So we've understood the problem of why we need AST. The next thing is actually installing AST. But how do we do that? Well, first of all, let's understand the problems here, okay? So the problem number 1 here is parsing is language specific and is quite painful traditionally. So every language has a different syntax, Python uses indentation, JavaScript uses braces, Rust has lifetimes, all of that. So traditionally you would need to like a completely separate parser for each language, and most parsers, like the ones inside compilers, are slow. They cannot handle incomplete or broken code, which is what you have mid typing, and they aren't designed for real-time editor use. Okay, so what is the solution here? That's TreeSetter. What is TreeSetter? It is a parser generator framework. It is built specifically for editors. It gives us features like incremental parsing, error recovery, uniform API. What are all of these things? Incremental parsing means when you type one character, it doesn't reparse the entire file. It just, the part that changes is parsed again. Because if you parse the whole file again and again, it will take a lot more time than just the part that changed, right? So that's there. Then you have error recovery. So it handles broken or incomplete code, and that's good for us because that's exactly why we are introducing AST in our application, because we want the code, when the state might be broken for the code. Not always we are going to have a proper code. And in our case specifically, that is going to be the case, because if the cursor is midway while typing, let's say, one of the statements, then the replacement region will be calculated, and that means the code will be broken. Then there's uniform API, because every language produces the same kind of tree. So the extension code doesn't need language specific logic. It is just uniform. So that reduces our logic. But the problem with tree sitter is that it needs to know each language rule. Tree sitter itself is just the parsing engine. It doesn't know Python syntax or JavaScript syntax. It needs a formal description of what the language syntax rules are. And for that reason, you have a grammar. If you've taken any compiler course or any such course, you might know that there is grammar. Grammar in programming languages is basically a set of rules, like, the function definition should begin with a def, then there should be identifier, then there's an opening parenthesis, then there's parameters, then there's a closing parenthesis, then there's a colon, and then we enter a block, and then the parameters are going to be all the identifiers, then you have a comma, and then you can have other identifiers, but that's optional. And not just optional, there can be multiple things as well in the parameters, because you're not just going to have one parameter. So all of those things, those are grammars. If you've also watched the video on regex engine, there also I describe a grammar, because those are just a set of rules of how the regex should be written. So the grammar is what will tell the parser that, hey, when you see def followed by a name followed by parentheses with identifiers in it, that's a function definition. Okay. So this is what all of the tree sitter packages will do that we're going to install. There's going to be a tree sitter Python package, tree sitter JavaScript, tree sitter Rust. Let's go ahead and install them right away, because those are the grammars that we need, and since we have already understood it, we can do it. So we'll do npm i-D, then I'll pass in the name, which is tree sitter Python. Then we are also going to do similar thing, but for JavaScript, TypeScript, all of them. So I'll just copy this tree sitter hyphen so that I don't have to type it out. And then I can do JavaScript. Then we have tree sitter, let's say Rust. Then we have tree sitter CPP, and let's see if I can spell this. So we have tree sitter CPP. Then you can have tree sitter C. There's also tree sitter TypeScript, because that's also one. Then there's tree sitter Go, or any other language that you want to support, you can type it out. Maybe the last one I'll go forward with is Java. So we can also have Java. And once I do this, everything will be installed. Notice I've installed this as a dev dependency. The reason we have installed this as a dev dependency is because, all of these packages are going to be added to node modules, and each package contains a grammar.js file that will define the language rules in our environment. Okay. Tree sitter JavaScript will contain the rules where, it defines how a function looks like. Also, now everything is installed, so I can go to package.json and show you that, hey, look, here we have all of the dev dependencies, okay? Tree sitter, all of these things. All of them are also installed in the node modules over here. Let's go to tree sitter JavaScript. Let's try to find it. Here we go. Then there's a grammar.js file over here, right? And here we have all of the grammars defined, as you can see. So that's the thing we'll be using. Also, if you look in the tree sitter JavaScript folder, there's another thing of tree sitter JavaScript.wasm. That is the WebAssembly part. WASM stands for WebAssembly. So here's the problem. Tree sitter core is written in C, but your extension, this VS Code extension runs in VS Code, which is JavaScript or Node.js. So the grammar files also get compiled down to C, because, tree sitter was originally built as a C library. And this is great for native applications like NeoVim, which uses tree setter directly. But in our VS Code extension, we run in a JavaScript runtime. We're using Node.js. So we have two options. We can use native Node.js bindings so that we can call C code from Node via an API. This is what the tree setter CLI and native tree setter npm packages do. Or we can compile the C code to WebAssembly so it runs in any JavaScript environment. And that is WebAssembly. But what exactly is WebAssembly, right? I mean, I understood what we'll do. We'll compile C into WebAssembly. But what is this WebAssembly? WebAssembly is a binary instruction format. You can think of it as a portable, sandboxed assembly language that runs inside JavaScript engines. So, when you have C, it's written or compiled down or whatever you call that process into assembly. And that assembly language is then executed. Similarly, WebAssembly is just the web version of assembly. It can run inside JavaScript engines. So the key idea is you take the code that is written in C or C++ or let's say even Rust, then you compile it, you get a WASM file, you load it and execute it from JavaScript at almost, native speed. It's not native, but almost native speed. And there is the tree setter javascript.wasm file. We need two kinds of WASM files actually. The layer 1 is that the tree setter runtime engine, which is the web tree setter.wasm. This is the core parsing engine, which is compiled to WASM. So it knows how to parse, but it doesn't know any language. This comes from the web tree setter package that we're going to install. So let's go ahead and add npm I web tree setter. Okay. Notice I did not add -d because these are all developer related dependencies. They'll only be needed to generate WASM files in our system, but this web tree setter is the actual thing we'll be using in our application. Then the second thing is the language specific parsers like tree setter python.wasm or tree setter javascript.wasm, as you can see here. So each grammar package will provide this WASM file that contains the compiled parsing rules for that language, as I mentioned multiple times before, and the runtime will load these dynamically. The part is, where do the WASM files even come from? And this is where the tree setter CLI enters the package. The tree setter CLI package provides the tree setter command line tool. One of its job is to compile the grammars into WASM files. It takes the grammar's C source code, runs it through an ECMAScripten based toolchain, then it does a C to WASM compiler and produces the WASM binary. However, as you can see, most grammar packages now ship pre-built WASM files inside their npm packages. Tree setter JavaScript does, as you can see. Tree setter Python also does it. Tree setter Rust also does it. Tree setter TypeScript does TSX and TypeScript both. Then you have Java, which is also present. Then you have tree setter Go, and you also have tree setter CPP and tree setter C. All of them have this WASM file. But if there wasn't for any language, you would use tree setter CLI to do it. So what I'm trying to get at is each package here has a WASM file in the node modules. But sometimes there'll be older packages or older versions of these packages that don't ship a pre-built WASM. And if they don't ship a pre-built WASM, we are in trouble. We will have to use tree setter CLI to do it. But now we are not going to install tree setter as of now. We'll see if we need it. We'll just go ahead and copy this node modules package, the node modules tree setter C, and copy this tree setter C.wasm file from node modules into our normal folder. Okay. And before we move forward, creating the script to do that, I'll just go ahead and also install as a dev dependency something called as @types emscripten. What is this? Well, emscripten is the toolchain that compiles C to WASM. So the web tree setter package uses emscripten under the hood, and its TypeScript type reference emscripten types. So this package essentially provides those type definitions so TypeScript doesn't complain during compilation. All right. So this will be helpful for web tree setter that we've added here. And that's why, it's a TypeScript thing. It's just giving us types. So obviously it's going to be added as a dev dependency. So let's go ahead and create a script. I'm just going to copy paste the script. You can find the script within the repository. So I'll just go ahead and have the scripts folder, and within the scripts folder, I'm going to have the download, or you can call it copy, download grammar.js file, and I'll paste in the script. And this is the script. So what are we doing here? Well, we are requiring or importing file system. Then we're also getting the path. Then we're getting the root directory. So whatever is the root directory, then we go 2 steps behind. Then that will give us the root directory. Then we get the grammars directory, which we are going to create. Over here, as you can see, the if condition exists. Then we have a grammars array within which we have a dictionary or an object. Then the package is tree-sitter JavaScript or tree-sitter TypeScript or tree-sitter TypeScript again, because the file changes. I showed you that tree-sitter TypeScript has a TypeScript and a TSX both. Then you also have tree-sitter Python, Rust, Go, Java, C, CPP. So all of those packages are mentioned here. What we're going to do is go into the node modules, go into this specific package and copy this file. That's the part we're doing here. Then we check, hey, if the file system does not contain the grammar directory, go ahead and create it. Then we copy the web tree-sitter runtime WASM, because I told you that we'll need 2 layers. The first one is the grammar WASM files, and then the web tree-sitter runtime WASM file. The web tree runtime WASM file is the core parsing engine. It knows how to parse, and the grammar files will tell it what language specific thing is needed for the core runtime to parse it. Okay, so what you do here is go to the root directory, into the node modules, into the web tree sitter, so that you can get access to the web tree sitter.wasm file. Okay, and then you check, hey, does this runtime source already exist? If it does, we'll go ahead and copy this file from runtime or from the node modules folder into our normal package, the grammars directory that we created here. A grammars folder will be created in this particular root folder with the name of webtreesitter.wasm. Okay. The next thing we have is the grammar WASM files. So we go over each of the grammar object here. We get access to the package and the file. Then we get the source, we get the destination, and then we copy the file from the source to the destination. The source is again the node modules folder, with the package being this thing and the file being this thing. Basically like, webtreesitter.wasm. Then you copy the file, you've copied ++, and at the end it will just say, hey, yeah, we've copied it to the grammars folder. Now let's go ahead and run it. And I'm going to run it in a unique fashion. I'll go to package.json here. I'll go into the scripts. Then here I'm going to have download grammars. Then we have an npm run download grammar particular command. And we're going to, or not npm run command, sorry. We're going to have node, and then we run that particular script. So we have scripts / and then we have download grammars.js. After this download grammars command is done, we're going to create another command. What it does is post install. Whenever we run npm install in this particular folder, what it will do is, install whatever is required. That's what npm install does. But then this command also runs what happens post installation. And then I can just run the command of download grammars, right? And this will install all of the, or copy all of the packages from node modules. So let's say I clone this repository from GitHub. Obviously I've not uploaded the node modules folder. What do I do then? So I'll run npm install. Node modules folder will now be available. And then I run post install, because it will run after the package is installed. That is a command given directly by package, or you can say the node environment. Then we go ahead and run the download grammars command. Download grammars command is this command, which will just install the Node.js script that we created. And that script will copy everything from node modules into the grammars folder. So just doing npm install will work. So let's go open up our sidebar, and here what I'm going to do is npm install, then hit enter. And as you can see, we run into an error. The error is that we have download grammars.js, or the problem is download grammars.js does not exist. So let's remove the extra s from everywhere. Download grammar.js is the thing. Now let's go ahead and run this again. We have npm I. And as you can see, everything is copied. 9 out of 9 grammars were copied into the grammars folder, which is over here, and we have all of the WASM files. That's good, because if anyone wants to clone our system, all they need to do is npm install. Now what I want to do is go ahead and initialize the AST service. What it does is just creates an AST service every single time. And actually I want to do it in services folder, not just in the source folder. Then I'll have a class AST service. Let's actually export this class. After that, we have all of the variables, and I'm actually going to copy paste it, because AST service is kind of like, it's just boilerplate code. We need to initialize the AST service. There's no logic involved. You just have to paste the same AST service code in place so that you can initialize it and use its content. So I'll paste it in, and then I'll explain what's happening. So the first thing is the grammars directory. That's a string. Okay, what is the grammars directory? And we have the access to it, right? I mean, we've created this grammars directory. Then we have the language cache, and language cache is essentially a mapping from string into tree sitter language. Okay. And this is not a bounded cache, because we do not need kind of like the invalidation groups, or you can say the TTL expiry date. All of that is not required in this cache. All it's required is that you maintain this mapping so that we can quickly access it instead of parsing the language every single time. Now we have to import tree sitter. How do we do that? Quite simple. We'll just do import everything as tree sitter, and then we have from web tree sitter. So that gives us this tree sitter. Then we have the parser, because that's the entire thing. It will parse your language, right? Then you have the current language ID. What language ID is activated? Python, TypeScript, what is it? Then is ready, because have we initialized the AST service or have we not? So whenever the parser is essentially not null, is ready is going to be true. Then we go ahead and expose this isReady variable outside, because many things depend on the AST service. The AST service needs to be ready, and AST service will only be ready if the parser is non-null, because its entire job is to parse and give us the tree, right? So we'll expose this isReady variable outside so that it can be used. So getter is created with the boolean to return, and I actually forgot, even before that we need to have a constructor which will initialize this grammars directory, because everything else is already initialized. So you have this.grammars directory path.join, then you pass in the extension path and the grammars. The extension path, what is it? We are taking it from the constructor. The extension path is going to be wherever this extension is located. So obviously AST service is something that will be created when the extension.ts is called. It's not going to be an inline completion provider or anything, because when we go to extension.ts, context is going to give us the extension path. Nothing else will give us the extension path. Having understood that, let's go ahead and import path. Okay, we have path here, which is giving us the error. So we'll import everything as path from path. And then we can call path.join so that we join the extension path with the grammars folder. And then we can use the grammars directory to find our WebAssembly files. So the first WebAssembly files that we need is the web_treesitter.wasm file, because that should be given to the tree sitter parser so that it can go ahead and initialize this particular, tree sitter instance. And then we'll create the new parser, and we'll just initialize so that we can use the parser again. And this is going to be our function. As you can see, we have an asynchronous function that returns nothing, but it's a promise because, well, it's asynchronous. After that, we have a try and catch. In the catch block, we are saying isReady is false because, if we run into any error, we are not ready. So it's false. In the try block, we are having WASM path is equal to path.join. We take the grammars directory, we take the core runtime WASM file and we join them, and then we give it to the treesetter.parser.init to locate this file and initialize it. So the core runtime file is given. Now we're creating an instance of the parser because this initialize doesn't really return anything to us. So we go ahead and create a new constructor, and this constructor will be based on this file. The core runtime used will be of the web tree setter, and then we're saying is ready is equal to true. So now we're ready to go ahead and ensure that the language is set up, because notice here, what have I done? I've just initialized the runtime. I also want to give it the language, right? The language path. For that, we are going to have another function that ensures that the language is correctly set up and this parser knows about it. And the function for it looks something like this. So we have asynchronous ensure language. Then we take in a language ID, which is going to be of the type of string, and it returns a promise boolean. Well, obviously it's asynchronous, but we return a boolean essentially that, hey, was this successful or not? Have we ensured that the language is correctly set up or not? So if we are not ready or there's no parser, in that case, we are returning false. Then we are saying, hey, where's the WebAssembly file for this language? Okay. And now we are going to create a mapping between the language and the file that's present for them. So we can go at the top and define here the language map, which is going to be a record, a string, comma string. The first one is TypeScript, and the particular file for it is treesetter typescript.wasm. The same for TypeScript React, which is tsx. Then JavaScript React is going to be the same thing because we are supporting JavaScript and JavaScript React both. Notice, why are we pointing to the same file and then we have two different names? That's because the language ID that we're going to get here is going to be dependent on the thing that VS Code extension gives us. The VS Code API is only giving us JavaScript or JavaScript React. We do support JavaScript React. It's just pointing to treesetter JavaScript. So that's why we have, JavaScript and JavaScript React keys. Then we have Python, Rust, Go, Java, C, and C++, and they point to their particular WebAssembly files. Then we go ahead and fetch that WebAssembly file for the language ID. And if there's no WebAssembly file to be found, it will return false. Then we check, is this language cache, does this have WASM file? Well, if the language cache has it, then we're going to check, is the current language ID not equal to the language ID? If it is not equal to, then we are going to set the parser to this language that we got from the cache, right? And we set current language ID to the language ID that we have. And then we return true. So initially, let's say we are at Python, the current language ID is null. If it's null, then we are just saying, hey, does this language ID, current language ID, not equal to the language ID, which is Python? That's true. So we set the parser language to Python and the current language is now Python. The next time, let's say we have another Python file, then we'll check, hey, does this language cache have that Python file? It does. So we are going to check, is Python not equal to Python? Well, it is equal to Python. The parser has already set that particular Python language beforehand, so I don't need to call it again, just an optimization that we're doing, and we're returning true. Then we have a try and catch block where, let's say the language cache does not have it. So what do? We go ahead and find out from the grammar directory that WebAssembly file. So we get the actual language specific WebAssembly file. We load it into treesetter, and then we set the language in the parser. So notice what I did here. Earlier also, when I had to do init, I did treesetter.parser.init so that I could pass in the core runtime. Even over here, we are doing treesetter.language.load WebAssembly file so that we can get the language and we set that language. Because this load is going to give us treesetter.language. And if you look into it a little bit, treesetter.language here is going to be having all of these fields where you have types, fields, you can read the comments to understand what they do. It's a lot more than what it looks like. It just extracts everything and we can set it to the parser. So now the parser knows what language it needs to parse. The current language ID is also set and we return true. Notice the language cache is also set up. So that's good. So that's all we need to do to ensure the language. Once we've ensured the language, what we want to do is parse the tree. So we can create a function to do that. And the function is going to look something like this. Quite simple. All we are calling is parse sync. It's a public function. We take the code which is of the type of string and it returns a tree or a null value. If we're not ready or the parser is not there, we return null. Otherwise, what we do is this.parser.parse and then we pass in the code. So the string format converts into this tree object. And if we see the tree object, it returns a language, copy, delete, root node, all of that. Because I told you we're going to get a tree, right? If we're getting a tree, we're going to get the root node, and from the root node we can walk, and we also get a function to walk along this tree so that we can make other, get other nodes. Now we have that. The next thing we want is another function that will allow us to use the parsed tree, and we use the parsed tree so that we can run a callback function on it, because obviously with just the tree, we want to use the tree, right? So what we can do is create a function called with parse tree. What it does is takes in the code, calls parsing so that it returns the tree, and then we can have a callback function which is executed, right? And that callback function can run anything that they want so that they can make use of this tree. And this is how it looks like. With parse tree, we're not going to get a language ID. We don't need that. We just need code, which is of the type of string, obviously, because we need to parse it to parse sync. And then we get a function, a callback function. So the client will be executing something like this.ast service dot, and then they'll pass in with parse tree. They'll pass in the specific code. Okay, we have the code. That's good. And then they can pass in, okay, I can't seem to rewrite code, but anyways, they get the tree and then they have a function, and using this tree, they can do whatever they want, and we'll go ahead and execute this function that they have. This function is what is going to be this function, okay? It has treesetter.tree and it returns t, and we are again returning t or null. So we get the tree from parse sync. If there's no tree returned, we return null. Then we have a try block just so that, if this function runs into any sort of error, we handle it. Then we are returning that function of tree, just calling that function. And once that's entirely done, we go ahead and delete the tree. That's quite important. We delete the tree. The next thing I want to do is just dispose of everything that we have. And I can do that right here. Dispose just deletes the parser. It sets parser to null. It clears off the language cache, and is ready is set to false. That's looking good. We can go to extension.ts so that we can initialize this AST service. So let's have let AST service, which is of the type of AST service. We import that. Then we have undefined because, it's not defined. And then we go ahead and initialize the AST service. So in the activate, once we have the output channel appended, we are going to do maybe over here before the inline completion provider, I'll do AST service is equal to, and then we create a new AST service. Okay. Then we pass in the extension path, and I told you the extension path is going to come from the context. So we have context dot extension path. Cool. The absolute file path of the directory containing the extension, shorthand notation for blah, 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 blah. Okay. Now we can go ahead and initialize this AST service. So I have AST service dot initialize, then it's returning promise or void. You can either do dot then or you can await it. But what I'll do is once, this is executed properly, I will go ahead and do output channel dot append line, and I'll append the AST service. I have AST service initialized. Then we go and check if the active editor is present. If the active editor is present, then I would like to ensure that the language is set up, right? Because once we have the active editor, that means the document is open. I know what language the user is dealing with. I can use it. So I have constant active editor, which is equal to vscode.window.activeTextEditor. Then I'll check if there is an active editor. In that case, we are going to have AST service dot ensure language, and I pass in the language ID, which is active editor dot document dot language ID. Awesome. So that looks good. The next thing I need is whenever the document changes, I would like to know so that I can update this AST service.ensure language. And to do that, we know what to do. We have vscode.window.onDidChange active text editor. If that happens, we know that the file or the editor has changed. So I get access to the editor here, and I'll check if the editor exists. And let's say the AST service is ready, because if it's ready, I want to change and ensure that the language is set up, right? So I have AST service dot ensure language. Then I pass in the editor dot document dot language ID, and that's pretty much it. So we preload the languages when the active editor changes. That's what we're doing here. So that means the AST service should be initialized. The next thing I have to do is use this AST service in replacement region stage. So I'll have a context stage newly created, which is region or replacement region stage dot ts, and then I can export this class of replacement region. And by the way, I think AST service class, okay, it's exported. Okay, good. I thought I didn't import it. So export class replacement region stage. Then we are going to have the constructor, which takes in the AST service, right? Because replacement region stage will use it, which is used in context gatherer. Context gatherer is called an inline completion provider, and inline completion provider is called an extension.ts, and extension.ts has the AST service. So we'll be using that. Now we have private read-only AST service, which is of the type of AST service. Okay. Now we'll go ahead and call the compute function on it. So we get the document, which is vscode.text document. Then we'll import everything as VS Code from VS Code, the standard code. Then we'll, fix this document. Then we get the position as well, which is going to be VS Code.position. Then we're going to return from here a replacement region. And that's a type we'll have to create in types.ts. What is this replacement region? Well, replacement region is going to contain the text, which is the text content of the region that may be replaced, and then the range in the document covering the replacement region. So two things, text, let's have that, export interface replacement region. Then we have the text, which is going to be replaced, then the range of what's going to be replaced, and we're all set. Now we can have this replacement region imported. Then let's try to return it from here. And what is our philosophy when we are coding up the replacement region stage? So what is our philosophy when we are doing replacement region? What are we trying to do? And here's the flowchart of what we are trying to do. We read the text after the cursor on the current line. Okay. Is there any non-white space text after the cursor? Yes, there's code after cursor. So we check, does this text look like an incomplete statement? How do we know it's an incomplete statement? Well, this thing. This will help us determine if it's an incomplete statement. We first check, hey, are there unclosed brackets? Example, foo, bar, it has one opening parenthesis, but it was never closed. So the parenthesis should match. Well, no, there are no unclosed brackets. So we'll check, does it end with a continuation operator like, plus, minus, double ampersand, double or sign, or let's say it's plus equal to, minus equals to, any of that? No. Well, then we'll check if it ends with backslash, and this is not Python only, actually, we changed this a little bit. We are going to check if it ends with a backslash for all the languages, because there are some languages that also support backslash continuation. Because if in Python, if you want to do anything that continues something, for example, hi is equal to, let's say, a string. So we have string plus, and if you want to continue on the next line, you can put a backslash and then go on the next line and continue it. That's how Python works. And we can do that in Python, but there are other languages that support that too. Then we have, well, if it's short, that means it's under 20 characters and it's missing a terminator, like let's say colon, semicolon, or there's a opening brace or a closing brace, or it has a question mark, or it has a colon, because these are terminations, right? I mean, that's a ternary operator, sorry. In that case, what do we want to do? And this is not just non-Python. This is used elsewhere as well. Then, yeah, if that's not true, that means statement looks complete. We don't want to extend it. What does that mean? Well, when we're trying to calculate the replacement region, we might have something like this, right? We're trying to return something, and let's say I return and I'm on a new line. So I just checking just one part is not enough. I want to extend it down to wherever the statement ends. And that's why what we are doing is, if you look at this example, we are checking if there's a curly bracket. If there is, that means we should extend. And to extend, find out what extension we need to do, we'll be using AST for that, because it's possibly in an error state. LSP is not going to give us the exact things we're looking for, but AST doesn't really care that, yeah, it's an error state. So we can use that. I told you that's the benefit of using tree setter. So let's go ahead and have these checks in place. So the first thing I want to do is check that, hey, the cursor after trimming, does its length is its length greater than 0? So the first thing I'm going to do is find out, hey, what is the text after the cursor? Because that's what we are interested in. If my text is over here, I want to grab this entire thing. If my text is over here, I want to grab everything after that equal to sign. So I'll have I would need the current line. So first I'll create a variable to get the current line, which is equal to document.line at. Then I pass in the position.line.text. Then I'll do text after cursor equals to current line. Then we slice it. Then we pass in the position.character, and that gives us the text after the cursor, because whatever is the position.character, after that everything is going to be the text after the cursor, right? Then we'll go ahead and check if we should try the extending capability. So we'll create a variable should try extension. That's the worst variable I could come up with, but yeah, you can use that. Then we say text after cursor dot trim dot length. Is its length greater than 0? Well, then we should try extension, but there's another thing, which is this should extend region. And that is all of the checks that I talked about right now that we're going to do. And we're going to pass in text after the cursor and the language ID, because we do need to, or not language ID actually, just this much is enough because we have set up the language properly. Now let's go ahead and have should extend region function. Is going to be a private function because it's just a helper function. We are getting the text after the cursor, which is going to be a string. And then we check, hey, what is the trimmed value? Or actually, let's just have this dot should extend region here, and we can check the trimming here itself so that, it helps us out to keep our code clean. Then we have text after cursor dot trim dot length, or not length. Let's do if trimmed dot length is equal to 0. In that case, we'll return false, because ultimately we want to return a Boolean value from here, right? Should we extend the region or not? If the length is 0, we don't want to extend anymore, because the line is empty. What are you going to do trying to extend it? You're just going to get, some other code base that we're not really interested in. So that's an important check. Then we go ahead and check if the brackets are balanced. How do we do that? Well, we're going to use regex for that. And this is the regex we have for opens. What are we trying to check here? Well, we are checking, first of all, this is a character group. So we're trying to match any of these characters, which is an opening parenthesis, this particular character, which is like the left bracket, and then the left curly bracket. we are trying to check if the trimmed contains any of them. And then we have /g at the beginning. What this means is that all the variables or all the matches related to these 3 brackets should be there. So if we find out one curly bracket open or one parenthesis open, then what we want to do is count all of them and find all their occurrences essentially, and then get the length. And similar thing will be done for closed as well. So same thing is done with closed, where we pass in the closing bracket, then we have this particular closing bracket, and then the curly bracket closing bracket, and then we are just going to check if open is greater than closes, because if we open more than we close, then we want to extend the region, because the user might have gone on a new line. Let's say they have something like this, where I'm returning, let's say a tuple, and I go on to the next value. Let's have A, B, C, so we want to extend in that case. So that's done. The next heuristic that we have here is, does it end with a continuation operation? So we do need access to all of these endings that are possible. Mine is not an exhaustive list, but you can go ahead and create your own. But this is what I have: a comma, a plus sign, a minus sign, then an asterisk, a division, then an ampersand, or one single or, and dot, then an arrow, a backslash, equals to, plus equals, minus equals, asterisk equals, and so on. You'll find all of them, including a colon. If any of these cases are there, what we do is, for constant ending of continuation endings, we go over each of these elements and check, does the trim ends with any of these? If it does, we return true, because we want to extend, right? That's the goal that we have. If we have something like this, let's say return hi or let's say return should try extension and then we pass in, let's say, true, So this is not an invalid statement, but we are going on a new line, or actually it should be something like this. It's not an invalid statement. So why is this not allowed? It's allowed. So that's how we are checking if you want to extend it. This is not very concrete, but it gets the job done most of the times. And AST is only called when it's really needed. The next thing we have to check is it short, under 20 characters, and it's missing a terminator, like a semicolon or this, if it's missing any of that. So we check here, hey, if the trimmed dot length is greater than or less than the 20 characters, then I want to check if it's ending quickly, or it has any of these things. So I'll have statement terminators for them, and I'll just paste this in. What we have is statement terminators is equal to a semicolon. Again, the same thing. If the statement terminators, any of them ends with this terminator, then we say that it's fine. But if it does not end, then we return true, because we want to extend the region. And the language ID is not equal to Python. So that's important. The language ID should not be Python, or we can skip this. I think it should be fine. Then we're all set. So now if any of these are not true, we return false. Okay. So this is all just heuristics so that we can find out if the region should be extended or not, so that we can call AST as less as possible. Because why do we want to do unnecessarily computation? Once we have that, I'll go ahead and check if should try extension is true, and let's say the region text. And actually first I'll have to go ahead and create the variables. The variables are going to be one of these. So not one of these, all of these. So we have region text, end line, and end character. These are all defined as a certain variable, but these are essentially what's going to be returned from here. Region text is the text that's going to be returned for replacement region. Then we have end line, what line are we at and what is the character. They're set to default values, but obviously once we try the extension, they'll change. And if they don't change, well, the region text is just going to be text after the cursor, right? We don't extend it. So that's the thing. End line is going to be, well, if we don't extend it, whatever line we're on, and the end character is going to be whatever is the current line. Cool. Or if you want, you can remove this region text. You can set let text after cursor equal to this thing, and then you have one less variable to worry about, and you can check, hey, does the text after the cursor is less than, let's say, 200 characters? Because if the text after the cursor is less than 200 characters, and I cannot find text after the cursor because it needs to be length. So the text after cursor's length, if it's less than 200 characters, that means we don't want to extend it anymore. Or let's say if it's greater than or equal to 200 characters, we don't want to extend anymore because we have found enough characters to fit into our replacement region. Our replacement region cannot be very big. So we don't execute it, we just put the current line in. If you want, you can increase this threshold, but that's a thing. 200 characters or more, I don't want to go further in. So that's good enough. That's our max region characters. Then what do we want to do? We want to extend to statement end. Let's see this diagram again. If it's an incomplete statement, we check if the text is already at the 200 character limit. No, so there's room to extend. So we use the code parser, which is the AST, to find where the statement actually ends in the next 1 to 3 lines below. We are not going very far, just 1 to 3 lines before. And then we check if the parser found a statement boundary. If the parser couldn't find one, it just uses the current line. If it does find, then it does the full extended text fit within 200 characters and 3 lines. If it does, then we use that as the extended region and return that. Cool. So let's go ahead and define the function to extend to statement end. For that, we are going to use the AST service. And we'll also have to define the AST analysis.ts file. Let's go ahead and create AST related stuff. So maybe you can create a folder called AST and have all the AST services within it. And I accidentally pressed enter. Let me rename this. It should be an AST analysis.ts. And here we're going to create a first function called export function find statement end. What we're trying to do is just find the statement's ending thing. What we're going to get here is tree setter. So we'll get it from tree setter.tree. And now we have to import tree setter just like we did in the AST service. We just copy the same line and put it here. Then we are also going to get the cursor. Where is our cursor? Well, what's the row number, which is essentially going to be the line. And then there's a column number, which is going to be the position. Okay. Once we have both of them, we can go ahead and also set the return values. What we're going to return from here is an end line, which is going to be a number. Then we are going to have the end character, which is also going to be a number. Or we're going to return a null value because it makes sense, right? We're trying to find where there's a statement end, where the cursor begins. And for that, we need the end line and the end character. So what is our strategy here going to be? Our strategy here is, let's understand this with an example. Let's say, I have something like this, where I have constant result is equal to, and let's say a long function, and the function is called, and it's called on a new line, right? So you have something like this, or let me put another comment, something like this. So our first argument is specified here. Then the second argument is also specified here. And then on the third line, it just ends. Our cursor is somewhere over here, the second arg. So what the tree setter will see is something like this. There's a lexical declaration. Then there's a variable declarator. Then there's a call expression happening. Then we pass in our first argument and the second argument for the function. So, as I said, tree setter is just going to create some sort of tree where it tells that there's a variable declaration happening. Within that, there's a call expression. Then there's things passed in like the parameters or the arguments. So what do we do? Well, we'll go ahead and find where our first argument is, right? Then it walks up. It will see where the lexical declaration is present. So it notices, okay, or let's say our cursor is at second argument, okay? Let's say my cursor is present exactly where it is right now. So I try to go up and then I find out, okay, so this argument is not there. This is also an argument, so that's not going to be the statement beginning. Then we find out, oh, there's a long function. So that's also not something we care about. Call expression, nah, because we just want to find out the lexical declaration. And then we find out that the variable was declared because there's an equal to sign. And then we find out, oh, there's a lexical declaration. So we grab this entire lexical declaration, we stop there, and we return the end of this lexical declaration. That is going to be our approach. Just to summarize what our approach is, we first find out the smallest syntax node that contains the cursor. So second argument, that is the smallest node, or like the lowest node that contains the cursor. Then we walk upwards until we reach a statement level construct. Statement level construct is this thing, right? Constant result is equal to. So we walk up the tree until we find out this particular declaration, and then we return the end position of that statement. So I know this is a statement, and AST already gives us access to where that position ends. So we go ahead and return the end, and we have this entire thing fetched. That's our approach. So as I said, first we need to find the smallest position. How do we do that? Well, for that we'll create a function because it's going to be recursive. We are traversing over a tree, right? This is going to be a node where the type is treesitter.tree. Then, or let's say treesitter.node because it's a node, right? And it's going to return nothing. And what we do here is check that, hey, does our node contain the cursor's row and the position? And let's create the variables up here. Let's say constant cursor row is equal to cursor.row. Then we have constant cursor column, which is equal to cursor.column. And yeah, that's pretty much it. Let's also create the root node, which is equal to tree.root node, because treesitter will give us root node. We already saw that beforehand. Then what we're finding is, does this node that we have contain the cursor's row and the position? Well, if it does, then we want to go ahead and find out the smaller node, right? We'll go over its children and try to find out if there's a smaller node over there. In our example, what that we had, which looks something like this, or let's make this a little bit more complicated. Let's say we have another function called here where the second argument and the third argument is passed in, okay? And our cursor is present at second argument. Cool. What do we do here? Well, we'll see that now the structure has changed. There's a lexical declaration, then there's a variable declaration, then a call expression. Within the call expression, we have the arguments, the first argument, then there's another call expression because there's a function call, right? And then you have a second argument identifier and then a third argument identifier. Cool. So we find out that the identifier nested argument 1 is present here. Cool. So we found out the second argument. That's what we want to do using find smallest. How do we do that? Well, we first check that, hey, does the node contain the position of the cursor? If the node contains the position of the cursor, that means we have to go deeper into its children. Otherwise, it does not really have that, right? I mean, there might be other things that are present within the text that is being returned or within the tree that's being returned. So I just want to find out the piece where the cursor is present. Okay, this is the node where the cursor is present. So I go deeper. Okay, second argument is not present here. In another function, it's present. So I go over here and yeah, I found out second argument. So that is the smallest possible node that contains second argument or that contains the cursor. So I'll have to create a helper function to help me find the cursor position. Let me go ahead and paste it outside of this function. So here we have contains position. Notice you have not exported it because it's a helper function. It will be used elsewhere as well. And then we have a node, a row, and a column number, right? Because to get the cursor position, if it's present or not, I need the line, the column, and the node. Then I find out the node starting position and the ending position. And then I just check if the row that we are getting, the line number is less than the start row or the row is greater than the end row. That means you want to return false because that node does not really contain the cursor position, right? I mean, if I have some other code here, let's say hi is equal to something, that was defined here, or let hi is equal to something like that is defined here. This declaration does not really contain the position. So the start position of the node, which is over here, is less than the start row, right? The starting row is over here. The line number is 17. Here it's defined on line 15. So 15 is less than 17, we'll return false. Or it can be defined outside of this. So it's line 25, line 16. That's what we're doing with this. Then we check if the row is equal to start row and the column is less than the start column, we return false because the start row matches, but the column is far away, it's defined somewhere over here. So the line is the same, but the column is outside of the range. That does not really make sense. We just return false for that as well. Then we check if it's equal to end row and the column is greater than equal to the end column. So the end line matches, but the column is outside. That does not really make sense either. We ignore that part. And if all of these don't return false, we are returning true because the cursor contains the position. Then I'm over here where my node start position and the cursor start position, the row and the column matches. Now I can go ahead and use this function over here. I'll check if the contains position is true, then we pass in the node, the cursor row, and the cursor column. If it contains the position, well, we know this node contains the cursor position, then I want to find out the best node. The best node is the smallest node. How do I find that out? I'm going to have let best node is equal to, or let's say it's of the type of tree sitter dot node, or it can be a null value, and by default it is a null value. And then we check, hey, best node is equal to node. When? Well, only when the best node is not present, or the node span is less than the best node span. What is node span? Node span is the number of characters in the node. It is the difference between the end index and the starting index of the node. The end index is the index of the last character in the node, and the starting index is the index of the first character in the node. So span is just the number of characters in the node, and the span is used to determine the size of the node. And we are going to create a helper function for that as well, because node span is used in other function as well. So we have treeSetter.node, it's going to return a number. And as I said, it's just the difference of end index and the start index. So I've returned node.endIndex minus the node.startIndex. And then I find out that, hey, if the node span of this node is less than equal to the node span of the best node, in that case, the best node is equal to the node itself. What have I done with this? I've checked that the length of this node is less than equal to the best node, because that's the entire point, right? I want to find out the smallest node possible. So I just take the smallest node, which is the end index. So let's say, coming back to our example, or maybe I removed it again. But in our example, when I had the function, or let's take this example, this is our statement. So if condition is present, I want to extend it, right? My cursor is over here, I want to extend it. So in that case, I'll find the smallest node that is present. The smallest node in this entire tree that's given to us is, well, not this function, not this if condition, this if condition. How do I know that? Because the length of this if condition is smaller than the length of this if condition, which is smaller than the length of this if function. And how did I calculate the length of this function? Well, take the end index, take the start index, and subtract it. That's the number of characters. That's what I did here. Then what I want to do is recursively check the children to see if any if any of the nodes provide a smaller node that more tightly encompasses the cursor position, because that's the point. I want to find the smallest position. And notice I do this inside of the if condition, because if this node, this if condition contains the position, only then do I want to go into this. Otherwise, I'm going into every possible, you can say, block, and that's not really what we want. Because if this contains the cursor position, this will contain the cursor position, or this will contain the cursor position. So I'll go layers deep. Then I find out let I is equal to 0. I is less than the node.named child count. Named child count, what is that? I'll come to it. So we have I++, and that is our for loop. So named child count is in tree sitter, like every AST node can have children, but not all children are treated equally. Named child count is essentially trying to tell us, hey, how many semantic children does this node have? That's what named means, semantic. So it excludes like the punctuations and the anonymous grammar tokens. So let's say if we have something like a binary expression, in a binary expression, you have a left thing, then you have an operator in middle, and then you have a right thing, right? For example, a binary expression can be LSP is equal to 1, 2, 3. That is a binary expression. You have a left hand side, an operator, and the right hand side. So the left is named, the right is named, but this operator that's used is not named. It is an anonymous token. Or let's say we have LSP plus 1, 2, 3. Even then, it's just something like binary expression where you have identifier 1, then a plus symbol, and then you have identifier 2. The number of named children in this is going to be 2, but the child count is going to be 3. Because we do have 3 children in this, right? But we only care about the named child counts because we want to ignore all of the operators and stuff present. Because think about it. I mean, what am I going to do knowing there's an operator, right? I just want to get the named thing because then I'll know that, yeah, this is an if condition. This is another if condition, and then there's a function. That will help me better than just knowing, oh, there's an operator. That doesn't give me much information. So now I'll go ahead and find out the child. So I'll say node.namedChild at I. I'm again trying to just get the named child node because, we are traversing over the named child count. Obviously, we'll find out the named child position at I. So let's say named child count is an array. Think of it as an array. So in the array, we're going at the index position. That's it. Now, I'll go ahead and check if the child is present, it's not undefined, it's not null, then I'll go ahead and find the smallest of that child, right? So within this function, it will give me, yeah, there's an if condition present, that's a named child. I'll go within this if condition. Then I find this if condition. Then I'll go within its child, which is this declaration. And within this declaration, I see, okay, well, it doesn't really contain my cursor. So this is going to be our best node that's returned because my cursor was over here. Great. That's how we find the smallest thing. So I'll go ahead and call find smallest. I pass in the root node and then I can check, hey, does the best node now exist? If there's no best node, I'll return null. I did not find the statement's end. So with this, we have completed step 1 of tree sitting, right? I mean, we had to find the smallest element. Now, the next thing we have to do is walk upward until we reach a statement level construct. And that's pretty easy, right? We have the current node with us, and this is kind of like the lead code questions. This is a tree, so it's going to be one of those, but we have tree sitter dot node, which is going to be equal to the best node. And then we go over the parents of this current node and try to find if there's, any of the construct level statements, and we're going to hard code the construct level statements. So we have while the current dot parent is true, and we say that the current dot parent is not equal to the root node, because if we reach the root node, well, we've reached the end because the root node is probably not going to have the parent. It's called the root node for a reason. Then we have constant parent type, which is equal to, and then we set current.parent.type. That is the parent's type. The reason we're getting the type is I want to stop at a statement level construct, right? And what is a statement level construct? Well, first of all, I told you that the nodes are of different types. You can have an if statement or a for statement or a while statement or a return statement or any of these statements. These are all statement level constructs. So I want to stop there. For example, in this case, when I gave you the example, I told you we want to stop here. We want to get this entire thing, right? My cursor is over here. How do I know that this is an if statement? The node type is going to give that to us. Every node is going to have a type specified, And that's what we're trying to find here, current.parent.type. Now we go ahead and check if the parent type is equal to, and it's going to be a lot of hard-coded values in. So let me paste this in. So if the parent type is equal to expression statement, return statement, variable declaration, lexical declaration, assignment statement, if, for, while, and you can find out many, because this is not an exhaustive list. I've missed out on many, but you can find whatever you want. Wherever there's a statement or a declaration, we found out our thing. So what we do is current is equal to current.parent, right? And then we just break out, because we found out the expression statement. So let's say I was over here, my cursor was over here. It found out that the smallest thing that contains the cursor position is this. We found out that this is essentially the statement, right? So it will just set current is equal to current.parent and break out. So we get the exact possible thing. And then, once we've broken out of the for loop, we just have to return, because now we have the correct node with us. It's the if statement. And once we found out the if statements, it's easy for us to find out that, this the end of this statement is over here, because that's the data that AST is going to give us anyways. So I'll go out of this while loop and return the value. The value is going to be end line, which is current node dot end position dot row, and the end character is going to be current dot end position dot column. Also, let's say if this if condition is not found, well, what will happen then? We run into an infinite loop. So what I do is find out that the current dot parent is specified. Current is equal to current dot parent. So if we don't find anything, we set current equal to current.parent and break out. Otherwise, it's the same thing. Or what you can do is something like this. Current is equal to current.parent regardless. And then you just break out. Both of them will work. So that's our find statement end. And we use that in replacement region so that we can find out the ending replacement thing, right? Now, first of all, what I'll have to do is take this AST service that's given to me and use the parse tree so that I can have a callback function. So I'll have something like this dot AST service dot with parsed tree. Then I'll pass in the code. And what is the code going to be? Well, the code is going to be wherever is the starting line. The starting line is wherever the cursor's position is. That's going to be the starting line, and the ending line is going to be whatever is the document's entire line count, that. Or it can also be the start line plus the maximum number of lines that we go up till, which is around 300 or 200. Yeah, 200. And instead of making this too messy, let me create a private function, a helper function that I can call here, which will be much better. So let me go ahead and do private extend to statement end, and it's going to return all of these things: text, end line, end character, or a null value. Then we have the document position, max number of characters that are allowed, and the max number of lines. Let me call this extend to statement end over here. So this dot extend statement to end is called. Then we have the document, then we have the position, then we have the maximum number of characters that we can go until. Let's say that's 200. And maybe we can also subtract the text after cursor dot length from it. So whatever is the text after cursor, we subtract that by 200 because that's the maximum number of characters we can catch. And the max region lines is going to be 200 because max region lines is just this thing, 200. So extend statement to end now, and now we can go ahead and call the AST service so that we get the access to the tree. So we have returned this dot AST service dot with parsed tree. Then I get access to the code, or actually I have to pass in the code, and the code is going to be wherever we start from until the kind of the end. And we've written down the code for it multiple times before, even in the prefix stage. If you remember, collect lines to cursor, that function is going to be quite similar. So I'll paste that in. Here we go. So there's a start line, which is equal to position.line. Then we have an end line. The end line is either going to be start line plus maximum number of lines that are possible, right? So we start at a particular cursor line and then we go up until 200 lines. That's one thing. Or we can have document.line count -1, whatever is the minimum value of them. I obviously want the minimum value because document.line count is the brute forced thing. Because I mean, if we don't have any other option, start line plus maximum lines, goes up until quite a lot. Or actually, I just realized the maximum number of lines cannot be 200, it should be 3. The characters should be less than 200. That's what we did here. But the lines, we told in our diagram as well, there can only be 1 to 3 lines. Sorry about that. We can only have 1 to 3 lines. So let's say start line plus maximum number of lines exceeds the document line count. In that case, we don't have to check anything. Obviously, we'll take this. So let's say, for example, I'm on line 76, okay? And it goes ahead and checks this line. Then it determines that, okay, maybe I need to check next line as well. And then it does another line, and then it does another line, 3 lines, right? And that's problematic because 79 and 78, obviously we'll take the lesser one. We don't want to go out of range. Then what I have is lines array, and then we go over start line, go up until end line and add that line 2 lines. And then we calculate the region text by just joining with a \n. So I'll pass in this region text. Then I get access to the tree itself. And yep, we're all set to use this tree to give to the AST analysis function that we exported out. So we're going to have constant result is equal to find statement end. Okay. And now we can pass in the tree. Then we pass in the row and the column number. The row is going to be 0 and the column number is going to be, well, the position dot character. Because when we want to find the statement's ending position, we have to give it what line do we kind of start from, what column do we start from. We've provided all of the rows as the kind of the region text, and we know over here it is going to convert the region text into the tree format and return that so that the find statement end can start. So essentially this tree is being given, right? And within this tree, the row is going to be 0, right? We start cursor 0. Then we check if the node contains that 0 and the column position. If it doesn't, we do our calculation. Then we check if there's no result. If there's no result, then we are going to return null. We did not find anything. We cannot extend to statement end. But then let's say we do find a result, then I just have to calculate the absolute end line, the absolute end character, and append all of that into the output text. And all of this is quite straightforward. So let me paste this in. We have absolute end line, which is equal to start line plus the result dot end line, right? Because we know that the end line is going to be, either 0, 1, 2, 3, 4, what is it? So we take the start line and then we add 1 or 2 lines to it. And that's going to be the absolute end line. The absolute end character is just returned to us. Then we have text equal to document.line at start line. So that gives me the entire line at that particular document. We get its text. Then we slice off starting from the position.character, right? Because that is our cursor position. So we found out the entire line. What I want to do is get the text after the cursor. That's what I'm doing here. And then I do start line +1 so that, I don't include the start line again because I just trimmed off the start line. For example, think about it this way. I have something like this, so I go and fetch document.line at. So I have to get this particular line, right? For that, I do document.line at .text.slice. So I only get this much. And then I move on to the next line. And then I keep going until the absolute end line and then append everything to text. that is our replacement range. Now, if the text.length is greater than the maximum number of characters that's allowed, we return null. Otherwise, we return this entire statement, and this dot extends to statement end gets that result value. Now I can take this, let's call this extension, because this was called should try extension. And then I can do if there the extension is present, then I'll have region, or let's say cursor after or text after cursor, which is equal to extension dot text. Then I have end line, which is equal to extension dot end line. And then we have the end character, which is equal to extension dot end character. That will give me my values. I can then pass or return the text to be region text or text after cursor. Then we have the range specified, and for the range, it's going to be a new VS Code dot range created, right? Because I have my own values now. The starting value is the position, the position that is returned here. Then we have the ending value, and for the ending values, we've calculated where to end. So we pass in the position here, and then the line number, which is going to be the end line, and the ending character value. Perfect. That's all there is. Now let's go ahead and call this in context gatherer. So I'll need access to this private read only. Let's call this replacement region, which is going to be of the type of replacement region stage. Then I do this dot replacement region is equal to new replacement region stage. And then let's call this replacement region stage. Then I need to pass in the AST service, which I'll get access to from here. So let's have AST service of the type of AST service, and wherever context gatherer is called, I'll have to update that. But for now, I'll pass in the AST service like that. Now let's go ahead to our inline completion provider. That's where I believe context gatherer is called. So there we go. Then I'll go ahead and fix the error shows up. That's good. Then I'll have AST service passed in. I'll take it from the parameter, or the constructor arguments, whatever it's called, AST service, and the type is AST service. Okay, good. And finally, we can go to the extension.ts and pass this in. This is terrible code, by the way. You should avoid doing this whenever possible. This is dependency drilling. There are a lot of solutions for this, but I'm not just doing that because that will take a lot more time to set up. But after that, it's easier. That's more maintainable code. But anyways, we're all set. We can go to context gatherer and call this replacement region. So I have edit history with me. I have prefix stage. I'll have replacement regions. Let's just call it replacement region, which is equal to this dot replacement stage dot compute. And then I'll pass in the document and the position. So I have the document, I have the position, and that's all. Let's also take this build prefix out from here, and here call constant. Let's call this prefix is equal to await this particular thing. So that's part 1, that's part 2, and I believe this was part 6. So let's put it at the bottom. And for now, what I'm going to do is take this replacement region and kind of log it out, because yeah, that's good. Replacement region.text will be logged out. I just want to see if it works. So I'll run, start debugging. Hopefully no errors are found. Everything works smoothly, and it doesn't. Let's see the errors. It says namespace WebAssembly has no exported member imports. To fix this, maybe we can just go to tsconfig.json, and here we have the library set to just ES22, right? We can also specify DOM over here. And now if I kind of do run start debugging, it works. So adding DOM removes the errors. Why is that? Well, TypeScript only knows the types you include in this tsconfigs library folder. Now without DOM, common global types like node, document, event, text, they don't exist. Only ES22 related features are present, like import and all of those things. Now, some tree sitter VS Code typings reference those names, especially node. So TypeScript throws errors like it cannot find the name node and all of those things. Adding DOM basically loads up this file that makes those global variables appear or available so that the tree sitter can use all of those things. Now coming back to this part where we have our test.ts, we can see AST service is initialized. That's good. Now I would like to calculate the region. So I have a result. I hit enter and it says prefix correctly is result plus equals chunk. Now it's not prefix, it's replacement range. We did not change that, but we do get result plus equals chunk. What if I do it on if condition? So we get this if condition properly as well. If token.is cancellation requested, then we have this .api client.cancel break. The entire if statement is properly fit in. That's amazing. And as you can see, the suggestion by the model is also pretty good. It correctly identifies that we need this .api client.cancel blah blah blah. So that means the replacement region is also working. Now the next thing, or if you want, you can go ahead and try multiple things more. It should work. That's the entire point of AST. It just gets the starting and the ending positions. That helps us a lot because all of our complexity is hidden away by the AST parsing. Now, the next thing is calculating the suffix. Once we have the suffix, we can move on to type definitions and cross-file symbols, which should also be quite easy. And I think cross-file symbols also depends on AST. But anyways, we will use the replacement region to get a small window of code that comes after the replacement region. And for that, we are going to have the context stage, which is the suffix stage.ts creator. Just like prefix stage and all the other stages, we are going to export this class. And let me remove the debugger. Then we have to call this as the suffix stage. And now the function can be created within this. And as I've mentioned many times before, suffix stage is quite easy. All we have to do is create one function and we only need to get the ending brackets, nothing more. So let's go ahead and create that function. It's barely going to be 30 lines of code overall. So we'll have build suffix after region. And then we're going to take in the document, which is going to be vscode.text document. And then we'll have a position, which is vscode.position, just like everything else. Then we're going to import everything from vscode as vscode. And let me just type in vscode. Okay, great. Now that we have this done, the next thing I have to do is figure out how should I, get the suffix after region. I've told you that is just the closing brackets that we want to get. So if we have the replacement region looking good, we'll go ahead and look ahead maybe 1, 2, or 3 lines. And then we'll try to see if, if we remove any brackets, any closing brackets from the line, is it empty? Because if it is empty, that means we have the bracket line and that's good for us. But if we don't have an empty line, maybe we overall have an empty line and we want to continue that. Think about it this way. Okay. So let's say, by the way, first I need to do from VS Code so that the highlighting comes back. Okay, great. So let's say this is my region. Okay. My cursor is at build suffix after region. So my cursor is over here. It notices that the replacement region is this entire thing, right? Because it's an entire function and that's how we have defined replacement region to work. Then it goes to the next line and it sees, okay, there's a closing bracket. If I remove this closing bracket, it will be an empty line. If it becomes an empty line, that is going to be our suffix. All we need is the closing bracket. And again, to re-emphasize what I'm saying here, the reason we only want to get the closing brackets is because we don't want to get any piece of code, because the way we'll be structuring our prompt is like this, right? We have the prefix passed in, then a replacement region, and then the suffix. But in the suffix, if we go ahead and tell that, hey, listen, the code after the prefix is this particular suffix, it will try to predict the entire suffix itself, because the natural thing for the model to think is that, hey, we have the prefix, the most ideal, the best prediction is going to be the suffix, and the suffix is essentially given to the model, so it will cheat. It will just predict the exact thing that was present in the suffix. So we are giving it a closing bracket to notify that, yeah, the function ends, or the function does not end, or the if block doesn't end. That's what we are trying to do. And if it wants, it can go ahead and add other stuff, considering that the function is going to end, so it can try to predict the entire end of the function. Or, if the function is not ending, what it will do is notice that, hey, listen, I just have an empty statement. If I have an empty statement, that means I can do whatever, because the function's pretty long. I mean, there's some code beneath it. That's what the model will understand. And that's what we're trying to achieve here. Just give it the closing bracket, not the entire code. Otherwise it will cheat and try to predict the exact code. And that does not help us. You can try it for yourself. If you want to give it code after the cursor, just do it as an experiment and you'll notice what I'm talking about. It will repeat the exact same thing. Performance is better when you just give it the closing brackets and stuff. And if there's no closing bracket, you just give an empty thing. Now let's go ahead and define the output, which is going to be a string array. We'll just join it at the end. And then we have document.lineat.position.text, or not position.text, sorry, position.line. And then we'll pass in the text, because position.line will give us the character. We get the line at that particular character. Then we get the text. And then we'll slice off the text, because I want to get the text after, the cursor or the replacement region, because the position here is not going to be the cursor. It's going to be the position after we have calculated the replacement region, right? Once we've calculated return user is the thing, we'll pass in this particular block where the position is present, right? This is where the replacement region ends. And then that will be after that will be our kind of the output or the suffix. So we'll pass that in and we'll slice starting from the position dot character, right? At that particular line, starting from that character. Great. Now let's move ahead. The start line, what's that going to look like? Well, it's going to be whatever is the position dot line plus 1, right? Because what we are trying to do is, let's say we are over here, the replacement region gives us this particular position. I want to start from the very next line, not from that line itself, because obviously the closing bracket should not be on that line. It should be on the next line. Otherwise it's given to us by the replacement region already. So we just start from the next line and start looking. So we'll have a for loop, let I is equal to start line. And what I'm trying to achieve here is that I go from I until, let's say 3 lines ahead. So if this is my function, return user is present, then I go up till the next 3 lines and see if there's anything that matches an empty bracket. If it does not, then what I'm going to do is, well, check, is it an empty line essentially. If it's an empty line, we'll skip, because empty line just means, something like this. Okay. We have an empty line here. My cursor was over here, so the replacement region turns out to be this, let's say. And then it thinks, okay, we have an empty line. Should I not pass anything? Not really, because even after the empty line, something can be present over here. So we'll go ahead and check the next line, and maybe the next line is also empty. So it will skip that and it will go to the next line, and then maybe on the next line it sees the empty bracket and will pass that in, because now there's not anything else present, right? We want to give it an empty bracket. But let's say we have some sort of function present here, maybe build prefix is present, just as an example. Okay. So if build prefix is present over here, it will notice, okay, we have the code. If I remove any of the brackets in this statement, it will try to remove this bracket. Does it amount to an empty line? It doesn't. That means there's code present here, and that is not going to be passed in the suffix, in the suffix, sorry. So we're all set. We don't pass in this particular function in, we stop over here. That's what we're going after. So we start from the start line, and then what we do is go until position.line plus, let's say 3, because we are going to go 3 lines ahead. And since we are going less than, we can do +1 so that, the indexing or the for loop can go on, and we're all set now. But the problem here is, what if, my cursor is over here, and then I go one step forward, and then I go one step forward, let's say. There's no bracket over here, let's say. And, the entire class or the entire file has gotten over. There's no more lines ahead, and I'm just doing I++. Well, in that case, when I try to do document.line at I.text, it will fail because, well, we don't have any line after this line. So what we want to do is, hey, we should take the minimum of whatever is the line count of the document and the position.line +3 +1. Whatever is, between these, like the smallest of this, we'll take that. So we'll never go out of range this way. Now we will try to get the line, which is over here. And then I'll check, hey, if we trim the line, is it an empty line first of all? Because if it's an empty line, I want to skip it. So let's have constant trimmed line is equal to line text dot trim. And let's say if trimmed line is equal to an empty line or an empty string, we'll continue forward. I go to the next iteration of the for loop. Then I'll check if maybe we replace all of the brackets, and here's where we are going to have the regex expression. So I'll paste that in, but that's what's going to happen here. Somewhat like a character group. In this character group essentially means like you can take any one of these elements. We've seen this before. So let's say we have the ending curly bracket, then we have this right bracket, then we have the ending bracket, and yeah, if we have a backslash as well. If any of these are present, including also a colon, a semicolon, a comma, and all of these things, what you do is just replace them with an empty line. That's what we're doing, an empty string. So if it sees this, it will remove it. If it sees this, it will remove both of them. If it sees this, it will remove 3 of them. If it just sees this, it will remove that. That's what we're doing here. And it will just convert it into an empty line. Then we trim this entire line and we check again. Hey, is it equal to an empty string? If it is equal to an empty string even here, then we'll take and push the line text into the output. So that's good. And once we do that, we can move on to the next line because we have our bracket. And if there's more brackets, I do want to continue pushing them. For example, we are an async create user. Let's say this is a class, right? So after this suffix, maybe the class also ends, right? That's totally possible. So that's what we're doing here. And let's say after that, it's none of these conditions. Exact code is present. You have, the exact content present. And if there's exact content present, well, I want to break out of this loop because we don't have anything. I mean, it's actual content or code piece written. For example, the function I showed you. If there's a function like async or create user, replacing any of the brackets won't really help. So what you do here is just break out of the loop. That, yeah, there's nothing. So this entire suffix is going to be empty. We're not giving it any completion of what's ahead so that it doesn't cheat. Great. Now the next thing I want to do is get out of this for loop and return the output.join and \n. It joins all the new line, all the elements by a new line. And that's pretty much it for the suffix stage. Let's go ahead and test it. I'll call it in the context gatherer. And by the way, a class was created with only one function in it because, you can get more complex with suffix. I've tried to keep it pretty simple, but if you have more ideas, you can try and experiment and see how that works out. Now let's go ahead and have constant suffix is equal to await this dot. Let's do suffix stage, and I have to create a variable for that. So I have private read only suffix stage, which is of the type of suffix stage. Then I do this dot suffix stage is equal to, and then I do new suffix stage, just what we've done before. It doesn't really require anything. Then I can take this suffix stage and call the build suffix after region. It's not really an await, it's a pretty synchronous method. Not a lot happens there. Then I go ahead and find out the document, and then I need to pass in the position as well. I told you that the position is not going to be the position as it is that we're getting from gather context, because that's the position of the cursor. What we need to get is the position of the region after replacement. So it's quite simple. We'll pass in replacement region dot range dot end, because that's the ending position or the ending range. So that's good. And now let's go ahead and test this. So I'll start debugging, or actually first I'll have to return it from here so that, I have some context about what is being returned, because we are printing it out. I believe in inline completion provider. Let's see. So we'll start debugging again. Then I'll ensure I select tab completion. Now I can scroll down. Maybe I can go to this cursor and hit enter. The prefix turns out to be empty, and I went behind the scenes to figure out why this issue existed, and the issue is there because the regex is incorrectly placed over here. So the regex should be this one, not the previous one, and this should work fine now. The difference, as you can see, is, well, I had repetition and that caused some issues, but anyways, it's fixed now. Now it will do exactly what I told it would do. It will replace the brackets so that, we can check if it's equal to an empty string or not. Now let's go ahead and run it. So I'll start debugging again. Then I'll move to the tab completion tab. Okay, great. Now let's have return result. As we can see, the prefix is correctly identified here. And yeah, it is a curly bracket. That means our suffix is also working, because this is not really a prefix, this is a suffix, right? So the replacement region is return result, and then the prefix turns out to be this particular bracket thing. Awesome. So that means the suffix is also working. If we go back to the context gatherer, we have replacement region, prefix, suffix, and edit history. Now we are left with two things, but I'll tell you what, we are only left with one thing. We're not going to do the type definitions, because think about it. What are type definitions? Type definitions mean we ask the language server for the type info about what's at the cursor. But the point is that our cursor is not obviously going to be at the exact thing all the time. For example, when I'm at return suffix, the type definition is not going to return anything. When I'm at edit history, it's not going to return anything. Only when I'm at something, let's say, I'm over here at AST service, will it realize, oh, it's a AST service, let me go fetch AST service wherever it's present in the code base. That's what the type definition will do. But we're not guaranteed that a cursor will be at that particular AST service all the time, right? If anything, it will most likely be at the variables, and the type definitions near the variables are empty. The way I was planning to implement type definitions was we use the hover result, or the execute type definition function that's present in the VS Code API. What the hover does is that you hover over it and, you get to know the type definition. That's what it is. And then the execute type definition is for something like this, where you have an AST service and my cursor is somewhere near them. So it knows, yeah, it's AST service. It's defined in that particular file and all of that. But our cursor is rarely ever going to be here, and it won't give us relevant results. Anyways, what we're going to do is add cross-file service, right? The cross-file symbol will find the relevant functions or classes from other files in the project. And relevant functions or classes are essentially, if I'm, let's say, over here, my cursor is somewhere over here, it will go ahead and find out, hey, where is the replacement region stage in our code base? Where is suffix stage, prefix stage, LSP service? Let me get their definitions essentially, so that I can give it to the model and help it better understand what we're doing. That's essentially what cross-file is. So cross-file along with our prefix will give us what the type definitions are going to give us, right? Because even in the prefix, if our functions got long or something like that, our classes got long, what we did is get the type definitions that are defined above that's related to us. I mean, obviously we only did base classes extraction. We did not do anything else, but you can, I told you how you could do it. So yeah, you could do that. So prefix plus crossfile is essentially going to give us type definitions. Maybe we'll miss out on 1 or 2 maximum, but I don't think it's very relevant. So I'll skip out on this step of type definitions. We'll directly go to crossfile symbols. And crossfile symbols is actually pretty straightforward. There's some code to write, and for some places what I'll be doing is, just pasting the code in. I'll explain it to you, but the code over there doesn't really matter as much because it's just boilerplate code of what we need to do to make it work. But yeah, we'll be using AST here. We'll be probably also be using LSP here. I'm not exactly sure. Probably most likely, yeah. So what is our steps going to look like? So the first step is going to be, well, we want to fetch all of the nearby context, right? We want to get all of the relevant symbols. So to get the relevant symbols, first we'll get all of the symbols from a symbol index, and that's what the LSP is for. Because if you remember, if we go to the LSP service we created, get document symbols, that will help us get the symbols for a document. The other thing we'll have to do is index the files. And here's where we are going to take another shortcut. The shortcut is that we're not going to index all of the files. Cursor probably does index all of the files, but the problem with that is, we have so many files here, and if we have even bigger code base, it's going to get much bigger. So what we'll do is skip the indexing for all of the files. What we'll do is index only a particular file that's open. Let's say I'm in LSP service. This file was open, so we'll index that. I go to context gatherer. I've opened this once. That's also indexed. I go to inline completion provider. That's indexed. Suffix stage indexed. So now whenever I hit enter over here, it will go ahead and fetch the relevant symbols from suffix stage because I had indexed that. So it knows that suffix stage is in the index. Great. Let me pull that up and put it in the context. That's what we're going to do with crossfile. LSP service I've opened. Okay, great. It will put that in as well. Then we are going to have the replacement region stage. It notices, okay, my index does not really have this replacement region stage. Let me skip that. So it won't go ahead and, have that symbol in. Of course, if you want, you can index all of the files. We'll make it, I'll point it out to you that, yeah, this is how you can go ahead and index all of the files. But what I'm going to do is whenever the file is saved or whenever the file is opened, that's the time I'm going to index the file. So first we'll have to create the indexing service, and for that we'll probably be using the bounded cache so that we can store it in a cache, and obviously we're going to return the symbols. To get the relevant symbols we'll be using LSP, because first we will have to know that this is a replacement region stage, right? For that we'll need LSP, because LSP gives us all of the symbols. Once I have that, the indexing part is done. The next part is going to be to go ahead and fetch, I have the symbol with me. I get that particular suffix stage class, but I'm not going to put in the entire function here. That's not really relevant to the LLM. It will actually pollute the context of the LLM because it will get confused that, yeah, this is the implementation, but just knowing that build suffix after region, I think the model will be able to figure out, okay, suffix stage does this job. We don't have to give it the entire implementation of how the suffix works. All it needs to know is that this is suffix. It has all of these functions. Great. Then for example, we also have LSP service. Here for LSP service, we'll just pass in, okay, there's an LSP service class. There's a constructor. There's this private register listeners function, then get document symbols, get super type names. That's enough for the model to know, hey, I have to call LSP service dot get document symbols because it's very well defined, right? Get document symbols. What is it going to do? It's going to get the document symbols. It doesn't need to know the implementation to figure that out. So it will help it to, whenever we have to call LSP service dot something, it will figure out, okay, yeah, LSP service dot get document symbol seems reasonable. So that's the plan. We're not going to give it the implementation. We just extract this header, and that's where we are going to use AST parsing, because there's no LSP API or VS Code API for LSP that will help us know, okay, this is where the header is. No, what we're going to do is we have to extract the signature that, yeah, this is the export class, this is the private register listeners function, this is the get document symbols function, and it fetches this entire line. Because again, as you can see, this is not on one single line. The entire function is like this: async get super type names, then you have the document, then you have the position, and then you have this. So this entire function signature is taking almost 4 lines. So we cannot just have one line, and that's why we need AST. LSP does not give us this information. So as you might have seen, the pattern here, the general pattern is we try LSP first. If that API does not exist or it does not give us relevant details, we'll switch to AST, which is bound to give us all the accurate data because it has the entire tree. But AST is just more complicated to handle. That's why, LSP would be great. But yeah. Anyways, we have all of that set up, and I hope you've understood what we're going to do. Let's go ahead and create a new folder. Let's call this cross file. And within this, we're going to have the cross file service.ts. And this is where we're going to call, or export class cross file service. And here's where we're going to define our function as well. Maybe this can implement VS Code.disposable because we are going to have some listeners, right? I told you that whenever the file opens or closes, I want to index. So that's probably when we'll have to dispose as well, right? So we'll have import everything as VS Code from VS Code, and now we're all set. From the constructor, we can go ahead and take the LSP service. I told you we'll be using that. So let's have LSP service. Then we're going to have the output channel if you want to block something out. And then we're also going to have the AST service, which is going to be like this. Okay, great. Now I can set the AST service to the AST service. Let me go ahead and have the AST service instance created at the top, private read only AST service. And the type of that is going to be AST service. Then we have this .ast service is equal to the AST service. If you want, you can just do private read only AST service. I'm just showing you another syntax you could use. So that's done. Now the same thing for LSP service. So you have LSP service defined like this. And then I can do this .lsp service is equal to LSP service. Awesome. Now let me go ahead and implement the disposable function. As of now, it's empty, but obviously we're going to dispose of the disposables list that we maintain in every disposable class. So we're going to have private read only disposables, which is going to be, well, a VS Code.disposable object, which is essentially going to be a list. Then we go ahead and say this is an empty list as of now, but we are going to register some listeners. So let me call this .register listeners, and then let me create the function to register the listeners, and register listeners is going to be a private function. So I have private register listeners, and I'll just say this is going to return nothing. Then I can do this .disposables.push, and I'll push in all of the elements. So the very first thing is going to be VS Code.workspace.onDidSaveText document, right? So that is going to return a document to us. And then I can say, hey, listen, this document that we have, I want to index it. That means whenever I save the cross-file service, I want the indexing to take place because most likely the cache is out of place. And for that, for that indexing, we're going to create our own service that will do the indexing. Again, quite straightforward. We're going to use a bounded cache, store in the cache, and all we need to do there is call the LSP service to get the document variables, right? So I'll have to create that class, but before I go there, let me go ahead and have other things as well. So I'll have another one, which is on did open text document. So whenever a text document is opened, I want to index. If you want, what you can do is go over all of the files that are present in this workspace and call index document on each one of them. It might take some time considering, your folder is quite large, but that's a trade-off you have to make. If you want to be like Cursor, you'll have to establish a background job to do something like this. I think they send it over the servers as well. So that's something you can totally do. I'm taking the shorter route. So anything that's open, we'll take that. Then we are also going to have, well, I think those two should be enough. Now let's go ahead and create the indexing service. And the indexing service, well, what do we call it? Let's call this symbol index, right? I mean, what we're trying to do is just index the document. Maybe you can call it document index as well. Now let's create the class for symbol index. There's no need to create a class for this. Since I've created classes for everything, I'm creating a class here as well. In the symbol index, we are going to have a public function, which is going to be called index document. Okay, that is going to take a document which is of the type of VS-Code.text document. It's going to return promise void. And yeah, that's pretty much it. Let me go ahead and have import everything as VS Code from VS Code. And now taking this document in, I have to index it. But before that, I have to put in some checks, right? Is it a proper file? And if it's a proper file, then I want to check the cache. If it's present in the cache, I'll return. And if it's not, then I'll go ahead and get the document symbols from the LSP service that I'm going to take from the constructor. So let me also have a constructor here, which is going to take a private read-only LSP service, which is of the type of, well, LSP service. Then we can also create a bounded cache here itself, because we know how this cache thing works. We've created it so many times now. So we have private read-only cache, bounded cache. And what we're going to store in this as the value is two things. This is the first time we'll be storing an object here. And the object is going to be a number. And the second thing is going to be symbols, which is going to be, well, indexed symbol. And that is going to be a list. Okay, index symbol is a list of symbols that are going to be present. And what is index symbol? Let's go to types so that I can paste this in. This is what it's going to look like. So you have the index symbol, which is the symbol's name. Then you have the kind, which is the VS Code symbol kind. And I've specifically told it to be a number. If you want, you can call it VS Code.symbol kind, something like that. Either way, it's fine, because VS Code.symbol kind is an enum that will ultimately store a value, which is going to be a number. But I'm just storing it to be a number. VS Code symbol kind is essentially, what is it? An interface class, what is it? Then there's going to be a container name. For example, if you're within a class and within a function, so if you're within a function of a class, it will say the container is, let's say, a class, right? So that's the container. Then you have the file URI, where the symbol is defined, because it's cross file. It can be defined anywhere. Then there's the range in the document, which is serialized as line or character numbers. So what is the start line? What's the start character? What's the end line? What's the end character? Then you have the extracted minimal signature. As I told, we'll only be storing the signatures for the index symbols, nothing else. So that's all good. Now I can go ahead and import this index symbol, and that's pretty much it. Now I can do this dot cache is equal to new bounded cache. Then I need to pass in the max size. Maybe I can pass in 1000. If you want, you can keep it to be 500, whatever suits you. But that looks good enough to me. The maximum number of entries allowed here is 1000. If you want, you can also take it from the settings, the configuration system. But yeah, that's the cache. Now let's go ahead and check. Does this document file, sorry, not file, the document.uri.scheme. If that is not equal to file, in that case, we're going to return, because it's not a file. Why do we want to index this? Then I'll get access to the URI. What is the URI? Because based on the URI, which is most likely going to be a file, but whatever else it is, I want to take that. Then I want to take the cached, sorry, the document URI is not going to be file. It's going to be the path of the file. Based on the path of the file, and then maybe we'll check the cache so that we can see that the cache is present or not. And if the cache is present, we can just return out of this function, because we don't really have to return anything. All we have to do is index the document. So if the cache is present, and in the cache we're storing the version number, and I've told you that the version number changes if the document changes. That means I can simply do something like this. Constant cached is equal to this dot cache dot get, and I'll pass in the URI. I'm not doing anything else. This is the simplest version I can think of. I've not created a cache key or anything, but I think I should. So let me do cached key, which is equal to build cache key. Then I'll pass in the parts of the array. I'll call this symbol index. Then I'll pass in the document URI. That's done. Then yeah, I think that much should be enough. So let me just save it, and I can use this cached key to get the particular thing, so that, any other URI, if it's added later on in anywhere, it doesn't conflict with the symbol index. The symbol index is prefixed with symbol index over here. Okay, great. Now I can go ahead and check, hey, if the cached is present and the cached.version, remember I've done version here. So if the cached version is equal to the document.version, that means we have the cached already stored. So why do we want to index again? Let's return out of here. Think about it. Whenever we index the document, we are going to store it in a cache. If the cached version is equal to the document's version, that means no file changes have happened. Why do we want to index the document again? Maybe the user just closed and opened the file again. That doesn't give us the authority, or not really the authority, but doesn't give us the opportunity to go ahead and index the file. It's the same file. Why do we want to spend our resources on it? Well, if that's not the case, then what I like to do is maybe do something like this. Constant symbols is equal to await this .lsp service .get document symbols. Then I'll pass in the document, and that will fetch all of the symbols that are required to get the document symbol. Now what I want to do is extract the symbols that are relevant to me. All I'm interested in is not all the types of symbols that are present. I'm interested in anything that's a class, function, an interface, enum, let's say a structure, all of those kinds of things. I'm not interested in everything. So I'll scan through all of the symbols and check, is this the relevant kind of symbol? If it's relevant to me, I'll push it in my result, and I'll have to maintain kind of this a structure, because what I want to do is have an indexed symbol stored right over here in the cache. An index symbol looks like this. So I'll build this entire result, and once that result is made, I'll store it in the cache. That sounds good. Let's go ahead and create the function. I'll create a helper function to do this. So let's have something like this dot extract symbols, and then I'll pass in the symbols, the URI, and we're all set. Let me go ahead and call this indexed symbols, which is equal to this dot extract symbols. Then let me create this function, and I'm just going to paste this in because it's exactly the logic I told you it would be. And here we go. This is the function. So what are we doing here? We are taking the symbols list, we are taking the URI, we are taking the container name, which is an optional string. The reason it's an optional string is because the first time we call extract symbols, the container name is null. But later on, when we do a recursive function, we are going to pass in the container name. I'll get to that. But yeah, container name is required. Then what we do is maintain a result. This is the index symbol. So whatever the extract symbols does, we store it in index symbols, right? And that's the value we're going to store in the bounded cache as well. And that is our indexing result essentially. So this entire range that you see, like this object, that is going to be our indexing data. That's going to be very powerful because now we've stored the name, the kind, the URI, the range of where the symbol exists. So that's powerful data with us. So the point here is that we go over all of the symbols and we check if it's of any relevance to us. And what we're interested in is one of these. We are going to check if it's a class, interface, enum, function, method, property, constant, type parameter, or structure. If it's any of these things, then it's of relevant kind. Because if it's anything else, like, a variable declaration was done or anything like that, that's not of relevance to us. What we are interested in is any particular structure. A class is going to be a structure. That's going to be a powerful symbol to be included in types. But it's just, if it's just a variable that's defined, how is that useful to us to show in types, right? All we want to show is something that's powerful, and a class, function, these are things that are powerful enough. So we are going to parse them. Then what we do is, well, if it's any of these things, then we're going to push it into the result. And then we're going to pass in the name, which is just symbol.name. The kind is just symbol.kind. The container name is taken from the parameter. Initially, it's going to be null, but later on we'll add more container names. Then we are going to have the URI. Then we are going to have the range, the start line, the start character, end line, and the end character. And yeah, we do this for all of the symbols. But before we do that, we have one more thing to do, and that's the recursive part. If the symbol has any children and the children's length is greater than 0, in that case, we're going to go into the container. So we'll have, well, container name dot. So if we are in any class, it will be symbol index, for example, dot extract symbols. Otherwise, if the container name is not specified, will be symbol.name passed in. And we call the extract symbols again, and whatever is the result of extract symbols, we push it into result. And yeah, that's basically it. Remember, extract symbols returns a result list, right? That's why we are destructuring this list so that all the objects are passed in and you don't have a structure where you have a list within a list, right? So we are just destructuring. Okay, so once you've dived into the symbol's children and we have our data, we've pushed it. Now we go to the next symbol and do the same thing. So that is just us extracting all of the symbols, and we have all of the index symbols with us. The next step is we have the index symbols. What do we do now? Well, we can just set it into the cache. So this .cache.set, I'll pass in the URI, not really the URI, the cached key that's present. I'll take this cached key, pass it in, and the value is going to be, well, the version, the document dot version, and then the symbols is going to be the index symbols that were returned from the extract symbols function. And that's pretty much it as of now. So that is our index document, and we're going to call that everywhere. So let me take this index document function and call it within crossfile. So I'll have this symbol index first of all needs to be created. So I'll have private read only symbol index, which is of the type of symbol index. Then I have this dot symbol index is equal to symbol index, or not symbol index, new symbol index class needs to be created here. Then I need to pass in the LSP service, which is this .lsp service, or the LSP service we got from the parameters, same thing. And yeah, we're all set. Now we can take this symbol index to call this symbol index document. I'll pass in the document, and the same thing can be done for this did open text document. Also, I would like to index the current document that's open, right? And to do that, and I think that will be accomplished by this on did open text document, because when we start, when our editor opens up, this is the text document that's open. So that will be indexed as well. And now let's just dispose of the disposables object. This dot disposables dot for each. I'll get the disposable object. I'll just call dispose on it. So that's also good. So we have indexed the files. Now what we want to do is get the symbols, right? Now to get the symbols, we'll have to create a function within the symbol index itself. So we're not quite done with symbol index. We're just done with one function. Now the point is, how do I know what do I want to get the symbols from, right? Because let's say my cursor is over here. I have index symbol service, and let's say LSP service and AST service is also done. So in that case, how will it know that it needs to go to LSP service and fetch any relevant symbols, go to AST service, fetch any relevant symbols? We don't really have the URI for the document for where it needs to go and fetch from the cache. How do we do that? Well, over here, whenever we try to index, we are passing in the cache key of symbol index and the URI, but we don't know what document to go into so that we can fetch the cache from there. You understand what I'm saying? The problem here is that we have an LSP service, we have an AST service, and a symbol index, but we don't just extract the identifiers and go to the symbol index to find them. That's a wild chase, because the cache key is dependent on two things: symbol index string, which we'll pass in, but the URI as well. And these things, LSP service, AST service, and symbol index, they don't give us the URIs. They just give us the identifier. We have to extract the URI. So what I'm going to do here is a little trick. I'm going to maintain another variable here. And what that variable is going to do is track the URIs. So we'll have private read only tracked URIs, which is going to be a set of string. This is just a set that keeps track of all of the URIs that we are tracking, right? And now we are going to index the document. Whenever we index the document, we are adding something to the tracked URIs, right? Because once we have set the cache, we have set the index, what are we doing? We are setting or adding to the tracked URIs. This is one of the documents that we are tracking. So we'll pass in the cached key, or not the cached key, sorry, the URI, which is the document URI.toString. And now whenever the user wants to get all of the symbols, we're going to return it to them. So we'll have get all symbols, which is going to return an indexed symbol, which is going to be a list. Then we are going to have a result, and now this result is going to be of the type of indexed symbol, and at the end we'll just return this result. But now what am I going to do? I'll loop over all of the tracked URIs, because whenever I index a document, I'm storing it in the tracked URI set. So I'll loop over all of the tracked URIs and try to check that, hey, we'll try to get the entry that's required, and well, we'll push it to this result and return it out so that cross-file service can use it for whatever task they want, because our point is to get all of the symbols from the files that are open or that have been indexed. So I'll do for, then I go over every URI of this dot tracked URIs. And remember, tracked URIs is a set. If you want, you can convert it into an array as well. So array.from, then you pass in this dot tracked URI. So you have a set that's an ordered list. Then maybe you can do entry is equal to this dot cache dot get URI. That gives us some sort of entry, and if that entry is not present, maybe it's undefined or something like that, maybe TTL expiry happened, right? So in that case, we'll just do tracked URIs.delete and pass in the URI. And actually, just not URI, we have to build the cached key as well. So let me copy it, paste it over here. Then I can pass in the cached key to get. So we get the cached key entry. Then we delete the cached key if the entry is not present, and we continue so that we can move to the next iteration of the for loop. And then I can check, hey, is the entry dot symbols dot length greater than 0? If it is, I'll decompose all of the values into results. So I have result dot push. I'll pass in the entry dot symbols because that's what they require, right? All of the symbols that are present, because once you have all of the kind of the symbols that are this entire thing, we have access to the powerful thing I was talking about, this entire, data of where the range is, what the name is, what is the kind, so that cross-file service can use it with the identifiers, right? Now we know all the symbols that we have indexed. Great. So we can use that with the identifiers, and we already have a function to extract the identifiers. If you remember, we had created extract identifiers function, so we can fetch all of the identifiers used in the prefix to get the data. So that's all good. We also have our get all symbols function done. Now let's go ahead and create a function here so that we can get all of the relevant symbols. So I have async get relevant symbols, where we're going to get the document, which is vscode.text document. Then we have the prefix, and that's going to be a string. This is the function that will be publicly accessible, and what it's going to return is a new type that we're going to create, which is cross-file symbols. So let's have a promise of cross-file symbols that we're going to return. And actually cross-file symbols is just indexed symbol, which is a list. So we can just pass in an index symbol as a list will be returned from here. As I told you, to get the relevant symbols, what we're going to do is get all of the nearby context. And to get all of the nearby context, we're going to get all of the prefix identifiers. Once we have all of the prefix identifiers, we are going to build and get their reference names. And once we have their reference names, we can compare it with all of the symbols that we've found from the get all symbols, right? I mean, we can call it over here as well. Constant all symbols is going to be equal to this dot symbol index dot get all symbols. We can use this all symbols, and we are going to fetch all of the nearby context, so that, and by nearby context I always mean like the prefix identifiers, we can get all of them and then compare it. So what we'll do is, well, I'm going to check that the all symbols should have their URI not equal to the document URI that's present, because if it's equal to the document URI, it will be caught by the prefix. Otherwise, only when the document URIs don't match, the file paths don't match, are they from different file, and this is a cross-file service. So obviously, now once that's not the case, then we're going to check if they're already present in the nearby context. If this symbol is already present in the prefix, I don't want to include it. So that's just one check. And then we're going to check, if it's other things, like if it's a method or a constructor, then we're going to extract the AST signature, because as of now, we just have the names. Once we have the names, I can tell AST that, hey, listen, I want access to this. Go fetch me the entire signature of what we have. For example, we have access to get relevant signals. We know get relevant signals should be included. But what we don't know is what's the entire signature of get relevant signals, so that if the LLM wants to predict get relevant signals, and then it needs to pass in the entire thing, like what's the document, what's the prefix, it will be able to. We are going to extract this entire signature from here. And that's what the AST will help us with. So lots of exciting stuff. Let's get to it. So let me go ahead and create a new cross-file, like a new file in cross-file folder. And that's going to be, well, to get the nearby context. So let me call it reference extractor. And we're going to be extracting reference from it. As the name suggests, it's just the nearby context. After that, we're going to go ahead and create the class, just like we've done before, reference extractor. Then we're going to have a constructor From the constructor, we're going to take the AST service because we're going to create a new function in AST service that will help us. So let me just create it now, then AST service like that, and we're all set. Okay. And the next thing I have to do is create a function that will help me extract. This is going to be the publicly visible function. Then we're going to have a prefix of the type of string, language ID. Maybe it's required. I'm not really sure if it's required. And yeah, we'll have these two things. Now to extract, what do we want to do? Well, I want to get all of the import line spans and remove it so that, I get the prefix without the imports, because currently our prefix might have imports. So what I want to do is get the import bindings, find the import line spans, then remove those line spans. Then I can extract all of the identifiers based on that prefix, right? And we have functions created for most of them. So first thing is find import line spans. This will help me find in the prefix where is our import line spans, and then I can go ahead and create a function to remove those line spans. So let me pass in the prefix, then we're going to get the language ID. Okay, it's required because in AST we will be requiring what language you're working with. And here we remember that there's three things that can be returned. If we go here, there can be imported original names, imported aliases by original, and imported local names. What we're interested in, or actually not in this one, find import line spans returns the line span. So we can just store that. I was thinking about parse import bindings and we'll get to that. But first, let me have the import spans with me. Great. Now I want to remove this import spans from this prefix. So I'll create a function for that in the import analysis file as well. So wherever I have find import line spans, below them, I can go ahead, or maybe above them, I can create a function that will help me remove the line spans. And I'm going to paste that in because everything in import analysis I've basically just pasted in. So here's what we're doing. We are taking a text of the type of string, we're taking the spans that we want to remove, and we're returning a string. Then we're checking, hey, is the span.length equal to 0? That means there's nothing to remove. We'll return the text as it is. Then we convert this text into the lines array so that we can loop over it later on. And we're also maintaining a set of numbers that will help us keep track of what we want to remove. Then we go over each span. Then we add basically all of the values that are present in the span, and the I should be less than equal to span.end and less than the lines.length because we don't want to overflow. It should either be the span.end, and span.end will most likely be the less than the lines.length, but even then we're putting this condition in, and then we I++ and we add it to the set. Then what we do is go over the lines array. Then we've kept track of what are the line spans that we need to keep. So we'll go over the entire lines, all the lines that are present within this text, and we'll say, hey, if toRemove does not have this I, because remember, we are passing in the line number, right? The line number that we want to remove is based out of the span that we are getting over here. Now, if that line is present in toRemove, then we basically want to keep it, right? So that means if toRemove does not have it, we'll not remove it. So we have kept the value and we push it in, and then we just return kept.join as a string. That's us removing the line span. So let's say at the top there is this import XYZ line, and then there's a function XYZ, or let's call this ABC, like that. Import lines, find import line spans will give us that this line is present. So we'll go ahead and remove this line, and this line is essentially, let's say, line 21. That's kept within the toRemove, but the line 23, 24, and 25 is kept in the kept because toRemove does not have those line numbers. It only has the line number 21. So it will not include that in the kept array. Now we can go ahead and use this function in the reference extractor. So we'll get prefix without imports, which is equal to remove line spans, and then I'll pass in the text which is going to be the prefix, and then I can pass in the import spans because that's what we want to basically remove, right? I mean, the prefix text is where we want to remove the imports from, and what import spans we want to remove is in import spans, obviously. Great. Now that we've understood that, what I want to do is take this prefix without imports and use it to extract the identifiers. The reason we had removed the imports is because think about it this way. If I have this particular class, this particular file, so we are having these two import lines, and then we are having the class. Within the class, we have this constructor, function, all of them. So what our base thing here is that I want to find out the identifiers, because once I get the identifiers, I can build the reference names. That's all well and good. If I go ahead and find out the identifiers just based on this entire file without removing the imports, I'll get find import line spans, remove line spans, AST service, then I'll see AST service again, then I'll see import spans, prefix without imports, again find import line spans, again remove line spans, because that's how the logic of find import line spans works. So that's just incorrect. And that's why we are removing the import spans so that we don't get any of these duplicate things, because we have already added them when we parsed through this code. Now without the imports, I'll find out the identifiers, and to do that, I can use the extract identifiers function we had already created. And I can pass in the text, which is prefix without imports, and the language ID can also be passed in. So I'll just pass that in. Great. Now I have the prefix identifiers, or you can call this prefix without imports identifiers. Then we are going to split it into a line, because I only want to check the last 15 lines. I don't care about anything else, because I'm just interested in the nearby identifiers. We're not interested in all the identifiers that are present within this file, just the last 15. So I'll have constant lines is equal to prefix without imports dot split, and then we do \n. Then we are going to go ahead and do constant nearby text is equal to lines dot slice. Then I'll pass in -15 so that I get the last 15 ones, and then I'll join them by \n, because it was an array, I want a string, because my next approach is going to be just to fetch the nearby identifiers. Remember what I did here. I found out the prefix identifiers. That's required because the prefix identifiers will be returned from this extract function. But the other thing that's also required is the nearby identifiers. And we'll later on understand why we need both of them. But as of now, just understand that both of them are needed. So we have prefix identifiers and also the nearby identifiers. So we have constant nearby identifiers, which is equal to extract identifiers, and then I'll pass in the text, which is nearby text, and then the language ID again. Okay, great. The next thing I want to do is fetch the declared identifiers. Declared identifiers means what are the identifiers that are really declared here. For example, if we have a function, let's say something like this, import foo as bar from, let's say /foo, and then we create a function called use it, and then we call bar on this, something like this. We have the import statement. We are going to require this particular line. We'll talk about that in just a minute. But this use it is going to be our declared identifier, because this function was declared. And that declared identifier will help us later on when we want to build the reference names and return that from here. Let's go ahead and comment this out. This will be an example I'll be coming to quite often. And now let me create the declared identifier. How do I get access to this use it? How do I know that this function is declared, or a class is declared, or some other variable is declared? Well, for that, I think an AST would be the greatest approach we could use, because an AST will let us know if it was a declaration that's happening. So let me go ahead and use the AST service now. So I'll have we'll have this .ast service dot, and then we do dot with parsed tree. Then I pass in the code. So the code is going to be the prefix. Then we have the language ID, And then we are going to have a function that will get the tree, and yeah, we have it. Or actually, we don't need to pass in the language ID. We just need to pass in the function, and the function will be created in the AST analysis part. And I'm going to paste that in because it's a lot of statements, but it means quite basic stuff. It's just boilerplate code for the AST to work. So let me go ahead and paste this in. So the function we're creating is extract declared names. It's going to get a tree, and we're going to return a set of, the declared names that we found. So we have a set instantiated, then we have the root of the tree. We go over all of the named child counts. We've gone over this before as well, because when we had to do this, we also went over the named child count. Then we extract the named child, and if the child is present, we are trying to extract the name from the node because we are trying to extract the declared name, right? So what we pass in is the child and the names. And now I have to create an array that will extract the name from the node. But the problem is we don't know the type of the node, right? I mean, the node can be anything. It's a variable declaration. It's a function declaration. It's a structure declaration. It can be anything. And we'll have to hard code all of that. So I'll just paste in a big function, but it essentially does the same job. All of the if conditions do the same job. So here's the big chunk. Let's go over it again. So we have extract name from node. We give the node, we get the names, which is a set. We don't return anything. All we are trying to do is extract the name of the node and add it to this names set. Then we have the type of the node, and we are checking if the declaration node types does not have this, then we return. And now we are going to maintain this declaration node types. And I'm going to define it at the very top. This is the thing. It's a set that contains all of the node types that basically declare something: function, function definition, function item, class, class definition, lexical, variable, interface, type alias, enum, structure, trait, type, type declaration, decorated, export, statement, assignment. All of these are where things are going to get declared, right? So we have them. So that's our declaration node types. If it has that particular type, or if it does not have that particular type, we're going to return because it's not a declaration. We don't really want to extract the name then. Then what I want to do is check if the direct name fields like function declaration, class declaration, etc. has this type. Because if it does, then we are just going to do name.child for field name. That's just the boilerplate code to extract the name. And then we'll get the name node and we add it to the names array. Now let's go ahead and have these things created. As you can see, direct name types is required, declarator types is required, and I'll fix all of these errors. Let me go at the top and import them as well. I've also added in a comment that explains what these are. So the first one is node types, where name field directly gives us the identifier. That's the direct name types, and as we saw in the code, just doing name just gave us the entire thing. So that's all of these things, okay? And they're a subset of this thing. Then we have the declarator types, which is just lexical and variable declaration. These are the node types that contain a declarator with a name field. And we'll look into that as well. But anyways, if we scroll down, we'll notice, if the declarator, if direct name types has a type, then we search the child for the field name of name, and if that name node exists, we add it to the set and we essentially return out. We have our names extracted from that particular node. Otherwise, it can be a declarator based thing like a lexical declaration, variable declaration, all of that we saw above. So what we do in that case is that we go over the node's name child count. Then we go over its child and see if the child is present and the child's type is variable or init declarator. Because when I extracted above in the comment, I told you that these are the node types that contain a declarator with a name field. They're not really, like they have a node within a node that contains a name field. So what I'm trying to do is go over the children and see if they have the declarator field in them, right? So that's the part about type declaration, declarator types. Now we go to the type declaration. That means the spec child has a name, and basically the same thing. We're going over all of the nodes name child count, and then we are checking if that type is equal to type spec. This is just various types of if conditions doing the same thing, but these are different declarations. That's why they have a different structure. So we're trying to extract all of the information from them. We also have an import statement, an export statement. And for the export statement, we're having a declaration. So that's how essentially this is how it all works. I mean, that's how the AST tree is created. So there's nothing more I can do except try to recursively go into this export statement and get the data outside, So I'm not even going to get into it. Then there's a decorated definition, which is Python only, which recurses into the child definition. And basically the same thing as you can see as the extract name node from type, but some things changes. For example, in the decorated definition, you have the definition. Here you add the declaration. So yeah, then you have the assignment, which is Python top level left side identifier, because on the left side you'll have the assignment, right? So that's what it's doing. And yeah, just a lot of stuff, which really depends on the tree that is created, and that is very library specific. So WebTreeSitter does it this way, and I think it works out pretty well. So let me go ahead and with parse tree, I can pass in this particular extract declared names function. And if this returns an undefined variable, then I'm going to create a new set, which is going to be of the type of string, and it's just empty. Okay. So that means we don't have any declared identifiers in that case. But in our little example that's present in the comments, the function useIt should be a declared identifier. The next thing I want to do is build the reference names, right? I have 3 things that I'll use to declare or to build the reference names. And actually, I just realized the prefix identifiers is kind of no use. It can be returned, but I've removed the functionality related to the prefix identifiers, so it's not really of any use. Now let's go ahead and do the build reference names. So for that, I'll have a helper function, and let's pass in the nearby identifiers. That's helpful. Then what we need is imported alias by original. So let me help you understand what this build reference names is going to do. So let's say we have this particular thing, right? What we're going to do here is, well, the nearby identifiers is useIt and bar, right? Because they are in the last 15 lines and we've removed the import statement for them, right? Nearby identifiers uses nearby text, which is dependent on lines, which is just prefix without imports. So it doesn't contain these import lines. So based on this, it extracts the identifiers, which is useIt and bar. Great. So now we have the nearby identifiers. We have the declared identifiers, which is useIt. But what we don't have is information about the import statements. We want cross-file lookup to target the original name. So the foo, because here, we have foo as bar. In the foo file, there's a function or something created that's called foo. But in our local file, we are using it as bar. So what we need is this mapping from foo to bar, because that will help me understand in the cross file, what is the original name I should go and target, right? Because in the foo file, it's just defined as foo. So I'll go to the foo file and find out, oh yeah, we have a foo. Great. So that's what we need here. So let me also extract that data. And for that, we'll be using parse import bindings, because if you remember, parse import bindings was the one that returned 3 things: imported local names, aliases, and original names. We're using this one because if you notice, this is the exact thing that does our job. It imports foo as bar. So the foo is the original thing defined in the file that's present somewhere else. That's why it will be helpful in cross-file. And then we have a bar, which is used in this particular file. I mean, foo is treated as bar. So it's a kind of a type alias. So yeah. Now let's pass in all of the data that's required. So the very first thing is going to be the prefix, because I parse the import bindings based on the prefix. Then I pass in the language ID, and that will return to me one thing that I need, which is imported aliases by original. Now I can take this imported aliases by original, I can pass this into build reference names, and the next thing I need is declared identifiers. These three things will help us build the reference names. So let me store this in a variable as well. Reference names is equal to this. Now let me go ahead and create a function to do that. We'll have private, and then we can have build reference names. Then I have the nearby identifiers, which is a set of string. Then we have the aliases by original, which is going to be of the type of map, which is of the type of string, comma, set of string, exactly what was defined earlier. And let me have a map here. Then we are going to have the declared identifiers, which is going to be a set of strings. So we have declared identifiers and a set of string. And it's going to return a set of string from this particular function because we build the reference names. We don't want any duplicate values. So yeah, that's it. Also, let me take this example down here so that I can explain each line what's going on. So let's understand. We have the nearby identifiers, we have the declared identifiers and the aliases by original. Now we want to go to the cross file to look up and target the original name, let's say the foo that's present, which is the name present in the defining file, and the user in this file is using the alias of bar, right, in this file. References will therefore contain kind of the original names for symbols we should look up in the cross file. Example, like, you know, the foo that's present in the example string above. So what we want to do is first get access to or create a variable that is going to be a result. Let's call this references, which is going to be a new set of string. Then we are also going to create a kind of a new map that maps string to string. So I'll have original by alias. Earlier we had aliases by original. Now we have original by alias, which is going to be a new map of string comma string. So this map is essentially going to answer the question that, hey, given a local alias name from the prefix, for example, the bar, what is its original imported name? So foo, because when I go over this entire, string, let's say I am using bar, okay? Or let's call this bar like that. So we are using bar, and the bar exists nowhere. I cannot just take this bar and call it. What I need to do is first check that, yeah, does the original by alias contain this somewhere cross file? Once I know that, I can go and search for foo instead of bar, because searching for bar cross file is going to give me nothing. It's not defined. But searching for foo is going to give me. So I'll first grab this. I'll find out, okay, yeah, the bar is present here. So let me take this foo and search it cross file. So that's what I'm doing here. And this map is going to help us. So first, let me create a reverse map. So I'll go over this constant original and aliases set of aliases by original, because that's what this contains, right? The original key, and alias is going to be the value, which is a set. Then we go over each alias within aliases. Then what I'm going to do is take the original by alias and set the mapping between the alias and the original. So all I've done is reversed the entire condition. Earlier, in aliases by original, we had foo mapped to bar. Now we have bar mapped to foo, because all of these variable names are only going to be defined once, right? So, that's what we're going to do. Now what I'll do is go over all of the nearby identifiers and check, hey, does the declared identifier have the same ID as this nearby identifier? If declared identifier has this nearby identifier, that means we can skip it because it was declared in this file. That means it's not going to be available cross file. It's like a temporary variable that was created in this class, or, something like that. But if it's not present in declared identifiers, then we can go and search cross file. That's exactly what we're doing here. So let me have this for loop going on. For constant identifier of nearby identifiers, I'll check, hey, does the declared identifiers have this identifier? If the declared identifier has it, that means it was defined somewhere over here. I can continue. That means I skip this particular identifier. Otherwise, I'll try to get the original name. So I'll do constant original is equal to original by alias dot get, and I'll pass in the identifier, and then I can just do references dot add. I'll add the original if the original is present, because if the original is not present, then I'm just going to pass in the identifier as it is. Because, you know, what if it is something like this? Maybe I also call another function called, let's say, cat, right? If this is done, and let's say we are importing cat from, let's say, ./cat. In that case, the thing is, cat is just cat. There's no mapping that's present in the aliases by original, because cat is treated as it is, right? So in that case, we won't find anything. And for that reason, this can be null. So we want to treat cat as it is. Having understood that, we are going to return the references from here. I hope you've understood this. This is basically the biggest part of build referencing. Now we are all set. We can just take this and return it. And now I can pass in the reference names. I think that's the main thing. Maybe we can pass in the declared identifiers as well. Then we can pass in the nearby identifiers if you want. If you want, you can still pass in the prefix identifiers. It's all good. If you want, you can also pass in imported aliases by original. You can also pass in other things. But yeah, we're all set now. Maybe we can create an interface at the top, which is just like, you know, something like nearby context, so that it gives enough information about what's going to be returned from here, so that we get that autocomplete. So let's call this reference names. Then we're also going to get the declared identifiers, and then we can pass in the nearby identifiers. Let me give each of them a type. So the reference names is going to be, well, this part, which is just a set of string. Then we have the declared identifiers, which is this thing, again, a set of string. And finally, we are going to have the nearby identifiers, which is going to be this thing, again, a set of string. Everything is just a set. So yeah, that's all. Maybe we can also pass in imported aliases by original, but I don't know. Maybe you want to, maybe you don't want to. We'll see as and when we need it, we can have it. Okay, great. Now we can go to the cross-file symbol service and use this thing. We're all set with the reference extractor. Let me have it created at the top. So we have private, read only, then we have reference extractor, which is going to be of the type of reference extractor, not reference error, reference extractor. Then we are going to have this dot reference extractor is equal to new reference extractor. And I'll pass in the AST service, which is this dot AST service. Now let me take this reference extractor and call the extract function on it. I'll pass in the prefix that I have and the language, which is going to be document.language ID. Okay, and that is going to return all of the nearby context to me. So let me save this as nearby context. Okay, and now what do we want to do? We have the nearby context. We have all of the symbols. I told you that, well, first of all, if the reference name size is 0, there are no relevant symbols for us in the cross file. So I'm not going to dive into the cross file and find something. So what I'm going to do here is check, hey, if the nearby context dot reference names dot size is equal to 0, let me return an empty list. There's nothing to be found here. So let me have all symbols, if, and yeah, boom. Now I have all of the symbols. I want to filter all of the symbols so that I ensure that this symbol that are present here, their URI and the document's URI does not match, because then it is in the same file. If it's in the same file, it's not cross-file service. We've talked about this. So we have constant. Let's call this candidate symbols because they're not the true symbols as of now. They're just candidates. They can be possible symbols, or you can call them potential symbols. Then we filter by each symbol, and then we are going to check two things. First, the symbol.uri should not be equal to the document.uri.toString. Okay, that's the first thing. The second thing is that they should not be defined in the declared identifiers, right? Because if they are in the declared identifiers that we get from the nearby context, we just saw that they're defined in this file. How are we going to have them searched cross-file? So I'll check, hey, this should not be defined in nearby context. So nearby context.declared identifiers should not have the symbol.name. That was the purpose of returning the declared identifiers. That's of use to us, great. The next thing I want to do is find out the referenced candidates. And the referenced candidates means that the nearby context reference name has the symbol, right? So we want to essentially do an intersection of all symbols and the nearby context. How do we do that? Well, we can do referenced candidates is equal to candidate symbols dot filter. I'll get a symbol here, and then I'll check, does the nearby context dot reference names dot have the symbol dot name? If it does, then we are going to have an AND condition, and then we have another condition. Well, if the nearby context reference names has the symbol name, great. It's not even in the, this nearby context dot declared identifiers. That means it is truly present cross-file. So it's an opportunity for me to go and fetch that, signature. Because I already know the name, I'll just use the signature to extract the particular signature so that I can return it. Because that's what this file is doing, by the way. Get relevant symbols is just trying to extract the signature of the function or the class that's present. Now we can have, let's say, the symbol kind. So we can check that the symbol kind should not be equal to the vscode.symbolkind.method, and the symbol.kind should not be equal to vscode.symbolkind.constructor or constructor like that. Let's have this symbol.kind as well. If you want, you can have the constructor or the method. I'm just not having them in our referenced candidates, because our constructor in some languages is going to have the same name as the class name, right? And that will cause some issues. So I'm just mitigating them. And method, it really depends on you. Now we have the reference kind. I'll just check, hey, if the reference kind that's present here or the reference candidates that are present here, if their length is 0. If that is, we'll return an empty list. Totally possible that the reference candidates is now empty because they're all defined in the same file. And other things that are mentioned, we have not indexed it. For example, if we had something like, this thing, and we had not indexed the file of foo and not indexed the file of cat, it's just going to have bar and cat, which is, not defined locally. It's just going to be empty, right? So we just return an empty list. But if it's indexed, we will get access to their definitions. And now I have the referenced candidates, which is essentially an index symbol list. What I want to do is extract their definitions. And to do that, I'm going to create a last class related to this cross file. And that's going to be signature provider. What it does is extracts the signature of that particular class or function or whatever. Now, let me go ahead and create this file. Let me have export class signature provider again. It's going to be a short class, but it will require some things added in the AST analysis. So let me have a private read only, first of all, signature cache, because once we compute the signature cache, I want to store it. And obviously we'll be using the bounded cache for this as well. Then we have a constructor, then a private read only AST service, which is going to be of the type of AST service. And then this dot signature cache is equal to the new bounded cache that's created. The type is going to be a string, and then I pass in the max entries of signatures, maybe 1000, whatever you want. You can take it from the configuration service again. Now we are going to have our async extract function because we want to extract the signature, right? And then we're going to take in all of the symbols, which is the indexed symbol, which is going to be a list. And we're going to have a promise returned of indexed symbol, which is a list. Great. Now what I want to do is find out all of the kind of the signatures of the function. Remember, what we are getting is this index symbol. Index symbol contains this name, URI, kind, all of those things, right? What I'll do is go over each symbol and try to extract the signature based on their name, right? So let me go to the signature provider here and have something like this done. So first of all, let me have a result variable, which is going to be of the type of indexed symbol, which is a list returned at the end. Then we are going to go over each symbol for constant symbol of symbols. Then I'll try to extract the signature, which is constant signature is equal to this dot extract signature. I'll pass in the symbol. And then we can check, hey, if there's no signature that's available, we can continue. Right? I'm just writing all of the other parts. Then we can come back to extract signature, which is the main part of this entire thing. We try to find or compute a signature here for the symbol. If we could not find or could not get a signature for any reason, what we have is a parsing error, like an unsupported kind, any of those, we continue to the next symbol. And then what we're going to do is push from to the result some data, which is going to be dot symbol. So, all the properties of the symbol. And then we're also going to attach the signature, because if you remember, when we did the indexing, which was in the symbol index, I believe, here we had passed in this particular symbol, right? I mean, this was the data that was passed in. One thing was missing here, which is the signature. And we did not add it, and that's why in the index symbol, if you notice, the signature is the place that's empty or nullable. So here we're not passing in because we don't have the data for the signature, but now we're extracting the signature, we're pushing to the result, but this time we have the signature attribute added as well. And now we can return the result. Awesome. Now let's go ahead and create the function to extract the signature. So I have private async extract signature. Let me capitalize this. Then we're going to get the symbol, which is going to be of the type of index symbol. And then we're going to return a promise, which is of the type of string or undefined. Then we have this. Now what I want to do is build a cache key, because we are going to store it in the bounded cache, right? I mean, we've seen this pattern so many times in this tutorial. What we have to do is build the cache key, then check the signature cache, return that cache if it's present. Otherwise, we'll go ahead and open the document that contains the symbol and ensure that we can get data from our AST. And that's where AST is going to come in. So first, let me paste in the stuff that we've already done before. And this is how the cache key is going to look like. Let's import build cache key first. Then we have it dependent on the URI, the kind, the name, the start line, the start character, the end line, the end character, and maybe at the top we can also have signature provider written out, because that is the unique identifier for this cache. Otherwise, someone else from other services might just use them and get access to a signature, which is not our intention. So this is just for signature provider. Then we check the signature cache. If it's not undefined, we return the cache value. Great. The caching part is done. Now what we want to do is open the document that contains the symbol, right? Because once we get access to the entire document, can we basically pass to the AST so that it can extract the signature. We have constant URI is equal to vscode.uri.parse, and I'll import vscode at top. So we have import everything as vscode from vscode. Then we scroll down and we have our uri.parse. Here I'll pass in, let's say, the symbol.uri. Then I'll also get access to the document, which is equal to await vscode.workspace.open text document, and then I can pass in the URI. So that will open up my workspace and open the document. So I have access to the entire document now. Now what I need to do is, get the entire text. So I have constant full text is equal to the document dot get text. And here I need to specify the range. What range do I want to get the signature from? And to get the signature, what we're going to do is something quite interesting and very easy as well. We are going to create a range here, which is vscode.range, and we'll pass in the entire range that covers this symbol, right? Because we have access to the symbol. The index symbol already keeps track of the start line, start character, end line, end character. So I can just pass that range over here. And now, this range totally contains the entire symbol. That includes its header, the body, everything. So I can pass that in. So I'll pass it in over here. And now I can kind of create a signature by passing it into a function called extract signature from AST or something like that, which I'll create in AST analysis and then set up my cache. So I have the full text related to the symbol that contains the symbol. This text will definitely contain the symbol. And from that, I will extract the header because that's not what the LSP gives us. LSP will not give me, oh yeah, these 3 lines are going to be the header of the function, the class, whatever is present. I have to do it. So here I'll pass in constant signature is equal to this dot AST service dot with parsed tree. And I'll pass in the code, which is going to be the full text, because in full text, I want to find out the header. And then I'm going to pass in the function, and the function is going to be extract signature from AST. And that's a function we'll create in AST analysis. Also, we need to pass in 2 things here. The first thing is the tree. Okay. So whatever we get access to, we'll pass that in. And the second thing is symbol.kind. What kind of symbol is this? Method, class, function, constructor, what is it? That will help us as well. Now we can go ahead and create this function in import analysis, AST analysis. And just like other functions, I'm going to copy paste in. And here's what I'm pasting in. So the first thing is, extract signature from AST. So if I go to signature provider and import it, it will be imported correctly. There we go. Then we have the AST analysis, right? I mean, we have the tree, we have the symbol kind, but we're taking it as a number. Notice here, we're passing in the symbol.kind. The symbol kind in our mind was something like constructor or any of that, but they're assigned a value because they're at the end of the day enums. So for us, it's friendly names that's written, but actually it's a number. And that's why we're taking it a number here and we're remapping it. So the kind interface was 10, class 4, function 11. These are values extracted directly from symbol.kind. If you go here and try to find out somehow that what is the number exactly for the symbol.kind, you'll see that these are the exact numbers. And then all we're checking is that, is it an interface? Is it a class? Is it a structure? Is it a function? Is it a method, enum, variable, constant? What is it? And for each one of them, we're going to extract. It's going to have its own separate function. And that's why I pasted it in, because all of this, again, everything related to AST is just so dependent on the package we're using, and how to extract it is just parsing through the tree, finding that particular thing and returning that. So yeah, let me paste in all of the functions. They kind of do the exact same thing, extracting the signature. There's no complex logic as such involved, so I'm not going over it. And here we go. These are the things. Maybe we have to create more functions, but yeah, you'll find them basically in your file when you download it. So no need to worry. So the first thing is extract interface or class signature. We pass in target types, which is going to be a set, and that is going to be the interface node types. Basically, earlier we had all the types defined here, which is related to declaration node, direct name. Similarly, we're going to have more things here. So let me paste them in. Here we go. So we have the direct name types. Okay, that was already done. Then we have the declarator, class node, function node, interface node. We see function declaration, method definition, function definition, and then we also see arrow function, which is basically JavaScript related. Then we have variable node types, interface node types, all of these things. right? So they are all used here in extract signature, because in interface node types, we only have an interface declaration because class or interface is basically treated that way. And then we go ahead and do interface or class signature. We also pass in the class node types here. Then if you want to see, take a look at the function, all we're doing is, well, if there's no body for the declaration child, we return the full text. Otherwise, we go ahead and build the signature by going over each child and stripping their bodies, because what we want to do is add a dot 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 at the end. Basically, our output from here is going to look something like this. If we have a proper class created, let's say XYZ, and it has 3 functions created, we're going to have the class XYZ, but then we're going to have something like function hello created here, and that's going to be something that looks like this, maybe something like this, and then function world, something like this, then cat, something like this. All the inner implementation is stripped off, just the headers are kept. That's what we are trying to do here. Now let's go ahead and create this function of find first node type, and all of our errors will be resolved. If you want, you can take a look at the code very deeply, but as I mentioned, it's just a lot of boilerplate code to do the same thing. And this is finding first node of type. What it's doing is going over the child, and as soon as it finds one child, it returns found, otherwise it returns null. So that's what's used everywhere. You can go over it at your own time. I'm not going over it. The point is they extract the header and give it to us. We have the signature with us. What do we want to do with that signature? Well, I want to set it to the cache, right? So if the signature is found, it's not undefined. In that case, I'll have this dot signature cache dot set, and I'll pass in the cache key. I'll pass in the signature, and I'll pass in the group key, because the group key is relevant for us to essentially, invalidate the entire thing if it's needed. So symbol.uri. And let's say we don't have the signature. In that case, we are going to return undefined. But if we do have the signature, in that case, what are we going to do? We are going to return the signature itself, right? And with this, we're all set. Maybe I can return it outside. Either way, it should be fine. Now let's go ahead and resolve the error that's present, which is this signature. It says promise string undefined. Let me await this, and there we go. Boom. Everything is now done. Our signature is also extracted, and that essentially will complete our entire cross-file service. So let's go back to the cross-file service and see. First, we'll have to create the signature extractor or signature provider. So we have signature provider, which is of the type of signature provider. Then I'll have this dot signature provider is equal to new signature provider. I'll pass in the AST service, and now I can use this over here. So I have this dot signature provider dot extract, and now I need to pass in the symbols, which is the indexed symbols, and the indexed symbols is just going to be the referenced candidates, right? Because we did all of that filtering so that we could pass it to the signature provider to extract their values, and that will be our result. So we'll return that result at the end, and that gives us all of the relevant symbols. Now I can go to the context gatherer and have the cross-file service. So let's have something like this. Private read-only cross-file service is of the type of cross-file service. Then we have this dot cross-file service is equal to the new cross-file service. And now I'll pass in the LSP service, this dot LSP service, this dot AST service, not suffix stage, AST service. I can't seem to use it. Maybe I can just call it like that. Great. And now I can call the thing over here. So we have this dot, then I have cross-file service dot get relevant symbols. I'll pass in the document. I'll pass in the prefix. And yeah, that's basically all we need to get all of the symbols. Let's do an await here. And then we have all of the cross-file symbols, which is equal to this. Let me return it as cross-file services from here, but obviously it's going to run into an error. So what I'll do is json.stringify so that I can see the actual value, because stringify will just convert it into a string, and I'll be able to see the real values. Once we have that done, we are going to create a completion context instead of a string so that we can use it in the inline completion provider. And then we just have to make the prompt. To make the prompt, we have to fit the budget, and yeah, that should be fairly easy. I'll probably be copy pasting code there. It's not very bad, there's not a ton of logic involved. All we have to do is ensure that each token is fit in, otherwise we trim it off. So it's kind of the same code again and again used. Let's go ahead and run or start the debugging. Let me push this down a little bit so that I can see some content, and actually we have no file created here, so it's going to be a bit of a problem. Let me go ahead and try to do something else. Maybe here I can create an animal class.py so that I can just see it in Python, maybe not in TypeScript. So let's have a class animal created here, and obviously this will result in API error. So let me just close it and write it down. Then maybe I can have a def init call, and maybe all I do here is self.name is equal to, let's say, lion, or maybe Simba. That's not a name, but maybe we have self.species, which is equal to the lion. Then we can say def speak, something like that, where we are just returning a string, and we say, hey, this return value is, and as you can see, it returns something quite weird. It returns def find max because the context being provided to the LLM is not good. As you can see, the prefix is just an empty list because we don't have any indexed symbol, and that's why I'm creating a class that is being referenced in main.py. So let's have return, and then we can have an f string where I say self.name is a self.species that roars. Great, good enough, whatever. I can't think of a better example, And then maybe we can have a class human that essentially inherits from animal, and let's have from animal we import animal, and then I can do, and now it predicts the right thing. Why does it predict the right thing? Well, that's because now our prefix contains the name animal, the kind is for, we have the URI, and then we have the signature. The signature is the one that matters the most. That will be the one that's used everywhere. And as you can see, the signature is class animal, def init, and then you don't have anything over here. Def init, and then it's just blocked essentially. The implementation is not shown. Then we have def speak, which returns a string, and its implementation is not shown either. That's good. That means our cross-file symbol is working. If you want, you can get more complex. You can run it on this exact code base as well, because it should work. Maybe we can try it actually. So let me close this folder. And I was unable to open the exact same tab completion. So I just opened up the source folder of this tab completion. And now I can go ahead and let's see where some sort of thing might be used. We have inline completion provider where, all of these various things are used. I go to AST service. So that's indexed now. And let's open up the output tab. We have the tab completion here. Good. AST service is initialized. I'm hoping the file was indexed. So I should be seeing AST service, or let's go to API client as well so that we can index that as well. And now let's hit enter. And as you can see, we have a TypeScript return with import API client from /API client, new API client output channel is passed in. That's pretty smart, right? It got to know the constructor, so it was able to predict the thing. Now, obviously, as you can see, it returns back, triples back, ticks and all of that. We are going to clean that off, but also we're just giving the LLM access to this particular thing, right? With just this particular thing, it's able to call the right, the method or the right class in the correct way. But what we have to do now is take the entire prompt and fit it into some sort of budget so that it doesn't overflow the budget and it doesn't cost us a lot, because when we run it at scale, we want the cost to be minimal. And then we can give it to the LLM, and then we can do all of the post-processing that's required. Now, I just want to show you the signature. So the signature for API client is this thing: class API client implements VS Code.disposable. There's an output channel, there's a pending request, then there's a constructor and it returns a promise. Then there's stream request. All of those methods are just shown, but their implementation is not shown, as you can see with log and this async generator, all of them. The next thing we have is this AST part, where we have the AST service, we have the signature, and yeah, none of the implementations are shown. So that's awesome. And that means our entire thing is working. Now all I need to do is create a completion context that will return everything. And this completion context is not coming from VS Code. We are going to create it ourselves. We are going to have an interface of completion context here. Let me define all of them. So the first thing that will be returned is the prefix, which is going to be of the type of string. Then we have suffix after the region. Then that's also going to be a string. Then we are going to have the replacement region, right? That is going to be of the type of replacement region as well. Then maybe we can also give it the cursor position, because that's some important context. We'll just add it to the completion context. Completion context is essentially what's given out of context gatherer, and whatever is given out is directly used by the budgeting and the LLM to basically build the prompt and give it to the LLM. Then we are going to have the language ID as well. Then we have the string, then we have the file path of what the current file is, because if you look at our data, we are also giving it a file path, right? The language, the file path, and the cursor position is over here. So all of those things are related to that. Then we have the edit history, which is going to be a string. And then we have the cross file symbols, which is going to be cross file symbol. And let's go to the cross file service and see it's being used. Okay, cross file symbol is just index symbol as a list. We can have that. Let's import index symbol. Great. And let's go ahead and return this from here. So instead of json.stringify, we're going to return everything. So the first thing is prefix. That's good. Then we have the replacement region. That's good. Then we have the suffix after region, which is just suffix. Then we have, and actually, let me see, we've not got this right. I wanted just replacement region, not replacement region stage. Let me remove this replacement region stage, because replacement region stage is the actual class. What we are interested in is the type replacement region, which is an interface created, right? After that, we have the next thing, which is, let's see, the cross file symbols. I have access to them. Okay, good. Then we have the next thing, which is cursor position, which is going to be the position, because yeah, whatever is the cursor position is the one given to us from inline completion provider. Then we are going to have the file path, which is going to be vscode.workspace dot, and let's say as relative path. And then we'll pass in the document.uri, which is going to be, well, the file path, right? Then we're going to have the edit history. Then we're going to have the cross file, or we've actually had the cross file symbols. Maybe we've returned everything or something is missing. Language ID. Okay. So the language ID is going to be document.language ID. Awesome. Now, if we go to the inline completion provider, here we're not going to get the prefix. We're going to get the completion context. And now if you want to print that out, you can, but you'll have to stringify it. Otherwise, it's probably going to return object or something like that. Maybe you don't want that. So let's have completion context and see if everything works out as we expect it to. Let's see over here. What is the error? Obviously, the prefix cannot be formed here. We're going to skip it for now. Later on, we're going to build the prompt and pass that in. Now, let me run and start debugging so that I can see the log output. Let me open up the terminal as well. I'll go to API client, AST service. Now, let's see if we have my cursor somewhere over here, we have the completion cache. All of this context is returned. It's not at all good looking, but yeah, it's there. Obviously, the model gets confused because we're just saying complete the code, but what code does it have to complete? We have not passed that in, so something weird is returned out, but we're more interested in this. So let's see. Let's see if our prefix is correct, and the prefix is this import everything. It's just going to return everything because it's less than 150 lines. That's good. Then the suffix after region is just empty. Makes sense, right? Because there's code after this line. Then there's signature of class AST service. That's also good. And the file path is properly mentioned. Edit history is not there at all. And the language ID. Maybe I'll add this dot, and now we'll have some sort of edit history. And as you can see, edit history shows up. We edited the line providers in line completion provider.ts. Line 25 is now this dot. Great. That means everything's working, and the language ID is also correctly showing up. That's awesome. I can close this tab, and now we can move on to the next thing. But before that, I would like to clear off some stuff, right? I mean, we have our cross-file service within which, we did the signature provider, and signature provider had the cache maintained. I would like to clear that off. So I have a clear function here. It's going to return nothing, but what we're going to do here is this dot signature cache dot clear. Then we also have this dot, or maybe that's pretty much it. So we can just clear that signature cache off. Then we can go to the cross-file service and do this dot signature provider dot clear function. Similarly, we're going to do it for another function where we have a reference extractor. Here we're not really doing anything, so maybe nothing over here. Then we have the symbol index, right, where we are tracking the cache and the tracked URIs. We're going to have a clear function on this. Then we are going to return nothing. Then we have this dot cache dot clear. Then we have this dot to, or not to, we are going to have the tracked URIs dot clear, and then I'll call that function in signature or cross-file service again. So I have this dot, let's see, symbol index dot clear. Awesome. That's just disposing of all of the useless stuff. It's no longer required, and we're all set now. So let's move on to the next thing. We're done with the biggest chunk of this tutorial, which is context gathering. Now it's just budgeting the token, putting it in the specific format, which is kind of like this. And you probably don't need me to code this out. You can do it yourself, but I'll just paste the code in so that we can go faster and we don't waste much time on this part. But let me go ahead and create a new function or a new class, which is called prompt builder, and that will be present in the services. So I have prompt builder.ts, and that's it. Then we can have an export class prompt builder, and yeah, that's pretty much it. Now we can go ahead and create the function we need. Now let me go ahead and paste the first function, which is going to be build prompt. So what is our goal here? The goal is that we build kind of the messages and just have one list that we can pass to the LLM. If you'll notice in inline completion provider, what we are doing is passing in the system and the role, right? I want to basically pass in the system prompt that we're going to have a hard-coded string, because system prompts always need to be hard-coded strings because they can utilize all of the KV cache and all of those capabilities. Basically, it will make our entire thing run faster, and it will also be cheaper to run because they'll cache the system prompt behind the scenes because it doesn't change. System prompt is essentially telling the LLM what to do, how to do, giving it some context about the user prompt. And in the user prompt, we're going to pass in this entire schema. All right, and that schema is going to change. So this is non-static and this is static. And if system prompt is static, the LLM or the LLM providers, if they've enabled it, can have caching behind the scenes that will make our thing cheaper and run faster. Cool. So what I want to return from this prompt builder is this message list. I want to have a system prompt and the user role, which contains all of these things. All right. So what are we going to take here? we're going to take the completion context, because if you remember, completion context is the thing that we defined in, I believe, in context gatherer. So if we go here, we'll see interface completion context. If we just export it, we'll be able to use it. Or what you can do is extract it from here, then go to types.ts and add it in over there. So we have export interface completion context here. Then we are going to take this completion context from the, not from here, but we have to take it from utils.types. Ensure that you don't use, well, first of index and replacement region, but also ensure that this completion context comes from types, not from VS Code. Now we can go here. We can also import completion context, but first let me just add other stuff that I have, which is chat message. What is a chat message? Chat message is essentially, what is the role going to be and what is the content, similar to what we have over here. Just two things. Let me go ahead and define the interface for it. It looks something like this, where you have the role of system or user or assistant. There's just 3 roles you can have. And the content is a string as expected, because that's how it's happening in inline completion provider. Now, we can import that as well. But let's go ahead and build the user prompt, because we'll need the user content, and then we can return this list where the role is the system, content is the system prompt that we'll paste in, then the role is user, and the content is the user content that we'll get after building the user prompt. Now, build user prompt is in a separate helper function of its own. The reason for that is build user prompt is going to have that budgeting feature that I talked about. Cool. So let's have completion context first from utils types. Then we have chat message from utils types. Then we are going to paste in the system prompt so that one thing is done and we only have to focus on the user prompt. And this is what the system prompt looks like. You can paste it from prompt builder that's present in the GitHub repository, but let's walk over it quickly. So we are just telling you're a code completion engine that can replace existing code. That's giving the AI identity. Then we have the format. What is the input format going to be? Because there might be some models that don't understand the types, right? So we just let it know what it's dealing with, but most models should know, otherwise you shouldn't be using those models. And if you train your own custom model, which we'll talk about when we use Fireworks, you want to ensure that your model knows about these tags, because they are the most important thing. If the model doesn't understand it, it will not be able to predict what comes next. Then we have the prefix, which is the code before the cursor with an inline cursor marker at the exact cursor boundary. Then we have replace region, text from cursor that may be replaced. As you can see, may is kind of caps locked because it may be replaced. It doesn't necessarily have to be replaced. Otherwise, the model will try to replace it every single time. Then we have suffix, which is code after replace region, read only context. That's good. What is the task we want to output? What a replace region should become? This may involve keeping some or all of the existing text unchanged, inserting new code, replacing incorrect or incomplete code, deleting an unnecessary code. Then the rules are that it only outputs the replacement text, nothing else. No markdown, no backtext, no explanations are required. Even then, the model sometimes just gives the explanation for some reason. So what you want to do in that case is clean the output, and that's what we're going to work on after we have given the context to the LLM. Then we match the surrounding indentation and style. Be minimal, only change what's necessary. If the region should stay unchanged, output it verbatim. Then if inserting at cursor with no changes to region, prepend your insertion to the existing text. That means, if your cursor is over here and it's inserting a cursor with no changes to region, it is not changing anything, then it should prepend the insertion to the existing text. But most of the times the models doesn't follow all of these instructions, but just in case it helps. The output format is that it should output the user complete replacement text, just the raw code, nothing else. Great. And as you can see, everything is an XML tag, because even our user prompt is going to be in the XML tag. It will just help the model understand better, and there's better segregation of what we want to do. Now let's go ahead and push the system prompt in, and now we have to build the user prompt. And this is the function. It's going to be a private function which builds the user prompt. It takes in the completion context and returns a string. After that, we're going to have to import the signature. So understand what we have with us. Within the completion context, we have the entire cross-file symbols with us, right? And within this cross-file symbol, do we have our signature passed in? So we need to go over all of the index symbols and then try to extract the signature from all of them and push it in so that we can get all of the imported signatures, because crossfile is the imported signatures, right? So let's create a helper function for that as well. And I'm directly going to paste this in because we just take the context, we return a string array instead of index symbol array. What we're doing is just the conversion from index symbol array to string array. And what we are having here is context.crossfile symbols. We don't really need this line. Maybe we just need this part. If there are no symbols, we return an empty array. Otherwise, we have a result which is empty array. We go over each symbol. If the symbol or signature exists, we push it to the result array and then we return the result. We're all set then. This is what get imported signatures is. And you might be wondering, why should we not just do it in context gatherer? And you can definitely do it. When you try to get the relevant symbols from here, instead of returning an index symbol, maybe you can go over all of the signatures that are extracted and then return the string array instead of the crossfile symbol. But I've returned it just in case, in the future you want to do something with crossfile symbols, it might help. So, but anyways, if you want, that would be a cleaner way to do this. But here I'm just creating a helper function to help me get the imported signatures. Now we have all of the context that we require within a string format, because everything is needed in string so that we can just pass it to the LLM, right? LLM is not going to understand our custom types. Once we have that in, imported signatures is in, everything else can be easily converted into a string. For example, we have prefix as a string, replacement region.text is a string. Then we have all the other things which are all strings, okay? So what we want to do now is fit to the budgets that we define. And this is another helper function that we'll have to create. We are going to create fit to budget function, where we'll pass in the system prompt, because, we want to calculate, right, how much tokens can be assigned to the system prompt, how many for prefix, replace region, suffix, imported signatures, edit history, all of them. Cool. So we go ahead and create that function, but before that, you can see there's another tag over here, prompt overhead tokens. What are these things? Prompt overhead tokens is just how many, tokens are kind of used for the XML tags, because this particular tag, this is kind of useless for the model basically. So how many are these XML-ish tags present that will help us, or that need to be accounted for? So we'll have a constant default prompt overhead tokens. Let's say it's about 50. Maybe it's more, I don't know, but that seems good enough. And we'll use this so that we can fit to the budget. So if nothing, let's say we combine prefix, suffix or something like that, and it isn't in a particular threshold, or it's not within a particular threshold, we trim the value, so that we don't overburden the model, and also we don't overburden our costs, right? This is very important. So let's go ahead and create the function to fit to budget as well. Now in fit to budget, there's a certain structure that needs to be followed. All right, first let's create the function and I'll explain you. The fit to budget function looks like this. It can be a private function as well. Maybe let's make it private. Then we have all of the parts that need to be passed in, which is these things. As you can see, they're within an object, right? So we are going to create a fit to budget input that will take all of these things, and we're going to return fit to budget result, which is almost similar to the completion context, but this time everything is going to be a string because we are fitting to the budget and returning the result. So let's create both of these interfaces. I'll just create it in this file because it's not really a shared types that exist. Let me paste this in. We have fit to budget input where the system prompt is a string, prefix is a string, everything that we have is a string. So we just have it similar to completion context, but this time the types are not present that were present in completion context. We just have everything as a string or a string array, right? Because imported signatures can't be a string just yet, it's a string array. Later on, we are going to convert it into a string, as you can see. So we get this as the input, and everything here is going to be a string as the output, because then we'll just take those string, pass it in a mega string, which will be passed to the LLM, right? So what this function is going to do is fit to the budget and return everything as a string. And within this function, we're going to create this string that's done after, all of the compression that we had to do, or the trimming that we had to do to fit to the budget, the number of tokens that are assigned. And then we can call it within, we can call this function within the LLM API, right? So we have fit to budget input and fit to budget result, which is created. Now let's go ahead and fit to the budget. So the first thing we want to realize is how much budget do we have for the input, right? What is the total amount of tokens that we have to pass in as the input? What is that? Well, we're going to define a set of tokens that get assigned to each and everything, right? I mean, system prompt should be this long. Then let's say prefix needs to be these many tokens. If it exceeds that, we trim it out. That's the basic plan. For that, we'll have to go at the top and define what the default budget looks like. And I'm not going to create an interface for it. I'll directly use this. So the default budget is something like the system prompt is a maximum of 1,000 tokens. Current file is 6,000 tokens. As you can understand, current file includes prefix, suffix, replacement region, all of that. Imported signatures is 3,000 tokens. That is cross-file symbols. Then we have edit history, just 500 tokens because we are storing just 35 of them. But if you want, you can increase it up to, let's say, 1,000, and you can decrease it to, let's say, what was this earlier, 500, you can decrease it down to 3,500. Or if you want to make it more sense, 1,500 and 3,000, right? Because the total is essentially 15,000. So you can manipulate them. Output space is rarely going to be more than, let's say 1,000 tokens in my opinion. But anyways, we have edit history as 1,500, output space 3,000, buffer 1,000, and total is 15,000. Now we can calculate how much input budget we have left. Also, one thing to note here is buffer. Buffer is how many tokens do you have that can be plussed. Like 14,000 is essentially where you cap for all of these things, but 1,000 token buffer so that it can be used anywhere else where it's required. So let's go ahead and create the budget of how many tokens we have as an input. This is what it looks like. So the input budget tokens is equal to the default budget dot total, that means 15,000 tokens, minus how many ever tokens are used in the output space, minus whatever we have in the buffer, right? Because that is the input that's given to the LLM. The system prompt, the current file, all of that comes in. So we just remove all of the things that are not inputs like output and buffer. That gives us the input budget tokens. Now we need to fit within all of these input budget tokens. The next thing I want to do is calculate how many tokens I have in my system prompt. And to do that, I'm going to create a helper function called estimate tokens, and our estimate tokens function is going to be as easy as it can get. I'm not trying to mimic production, so I'm not using anything like tick tokenizer or anything like that so that we can get the real number of tokens. I'm just going to divide the system prompt by 4, and whatever is the value is the token, because here we are assuming that one token is equal to 4 characters. All right. So system prompt might have, let's say, 1,000 tokens or 1,000 characters. So we divide it by 4 and we have 250 characters or 250 tokens. Sorry. One token, 4 characters. So let's create a helper function for that as well. We have estimate tokens. What we're doing here is taking in a text, returning a number. If there's no text, we return 0. Otherwise, what we do is math.ceil, which returns to us the upper bound, because it's ceil, right? If we use floor, it would give us the lower bound. So if we have something like 4.5 return, it will take 5, because it makes sense, right? I mean, if you have 4.5 tokens, you want to take the upper bound because it's just 5 tokens. What is 4.5 tokens? It doesn't mean anything. So text.length, maybe whatever is the length, 900, 1,000, whatever. And we divide it by characters per token. And we are assuming that 4 characters is 1 token. So we divide it by that and use that. So we have the system tokens, and now we can calculate the remaining tokens. And remaining tokens is just input budget tokens. Whatever we calculated is the remaining tokens minusing out the output space and the buffer. Then we minus out the system tokens because system tokens are already taken, and then you minus it by the default prompt overhead tokens, which is about 50, right? So you take all of these out, and then you have the remaining tokens. Because remember, we have added the XML-ish tags for system prompt, that's included, but there are XML tags that will be added in the user prompt as well, right? This file thing, this types thing, they're not added yet. They're all real content as of now. Types just contains the interface. It does not contain this XML tag. So we're minusing off the XML tags that are going to be added later on. Then we'll also have another function that will convert the tokens to characters. So earlier we did estimate tokens with divided by 4. Now we multiply it by 4 so that we can convert the tokens to the characters. So 250 tokens is 1000 characters. So we just multiply it by 4. And yeah, then we can go ahead and tell that the maximum characters we can use is this dot token to characters remaining tokens. So earlier, we converted system tokens so that we could get the remaining tokens because everything was in the format of tokens or in the unit of tokens. And now everything is back to characters because that's what we really understand. And now the trimming is going to begin so that we can trim off all of the stuff if it doesn't fall under our budget. So the first thing we'll try to truncate down is the edit history. Edit history is, the edit history, whatever is the intent of the user that we were tracking. And we truncate 2 tokens depending on the edit history and the edit history budget that was assigned through the default budget, right? Let's create a function to truncate 2 tokens. It's a pretty simple function and it looks like this. We have truncate 2 tokens, text string, and the maximum number of tokens that are assigned to this particular section. Then we count the maximum number of characters where we are converting from tokens to characters, right? Because edit history is still in the form of tokens. What we want to do is convert it into characters because we understand characters. And then we can have, if the text does not exist or the text length is less than equal to max characters, we don't have to trim off anything. It is under our budget. Because, if the prefix is 1000 characters and let's say maximum characters was assigned 1200, it's in the budget, we'll return the text as it is. Otherwise, it's not in the budget. And what we'll do in that case is slice off from the beginning to the maximum characters. So we take the first 1200 tokens that are assigned or whatever max characters tokens are assigned and we trim it off. So that's edit history. Similar thing needs to be done for another thing, which is imported signatures. So what we do here is truncate 2 tokens. Now imported signatures is in the form of string array. What we need to do is join it by a \n so that we can get the entire string. And the default budget imported signatures is given so that it can grab the first, let's say 3000 tokens if it exceeds the budget, right? Next thing we have to do is find out the current file cap. Right? The current file cap is something like this. We convert the current file tokens into the characters and then we extract the prefix, the replacement region and suffix because these all belong in current file, right? Because current file is just what is in the current file. The current file does not include the imported signatures. It does not include recent edits. It includes the prefix, the replacement region and the suffix. So we take all of them to calculate the current file cap. So we have current file cap in tokens and prefix, replace region and suffix extracted out. And here comes a big logic. I promise this is the only big logic that's present in prompt builder. So this is the logic. I've put in comments so it will help. So what we want to check first is if the combined text exceeds our character budget, we need to trim. So the first check is kind of similar to this one, but this time we'll have to do this. We have to take the prefix length, the replace region length and the suffix length to check if it is greater than file cap, right? Because if it is greater than file cap, then only do we need to kind of change, right? I mean, that's the only time we have to trim. Otherwise we can keep using this prefix, replace region and suffix. Then what we do is check hey, the replace region is never trimmed. Figure out how many characters remain for prefix plus suffix, because think about it. If we trim out the replace region, it will cause model problems to our model. Because if you like cut off return user, something like this, the model will suggest a wrong thing. We cannot can trim out the replace region. That's the most important thing in our current file. I would say arguably the most important thing that's present in the entire file. So we cannot remove that. So what we find out is current file cap minus the replace region dot length. How much tokens do we want to keep? So this is the logic. The replace region is never trimmed. Let me remove the comments that I've explained. Then what we say is that we want to give 70% of the remaining budget to the prefix. So that means the code before the cursor matters more than the code after the cursor. And also in suffix, we know that it's always going to be quite less, because all we are having is an empty thing or just a closing bracket of some sort. So yeah, that's good. We can give 70%, or we can also give 90%, whatever you want. Let's switch to 90%. So 90% of the remaining budget is to the prefix. If it exceeds, then what we're going to do is slice off the prefix. So what we do here is math.ceil keep into 0.9, because here keep basically means how many tokens do we have left now, because replace region is not going anywhere. So now we have the prefix share. The prefix share is just whatever is keep multiplied by 0.9. Maybe it's 14,000 or 10,000 tokens. Let's say 10,000 tokens are kept. So you multiply it with 0.9. So you have 9,000 tokens left. Cool. That's what prefix gets. And let's say if it's less than the prefix length, well, the prefix share is going to be whatever is the prefix length, right? Let's say prefix length was 10,000 tokens, and the math.ceil is 0.9 or 9,000 tokens. So we are going to take the 9,000 tokens one, not the 10,000 tokens one. But if prefix length is smaller, well, we can adjust, right? It's flexible then, because why should we assign it 9,000 tokens if it's only, let's say, 3,000 tokens, right? So we kind of change and say, okay, prefix now gets 3,000 tokens and the suffix will get whatever budget is left over, which is keep minus the prefix share. So that means, whatever is minused off by replace region, we also subtract off prefix region, because that's everything remaining for the suffix share. And suffix share is also going to take suffix.length if it's smaller than keep minus prefix share. Because, it's the same logic. If the suffix is about 10 tokens and it's assigned, let's say 10,000 or let's say 1,000 tokens, for example, why would it take 10,000 tokens, right? It will only take 10 tokens. So that's what we're doing here. And then we slice off the prefix. So we keep only the end of the prefix. That means the part closest to the cursor. So what we're doing is prefix.slice, and then I take prefix.length minus the prefix share, because let's say, we have 3,000 tokens assigned to the prefix.length. The prefix share is 1,000 tokens. So we start off from 2,000 character, and from the 2,000 character, we take the next bunch of prefix. So we get the remaining, you can say, 1,000 tokens that are present. Cool. So the part closest to the cursor is kept. Basically, if you have a long prefix, the part closest to cursor, it will keep these things. It will remove all of these things if required. So the priority is given to the things that are closest to the cursor. Makes sense, because it's prefix. We want to keep the code closer to the cursor. And suffix is the opposite. You keep only the start of the suffix, the part that's present right after the cursor, and we're set. Once we have done all of that, we've kind of trimmed out whatever is needed. We've truncated the edit history, the imported signatures, the current file cap. So let's just go ahead and return it. So we'll return the prefix, the replacement region, the suffix, the imported signatures, and edit history. But we have a problem. Imported signatures is, well, a string. Okay, yeah, we converted it into a string when we did truncate tokens to characters. But anyways, okay, cool. Let's also remove max characters. It's not needed anymore. The same goes for system and input budget tokens. I had another layer of trimming down, but I don't think it will be required. What I had essentially is that we have the total number of characters present, and let's say even after calculating all of them, we're still not in the budget. So what we do is trim off in a certain priority order. So we remove off edit history first because it's the least kind of preferred to us. It's just enhancement, it's not critical. Then imported signatures, that's as well not very critical, it's just enhancement. Then we remove off the prefix, suffix, and as a last resort, we cut off the replacement region. But I don't think it's required because we are truncating to the token budget that's assigned. So we should be fine. And yeah, I'm just returning it as it is. So this is our fit to budget. So let me go ahead and have the fitted declared here, and let's use it. So we'll have the entire output created, right? The output is going to be whatever there is over here. So if we have the language, we'll insert this tag. Then we'll have the types, then we'll have recent edits, all of that pushed. And I'm going to go very quickly on this one too. So the very first thing is this one where we have the file tag, where we have language is equal to context.language ID, and then we pass in the path, which is the context.file path. We are passing in both through the completion context, and then we just need to create parts.push, and then we push in this \file so that we've kind of completed this entire file. Then the next thing we have within it is this thing, which is called types. So for that, we'll be using imported signatures. So we check here, if the fitted.imported signatures is present, then we have the types XML tag, we end the types XML tag, and within that we have the imported signatures written out. Cool. The next thing we have is the edit history, and for edit history, we are going to have the same thing, but this time recent edits, fitted.edit history, recent edits. Great. Now after that, if you notice, we have the prefix. The prefix is always going to be mentioned. So we have parts.push prefix, then the fitted.prefix comes in. And after that, I've also passed in the cursor, right? Because wherever the prefix ends, that's where our cursor is, because that's how we have aligned our fitted.prefix to be. We've not trimmed off any values. We've not done anything. So the spaces will remain. So let's say my prefix is over here. Let's say my cursor is over here, right? The prefix will be this entire thing. It will include all of the spaces and stuff. Like for example, let's say my cursor is over here. It will include these spaces, and then we will push in our cursor. So our model knows exactly where the cursor's position is. Then we have the prefix tag ending. Then we have the replace region and the suffix. Cool. So we have replace region, fitted.replace region, suffix, fitted.suffix, and that's great. So that's pretty much it. We have the entire parts now. So what I can do is return parts.join, and then I'll do \n. So we have this entire thing in a string format, and we've built the user prompt. All I need to do is call build prompt, which I'll do in context gatherer, or actually with an inline completion provider. So first, let me create a new class. Let's call this private read only. Then we have the prompt builder, which is of the type of prompt builder. Then we have this dot prompt builder is equal to the new prompt builder, and I'll pass in this dot prompt builder dot, and then I can calculate the user token or whatever. So we have the completion context with us. I just need to take this completion context and pass it in. So this dot prompt builder dot build prompt, then I pass in the context, which is the completion context. And then I can take whatever value is given out, which is going to be a chat message, and pass it in over here. So I'll have, let's say, constant messages is equal to this thing. And once you have done that, I can take this message and kind of pass it in over here. Great. Now what is the token? Well, that's the cancellation token. And now we're all set. Now we can go ahead and run this entire thing. So the entire logic is given out now. Also, instead of JSON.stringifying completion context, we can stringify the messages list. Now let's start debugging. Let me go to API client AST service. So those files are indexed, and then we can, let's say go over here, somewhere here, so that we get access to the cross-file symbol. I'll also open up this tab completion tab. Now let's hit enter, and you can see the entire thing shows up. And then we also get this dot context gatherer dot initialize. That's a prediction that's given, but as we know, context gatherer doesn't have the initialize function, and the reason it calls initialize is because it doesn't know what's present in the context gatherer. So let's go to the context gatherer next. Now it knows there's no initialize function in it. Let me call this again, and it's using the cached value. As you can see, no API call was done. It's just the cached value showing up. Let's hit enter again. A new API request is sent, and then we get API client.getActiveProvider.onDidChangeProvider, and then the completion cache shows up. And as you can see, the getActiveProvider is present here. So that's good. And the entire thing seems to be working. We're also getting our tab completion. Awesome. Now, the next thing I want to do is, well, there are multiple issues as of now. The first main issue that I want to tackle is cleaning off the output. Sometimes the model will still pass in the backticks. Even though in our system prompt we've mentioned, hey, I never want backticks, it will still pass in the backticks. I want to clear those off. That's a simple regex expression, but it's quite a helpful thing to have. After that, we are going to have a deduplication service so that we remove all of the duplicated things. And that's also going to be relatively straightforward. After that, we will go ahead and compute the minimal diff so that we understand what is the new stuff added, what was the stuff that was removed. And then we can display the deletion decoration range, and I'll talk about that. After that, we're going to go back to our API client because we'll notice that everything's working properly, but the speed is not there. Right? The LLM model that we are using right now from OpenRouter is too big, too large. What we want to do is use a smaller model that will help us give the answer faster, and we'll be using other kind of the providers that are present, Groq and Fireworks. After that, there's more stuff that we need to do related to intent tracker, because right now we've only handled edited, added, and all of those things. But we also want to add other things like, the user, let's say, rejected or accepted our suggestion. So that's the two things that we want to add. Here you can see there's pasted as well. So we are only using added, pasted, and edited. The two things I want to add is record the rejection that was done. For example, the ghost suggestion was displayed to the user somewhere over here, and then the user just pressed escape so that they could not have that completion. That means it was a wrong suggestion. So that's helpful context to the LLM to know, yeah, hey, the user didn't like this suggestion. And then we have the exception. So the user pressed tab, so they had the entire ghost suggestion showing up. So we record that exception. Then the final thing we're going to have is a new UI feature where at the bottom, we essentially show the tab completion status bar. Is it in an error state? Is it working fine? Is it loading? What is it? That's the last thing. And then we're all set with the entire thing. So lots of small things to do, but we'll be done very quickly. Now, just to go back, we only want to add for now the cleaning of the LLM response. So we remove the backticks and all of those kinds of things. Let's do that. So let me go ahead and create a function to clean the completion text. So I'm just going to have this dot clean completion text, something like that. And we're going to pass in the completion that we have, the string, and it's going to return to us some sort of text that we are just going to store in completion, right? Because the completion is over here. We're just reusing the variable, passing it in, and whatever is the cleaned version will again be stored in that variable. And then we do all sorts of stuff with it, like putting it in the cache, activating the completion, all of that. So let's go ahead and create the function. I'm going to paste this in as well, and let me just do it right at the end of the file. So I'll just paste it here, and it's quite a simple function. Well, it's a private function which cleans completion text. It takes a text as a string and it returns a string. Then we have let cleaned is equal to text.replace, and then we have a regex part that we are replacing. Because think about it, what are we trying to do with clean completion text? Well, the model many times returns the output in a format like this. So they say, okay, you have your code, which is, let's say, in Python, and they just return a text with, let's say, def hello. So like, we only want this part of the text. We don't want this particular thing. So what I'm doing is removing these backticks that are present. So what this does is that we are checking that, hey, is there this triple backtick at the beginning of the text? And then is there a word after it? And that word can be 0 or many times present. And then there's a new line, and then, the new line can be optional. That's what we have over here. We have 3 backticks with Python as the word. Then there can be multiple other words present here, but we only have this one. And then we are going on a new line, but that new line was optional because many times the model can just return something like this. But yeah, we do have a new line, and what we are doing is saying that, hey, this particular thing that we have, remove that. So yeah, we go ahead and remove it. So this entire thing gets replaced by an empty string. But still we have these triple backticks present. So what we want to do is replace on a new line, there would be this triple backticks, and it's at the end of the completion, right? Because even over here, it's at the end of the completion. So that's what this $sign does. This anchor sign is the one that says, yeah, it's at the beginning of the sentence, and this $sign says that the triple backticks are at the end. And yeah, indeed they are. So it takes this, it replaces it, and we have the text like def hello returned. But there are other approaches that we also want to find out, because we've told the model that, hey, you should only return code all the time, and that will work sometimes, but many times it won't work because the model is not really smart. It is not really following our actions. It just looks at the code and it's like, oh yeah, here is an explanation of blah 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 blah. It's not returning code. So I have a simple explanation pattern built in, but if you want, you can go ahead and add many other things, because you can also detect if it's valid programming language and if it's valid Python syntax. Otherwise, you can remove all of the words that seem English, not Python, or let's say C++ or any other thing. So what am I doing here? I'm saying that there'll be 2 new lines, and after that there might be something like this where you have a beginning like note, explanation, all of that. If any of these things are present, what you're trying to do is replace them with an empty string, because the model might return something like this. So they've returned, let's say, hey, here's a note, and then they go ahead and pass in def hello, or let's say they have note, hi, something like this will only work if blah 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 blah, right? So like, if they do something like this, we are just removing this note from here. That's exactly what we're trying to do, because notice, whenever we have some sort of explanation that we found out that is present, we are not capturing it, and then we are having multiple spaces here, and then we are saying that it ends, right? So if this is the case, which is the case, we have note and then we have multiple words, and yeah, we're just removing this multiple words that are present. This is the clean completion text. Then once we have replaced it with an empty string, we are trimming at the end. Notice we are not trimming, because if we trim, what happens many times is, let's say there's some sort of indentation that the model allowed, right? So it called def hello like that, or created def hello like that in Python. But now, since we did, let's say, trim, what will happen is that this indentation will go away. And if the indentation goes away, the Python syntax is wrong. And therefore, what we want to do is just do trim end, because if it removes from the end, that's fine, because there's no indentation that side. It's most likely an error, or like something we want to remove. Because like, who does this, right? I mean, so many spaces after def hello, it's probably wrong. Once that's also done, we can, we've called the clean completion text. The next thing I have to do is just ensure that the deduplication service is on. Right now, I mean, with clean completion text, we won't be able to test if this is working or not, because in our case, our model does not really return those triple backticks or anything. I mean, you might see it once in a while, but it's hard to reproduce. With dumb models, it will do it multiple times. You can also engineer it to be, more focused by putting it in your prompt, but I don't think that's a very scalable solution, because sometime or the other there is a possibility that the model messes up, so we are just creating harness around that. Okay, once we have that in, let me go ahead and close all the save files from here and create another service, and this is called the Deduplication service. This is a service that will allow, or actually not allow, all the duplicated content to be present. So the way this works, and by the way, just to reassure what this service does, is that whenever you have duplicated content, it will detect it. So how do we find out if it's duplicated content or not? To do it, we run 3 simple checks. The first one is look behind. That means it avoids suggesting lines that are already above the cursor. The second one is structural. We avoid suggesting a whole block that already exists below the cursor. And the third one is look ahead. It avoids suggesting trailing lines that already appear right after the cursor. So you can think of it as, we don't want to repeat what's above the cursor, we don't want to rewrite what's below, and we don't want to add closing lines that are already there. Right? That makes sense? Let me go ahead and create a class. So we have export class deduplication service. Then we are going to have, let's say, a simple function called check. Here we are going to get the document, which is vscode.text document. Then we have vscode.position here. And then finally, we are also going to take the completion text or completion that we got, which is going to be a string. And then we have a function. Also, let me go ahead and import everything as VS Code from VS Code. That looks good. After that, we have to, check. So as I said, the first one is going to be look behind. But before that, let's just have a validation check. So the first one is, what if the completion text is not present at all? Right? I mean, there's a bunch of spaces that are present, but at the end of the day, the completion text is not present. So what do we do? Also, what is our output from here going to be? So first thing is going to be dedup output. So let me go ahead and create the interface for that. We have deduplication output. Then what is this going to return? Well, it's going to return a Boolean value of whether we should proceed or not after the deduplication. Then there's going to be a completion text, which is going to be a string. And then we are going to have a reason text if it is present. Reason text is essentially, hey, what was the reason that this deduplication was rejected? Mainly to log it out, but if you want, you can do other things with that too. So let me go ahead and have this check here. So if the completion text dot trim is not present, or completion dot trim is not present, in that case, I'll just return, hey, you can proceed, because it's not really a deduplicated thing. And then you can just show the completion text if you want to. You can also set proceed to false, because, I mean, it's just empty. What are we even going to show? So the next thing we want to do is the stage 1, which is look behind. So we remove any starting lines of the suggestion that already appear above the cursor. That is what we want to do. So let me have completion is equal to, and then we have this dot trim look behind overlap. And what will we pass in over here? Well, we'll need document. Let me pass this, right? So we have the document, then we have the position, and then we have the completion. All right, now let's go ahead and create this function. So we have private trim look behind overlap, where we're going to pass in the document, which is the vscode.text document. Then we go over position, which is vscode.position. Then we have the completion, which is going to be a string. And what are we going to return from here? Just a string, right? Because we want to trim the text that is behind. So let's take an example and I can explain why we are returning a string. So let's say this is what we have. So this is our goal. So the goal is that, we have the file above the cursor like this. On line 10, we have return X. On line 11, we have an empty bracket or like a closing bracket. After that, the model, gives a completion. It says return X, and then it has this curly bracket, right, on a new line, and then it again gives us a new line. That's totally acceptable, and we've seen evidence of that in our code base as well. It just returns the exact same thing above the cursor. So what do we want to do? We only want to keep this particular part, right? I mean, technically this particular part, because return X is present, so that thing is there. After that, we have \n on a new line, and then we have the curly bracket. Okay, so the curly bracket is also there. So what exactly is changing? Well, we actually don't want to keep anything because, yeah, what the model returned and what the file above the cursor are basically the same things. So what we're going to do is trim out this entire thing. Let's say if the model returned something like this, maybe the file above the cursor is just this much, and the model returned return X, then on a new line a closing bracket, and then a new line again. In that case, we will have to keep this particular part because return X matches this thing, and what's remaining is on a new line, the curly bracket ending, and another new line. We'll keep that. So this is our goal. Let's go ahead and have this goal accomplished. So we have constant all lines is equal to completion.split by a \n. That makes sense. And I don't know why we're not getting the proper autocorrect. Okay, maybe because I misspelled all lines. Also, I forgot to put a comma here. And let me remove this comment. It's a bit distracting. We understand what we want to do. Now, let's go ahead and have the non-empty part of this, right? Because, I mean, there will be cases where we will have to essentially normalize the string so that we can properly kind of compare the lines. For that, we will have to loop over all of the lines that are present and push to a list that maintains all the non-empty lines that are present, and we ignore the empty lines. So we have constant non-empty is equal to, and let's say the type of this is normalization, which is a string, and then we have the number where we pass in the index, something like this, right? So the normalized string and what is the index number of that line, we are going to get the line number. And well, this is going to be a list, and initially it's empty. Then we go over all of the lines. So let I is equal to 0. I is less than all lines dot length. Then we have I plus plus. After that, I'll just check, hey, if all lines at I dot trim does give us a value, that means we're all right, right? I mean, think about it. We've put everything in the format of a line, and then we are saying, hey, all lines at 0, if we trim that, is it an empty thing? If it's not, great. If it is, then we're not going to do anything. But if it is not, in that case, what we want to do is push to the non-empty part. So non-empty dot push, and then I'll pass in this thing where we have the normalization, and then we normalize the text. This is a function we'll have to create, and to normalize text, I will pass in all lines at I, and then I will also pass in the index number, and the index is going to be I. We'll understand why that index is useful, but first let's just go ahead and create this normalized text function. And this normalized text is more like a utility function. So we'll just add it to language utilities, or if you want to create some other file, you can have that. I'll just paste it here. And what this does is actually pretty easy. All it does is that it takes a text string, it returns a string, and then we replace in the text any spaces that are present or all of the spaces that we can find with like this string. And then we trim it out, and then we convert it to lowercase. Awesome, that is our normalization. Let me just go ahead and do this. So what we've done is removed all of the spaces that we need so that we can compare the lines properly instead of relying on indentation, because even if the indentation is wrong or incorrectly matched, the content is essentially the same. So I would like to have different, like just a normalized version for all of the lines where we remove all the spaces so that we can just compare the actual content. Great. Now, after that, let's say if the non-empty dot length is equal to, let's say 0, or you can put any other check, we'll just return the completion string. Okay. Now the next thing I need is I want to build a list of non-empty lines above the cursor. That means we include the part of the current line before the cursor, and then we normalize them so that, we can compare it again. So all I want to do is step 1, get all of the lines that are non-empty and present above the cursor. And to do that, we can create a new array. Let's call this look behind, which is going to be a string array, which is going to be an empty array initially. After that, we'll just have let line is equal to position.line. Then we have line is greater than equal to 0. And let's say we go to look behind dot length, and it's less than 200 because we want to get the last 200 lines, right? And what we'll do is line minus minus, because position.line is where our cursor is. If our cursor is at position.line and we want to go up, right? For example, my cursor is over here. I want to get access to from here. So I'll take access from here and then go to line 40, 39, 38, 37. And let's say if I'm on line 240, so I'll go until line 40 so that I only get access to 200, right? I mean, that's our plan. So either it satisfies the condition of line is greater than equal to 0. So we only go until line 0. And if we have more than 200 lines, we only capture the 200 lines. And we do that from here. So we go from 41, 40, 39, 38. So it's in kind of a reverse order. After that, I'll just check what the text is. And the text can be of two types. The first one is what if a line is equal to the position.line. That means my cursor is over here and the line is also over here on the same line. So in that case, I want to get the part of the current line before the cursor, right? So here I can just put a check. Yeah, if this is the case, then we are going to have document.line at text. Then I'll have dot text, or not line at text, line at line. And then we have dot text dot slice, and we slice from 0 to the position dot character, right? Because what we are doing here is my cursor is, let's say over here, I grab this particular text. If my cursor is over here, I grab this entire thing that's present. If my cursor is over here, we grab this thing and then we move forward, right? So that's what I'm doing. Now, otherwise, if the line is not equal to position.line, my cursor was over here, but let's say we have traversed over this. Now I want to get access to line 39. So in that case, what I'll do is just capture the entire line as it is. And to do that, I can simply pass in document.line at line.text. I don't need to slice until position.character. I get the entire line. And then I'll check if the text.trim is non-empty. In that case, I'll do look behind dot push, and I'll push the normalized text, which I'll pass in. And yeah, we're done. So we have normalized it over here. We have normalized it over here. Both are in the same format, so we can compare them later on. Now what we want to do is we essentially want to reverse, right? Because whatever we have right now is in the reverse format. I have line 41 first, then line 40, then line 39, then line 38. What I want to do is first have line 38, then 39, then 40. Cool. If you want, you can kind of change this as well. There is no need for me to do that. But the problem is we'll have to put in more kind of logic here, in the sense that I will have to first find out, what is the starting position, because the starting position can be 0, or it can be whatever is the line number minus the like the minus 200, right? Because if we have line 241, we want to go and start from 41. So we'll have to do math.min and all of that. You can, but anyways, reverse should not be a problem because it's essentially O of 200. But yeah, after that we can check if look behind dot length is equal to 0, we return the completion text as it is. The next thing I want to do is find out a special case. A special case is something like this. Let's say the user types return and the cursor is after return, right? The completion is URN X and then, we are on a new line. On screen, this looks like one line, right? Return X. To detect such kind of duplicates correctly, we treat prefix plus first completion line as an extra variant of what the first completion line will become once inserted. So the point here is that the user has typed return and we have URN X, right? So when we merge both of them, it becomes return X. And if you want to detect duplicates correctly, we treat the prefix plus first completion line as an extra variant of what the first completion line might become once inserted. So it would become return X, and that's what we're trying to find out. This is a special case that we're handling. So we'll have constant prefix is equal to document dot line at, then we have position dot line dot text, and then we slice from 0 till position dot character. Okay. After that, we'll have a variance. So the variance is going to be a string where it's an array of arrays, which is equal to, and then we have non-empty dot map, and then we map over each of the non-empty things and add it. So we have e dot norm done. So what we have done is stored one variant of non-empty. So whatever is present in the non-empty, we went ahead and added that over here. Now our job is to add other variants. Okay. So we'll check if the non-empty adds 0, and let's say it's non-empty adds 0 dot index is equal to 0, and let's say the prefix dot trim is non-empty. If this is the case, then what we're going to do is merge this in, right? Because if non-empty at 0 dot index is equal to 0 and the prefix dot trim is also present, in that case, we essentially want to take both of them and merge it together, and then we check if the merged value is not equal to the normalization value. If it is not, in that case, we can push another variant to the variants list. So we have normalize text, then we pass in the prefix plus the, let's say the all lines at 0, and then we check if the merge value is not equal to the non-empty at 0 dot norm. In that case, we'll have variants dot push, then we push in the merged values, and then we have non-empty dot slice, then we slice up till 1, and then we map e, and for each element that we get, we have e dot norm. Also, we have to pass this within a list. So let's have a list here. Okay. So let me just go over this again because I think this might be confusing. Again, what the problem is that we're trying to solve is, let's say the user has already typed something like RET, and now the completion suggests URNX : right? In that case, if you just look at the completion text by itself, the first line is URNX, right? I mean, that's what the completion returned. So that is the first line. But when you insert it at the cursor, the actual visible result becomes return X because the user has already typed RET. So if you're trying to detect whether the completion duplicates existing text, comparing only URN is wrong. Like if you just do URN X, that's just wrong. You also need to consider the merged version, and this is exactly what this code does. The first thing we do is get what the user already typed on the current line before the cursor. After that, we start with the normal completion lines. Okay, so non-empty is the completion lines after normalization, right? So if the completion is something like URNX, something like this, and I don't know why it does X context, then this line, the variants list would then be something like this, where you have URN X like this as the first element. Okay, so it has URN X like this as the first element. This means that there's one possible interpretation of the completion, and that is its own lines. After that, what we do is the special handling. If the first non-empty completion line is actually line 0 and the prefix exists, then we go ahead and merge it in. So this means the first, like this line, this particular line just means that the first non-empty line in the completion is the very first line of the completion. And that matters because only then can the type prefix merge with the completion's first line. If the completion started with blank lines or the first non-empty content was later, then merging with the prefix would not make sense the same way, right? And then we just go ahead and build the merged first line. And also this check is present because we don't want to add a duplicate variant. If the merged line is the same as the original normalized first line, then adding it as another variant would be pointless. We'll just be looping over more things later on. So yeah, we went ahead and added the variant as another possible variant. So this URNX that was present, another variant of it is stored here, which is RET_URNX. Okay, that's what we tried to do, and this is going to help us later on when we trying to find duplicate. So now what we want to do is look only at the last few lines above the cursor, which is a very small window, and try to find out the longest sequence of lines that matches the start of our completion, right? So we'll have constant window start, which is equal to maths.max. Then we have 0, comma, look behind dot length -5. Our window is of 5. So we just go 5 lines above the cursor and try to find out like the longest string of lines that, matches the start of our completion. So if our start of our completion was URN, we try to find if there's any other thing with URN, or, in this case, we also have another variant. So we'll try to find RET_URN. Because think about it, if we have RET and then let's say the completion was URN, if we try to find URN, we're not going to find anything because, which line here would be URN beginning with URN. But if we merge both of them, we have RET_URN. And if we have return, we know there might be some line starting with return. And, if it's the exact same line, we're just going to trim it out and all do all that sorts of stuff. So let's have let best match is equal to 0. Then we have for let start is equal to look behind dot length. Then let's say it's -1 because, the length is 1 indexed. Then we say start is greater than equal to window, or let's have window start. After that, we have start minus. So we keep going until we reach this look behind dot length -5. So we are going 5 steps. Okay. And then we do constant max compare is equal to math.min. Then we have non-empty dot length, comma, look behind dot length minus start. So what we're trying to find out is what is the minimum value that we can compare with, and like the maximum value we can compare with. And the way we're doing it is finding out what's the minimum between this non-empty dot length and look behind dot length minus start, because non-empty dot length might be, let's say, 3 lines, right? And then we have look behind dot length minus start, which is, let's say, 4 or 3 or 2. Whatever one is the smallest, we'll take that because we want to loop over it, right? So again, just to go back a little bit, this line was just for us to find out, if what are the last 5 possible starting positions. Then we find that what is the best overlap that we've found out, and this will essentially store like 0 if no lines are matching, 1 if the first completion line matches, 2 if the first 2 completion lines match, all that sorts of things. Then we try every possible suffix start near the end of look behind. So this loop essentially goes backward through the last few lines of look behind. And if look behind dot length is, let's say, 8, then start might go 7, 6, 5, 4, 3, 2, 1, and so on. So each start is essentially meaning what if the overlap begins here. And then we are computing how many lines can even be compared from the start. So this will just prevent it from going out of bounds. It can say like You cannot compare more than the number of completion lines, and you cannot compare more than the number of remaining lines in look behind from start. For example, if the non-empty is 3, look behind is 8, and start is equal to 6, then look behind.length minus this thing would become 2. Max compare will essentially be the minimum value of 3, 2. So we only have 2 lines that can be checked here. Because if you try to go to the third line, well, the look behind.length minus start is only 2. How will you go there? How will you find its third line? Now the next thing we do is we go over each variant that's present. The URN, the RET URN, we just go over that. So we have for constant variant or variant of variants. And then what we do is let matched is equal to 0. And then while the matched is less than the max compare and the variant at matched is equal to, let's say, the look behind at start plus matched. In that case, we are going to have matched plus plus. So what have we done with this loop? Well, we are just trying each completion variant. So we have URN, RET URN, and then we have let matched is equal to 0, a variable that's created, and we're just trying to count how many lines match in the sequence. So this is kind of like the main loop of this. It compares variant 0 with look behind at start, variant 1 with look behind start plus 1, variant 2 with look behind start plus 2, and so on until the lines stop matching or the maximum comparison is reached. So it is checking for a prefix of the completion matching a suffix slice of the look behind. Great. And now we also want to store the best match that we have found till now. So if the matched value is greater than the best match, then yeah, we have found out a best match which needs to be updated now, which is best match is equal to matched. Okay. So with this, yeah, we have a best match and we are going to return that. But let me just give you a more concrete example of what this does. So let's say our look behind is something like this, right? I mean, look behind is just looking behind the cursor. So if we have, let's say, true, and then we have something like this, and then we have return X, okay? Or maybe instead of closing bracket, we have foo called, okay? So this is our look behind. Everything is a line over here, okay? And this is all normalized. So the spaces are gone and all of that is done. Just consider that. And then our variants list is something like this, where we have the first thing as return X, and also let's add foo here as a variant. Okay. Then we also have another thing where we have URN X, and then we have foo called here as well. So if we try starting with 2, okay, so start is equal to 2, we compare starting from look behind at 2, which is foo. And the variant for that is return X foo, because we are comparing this line with all the variants. So we compare return X and foo with return X. So we compare, hey, return X and this foo, sorry, like not this return X. So we are comparing return X with this foo. There's a mismatch immediately, so matched is equal to 0. After that, we have start is equal to 1. That means we compare return X with this particular variant again. And now we have return X matching the return X that's present here. So that's good. And then we match foo with this foo. That's also matched. So now a matched value is equal to 2. And this is how it works. We're just trying to find how many lines match, and that will tell us how many lines or the first lines of the completion are already present immediately before the cursor. Now you might ask, why are we scanning multiple start positions? That's because the overlap might start at different places near the end. For example, let's say if I have a look behind that is like A, then you have B, then you have C, then you have D, and the variant is equal to, let's say, something like C and then D, the overlap starts at index 2, not at the very last line. So the code checks several possible suffix starts. It starts with D, then it goes to C and then compares D, then you have B, all of that, okay? So the mental model you want to take from here is that we take the completion, we see whether its beginning matches any of the ending section of the recent text behind this cursor, and we keep the longest match that's present. After this for loop now, we can go ahead and check if best match is equal to 0. In that case, we want to return the completion text. Then, if we don't have best match not equal to 0, that means we've matched some lines. What I'm going to keep here is, let's say if we matched n lines at the start of the completion, I'm going to drop those n lines and keep the rest because we want to trim it, right? I mean, if return x matched and foo did not match, I want to remove return x and just keep foo. So what I'll do here is return all lines dot slice. Then we'll pass in non-empty at best match minus 1 dot index plus 1 dot join backslash n. So what we do is go and slice until the best matches. So let's say we found 2 best matches. We're going to slice starting at that 2. So we have, let's say, the best match is 2. So we remove the first 2 things that are present and then we join with backslash n. So that is the trim look behind overlap. Okay. Now we move on to the next thing, which is the stage 2, where we have the look ahead. But even before that, I would like to check, hey, if the completion text dot trim is not empty now, in that case, we will return proceed false because we found a trimming and that's like not valid for us. It's just empty. We cannot proceed. We cannot display it to the user because there is a deduplication here. So we have completion returned, and after that we'll also provide, let's say, a reason, and the reason text is going to be all completion lines already exist above the cursor. Now we move on to the next thing, which is look ahead. So we have constant look ahead is equal to this dot build look ahead. Then we pass in the document and the position here. Let me go ahead and create the function to build the look ahead. So we have private build look ahead, and this is going to be a short one because we just have vscode.text document. Then we have a position, which is vscode.position. And what we are going to return from here is again a string. So what we're trying to achieve here is just build the look ahead single string that represents everything after the cursor. So that means it is the text from the cursor to the end of the current line plus up to 100 full lines below the cursor. So let me have suffix. It's pretty straightforward, so I'm not even going to give an example. We have suffix is equal to document dot line at, then position dot line. We've done this multiple times, dot text dot slice, the position dot character. So we get everything up until the character on that particular line. So everything on that line before the cursor. Okay. Then we have all the other lines that we want to create, which is going to be a string array. After that, I go from the position dot line plus 1, right? Because I already traversed over the content I needed from the cursor line. And then we go until the end and we have I++. Let's have end here, and I will have to calculate the end. What is the end? Well, the end is going to be document dot line count, right? But let's say line count -1 because we are one indexed with document.line count. But what if, the line count gets shorter, or let's say line count is, let's say 400 and we are on cursor line 200. What I want is the next 100 lines. I don't want the next 200 lines. So in that case, I will also have math.min, and then we have whatever is a minimum value between position.line plus 100 or document.line count -1, right? So if we have 400 lines in the document and our cursor is at line 200, we'll go and grab line 200 to 300. But if we are at, let's say, line 350, I only want to grab until line 400, not go until line 450 because that does not exist. So once we have this loop, I can just do lines.push. I'll push it to document.line at i.text, and then we have all of the lines. Now I just need to calculate the string, which is going to be, let's say, the below text or below string, whatever. And then we just have lines.join, and then we have \n. Then we return the below value. But remember, there's like a sort of condition we'll have to put here. We join suffix and below into one string, skipping empty parts so that we do not add extra new lines, right? So what we do here is check if the suffix and below both are non-empty. In that case, I will just have $suffix, and then we have \n, and then we have $below. Otherwise, the suffix or the below, either one is not present. So I can just pass in something like this, suffix or below, right? Or let's have below. Okay. So with this, we've built the look ahead text. We grab everything after the cursor on that line and the 100 lines below that. Good. Now that we have the look ahead string created, the next thing I have to do is check if there is nothing after the cursor. But even before that, let's have a simple check. If lookahead.trim is not there, in that case, we will return proceed to true, and then completion is returned. Okay. But now we have to check if there is nothing after the cursor. And for that, we are going to have the structural overlap. The structural overlap, again, is just to check if the body of the suggestion looks like a block that already exists below the cursor. So we'll have if this dot has structural overlap. In that case, we are going to pass in the completion and look ahead. Okay. And if this is the case, in that case, we will return proceed false as expected, and the completion is going to return. The reason is going to be, well, the completion is duplicating the existing code below the cursor, right? So that's done. Now let's go ahead and create the function called structural overlap, has structural overlap, whatever that is, private has structural overlap. Then we have completion, which is going to be a string. Then we have look ahead, which is also going to be a string. And yeah, we have this. And obviously this is going to be a Boolean because we're using this in the if condition. So what exactly is the structural overlap? It looks something like this. So that means, if the existing code below the cursor is something like this, const x is equal to 1, return x, and the model completes constant x is equal to 1, return x. As you can see, the spaces are gone. After normalizing spaces and indentation, the two sequences look the same. In that case, we should not suggest the completion because the code is already written. So we just reject it as it is. So that's what we're going to do. And to do that, we have constant completion lines is equal to completion text dot split. Then we have a \n. So we have all of the lines, and it's not completion text, it's just completion. And then we filter from each line. So we go over each line, and then we remove all the lines that are non-existent after trimming. And then we map each of the things, and what we map is normalized text because we want all of the normalization to happen here. And the same thing will go for the look ahead text. So we have ahead lines, which is equal to look ahead. So both come in a format that are essentially the same. And if the completion lines is less than equal to 1, or let's say the ahead lines or ahead lines dot length is less than 2, we return false, right? So that means the completion lines dot length is just 1, or the ahead lines dot length is just 1. Both are basically the same way of telling the same thing, because less than equal to 1 includes 1, and this is less than 2, which is just, less than equal to 1. So once we have this, what do I want to do? Well, I'll slide over the completion. And again, just to reaffirm, what we're doing here is that if we look at the lines after the cursor, do we already see this completion there? And if yes, the completion is redundant, so we reject it. And what this completion lines means is that it is the lines from the completion suggestion. Ahead lines is lines already present after the cursor in the document. And what we are doing here is trying every possible starting joint point in the ahead text. So what we'll do is slide the completion over the look ahead and check each possible start position. If at least two consecutive lines are very similar, we treat it as a duplicate block. So we don't want the exact same thing, because in look behind, we had to check for the exact thing, right? With trim look behind overlap, we are just checking if the string matches exactly. In our case, it doesn't have to match exactly, because there might be a case where it's structurally the same. It's not trying to be exactly the same, but what it means is basically the same. So we are going to use string similarity for that. We'll use our own algorithm, but if you want, you can use AST over here so that you can correctly match the things. I just didn't want to overcomplicate this. So what do I want to do first? I try every possible starting point in the ahead text. So I have for let I is equal to 0, I is less than equal to ahead lines dot length minus 2, I plus plus. Okay, that means we are starting matching at ahead lines at 0. Then we go to ahead lines at 1, 2, etc. but only up to minus 2. Why are we stopping there? Because the function only cares whether it can find two matched lines. If there's only one line left, it cannot possibly reach the matched is greater than equal to 2, right? So there's no point starting from the very last line anyways. Then we just do let matched is equal to 0 for each candidate at I. We are essentially trying to count how many consecutive completion lines match, and for each I, we are reinitializing it to 0. Then we want to compare the completion lines against the ahead lines from the start position. So what I'll have here is for let j is equal to 0, j is less than the completion lines dot length, and we have I plus j should be less than ahead lines dot length. Okay, and then finally we'll have j plus plus, or not k, j plus plus, and this will compare lines at 0 with ahead lines at I, compare lines at 1 with ahead lines at I plus 1, compare lines at 2 with ahead lines at I plus 2, and so on. So this condition just means that we do not go past the completion lines, and this means we do not go past the ahead lines. And now we go ahead and check if the lines are similar enough. And for that, we'll be using string similarity, and that's a function we'll have to create. Then we have comp lines at j, and we are comparing that with ahead lines. And as you guessed it, it's going to be I plus j, because if we are having I plus j less than ahead lines dot length, we are going to use ahead lines at I plus j, right? And if this is greater than equal to, let's say 0.85, in that case, we'll have matched plus plus. Okay. And again, this is just a fuzzy comparison that we're going to do. It's not going to be exact equality. So lines can differ slightly and still count. For example, if we have return x like this versus, okay, let me have this versus something like return x. Okay. In that case, the similarity should be higher and they're treated as matching. Or if we have foo bar versus, let's say there's foo like this bar, they're not exactly the same, they're spaces, but they are similarly high. So let me go ahead and create this string similarity function. You can create another utility file for it. I'll just put it in language utils to make this fast. And I'm just going to paste this in. There's two functions that I've added. The first one is string similarity. So we compute the similarity between two strings, and it's Levenshtein based. I might be pronouncing this name incorrectly. So it returns a value between 0, which is completely different, and 1, which is identical. And then what we're doing here is calculating the max length, which is, whatever is the maximum between A and B. If the max length is 0, we return 1.0 because, well, it's identical because, there's no length. Then what we do is find out the distance, and then we have 1 minus distance divided by the max length. So what is the distance? Well, the distance is computing the Levenshtein distance between two strings. It returns the minimum number of single character edits, or that means insertions, deletions, substitutions that are required to change one string into the other. Once we find that out, what we're doing is 1 minus the distance. So let's say the distance is 0.5. So 1 minus 0.5 divided by what the max length is. Maybe the max length is 2. So what we have is 1 minus 0.5, which gives us 0.5, and 0.5 divided by 2, which is 0.25. That means the string similarity is low, because it is just returning the minimum number of single character edits, right? I mean, if there's 2 edits, or let's say 5 edits required to make one string different from other, and then this max length is just 2, it might not be possible. But yeah, in that case, the similarity is quite high. So essentially what we're doing is finding out how many edits it takes to convert one string to other. And once we find that out, we are just using this score to find out the similarity percentage in a way. And this is the entire implementation. This is a very common Levenshtein distance problem. I'm not going over it. If you want, you can understand it through other tutorials. But yeah, this is a common algorithm. What we're doing is just finding out the matrix, filling in the matrix, and then calculating the number of edits it would take. Now, let me just have string similarity here. And once we've made use of that, what I'm checking is if it passes a certain threshold of 0.85. And once it is greater than 0.85, we say matched plus plus. Otherwise, the matched is greater than 0. And if the matched is greater than 0, it means that we want to break out, because, we matched a certain thing. So we get out of this loop and continue again. Once this entire loop is over, what we want to do is check if the matched is greater than equal to 2, because as soon as we find out that there's 2 strings that are the same, we return the true value, because yeah, we found out a structural overlap. 2 is enough. We don't want to calculate any further. And then after that, we just get out of this for loop. And let's say if still by this, it's still not able to match, then maybe there's no structural overlap. So yeah, we found that out. So that's stage 2. And then finally, we have stage 3, which is trailing overlap. So we'll have if this dot has trailing overlap, then we pass in, and let me just have overlap like this. Then we have completion, document, and then position. Then we have to return proceed false, because similar to structural overlap, if there's a trailing overlap, we reject that as well. Then we pass in the completion, we pass in the reason, and the reason is going to be trailing completion lines duplicate existing, or let's say duplicate code below cursor. Now let me go ahead and create the function to find out the trailing overlap. So let me just go ahead and create that function. So I have this function private has trailing overlap, where we get the completion text string, document, and a position. After that, we're going to return a Boolean value, and then let me show you an example of what I mean by trailing overlap. So let's say the existing code is return X, and the model completion is return X, similar to what we have seen before. If we already kept return X from earlier checks, we now look at the end of the completion, which is this particular part, and compare it to the start of the code after the cursor. So if they match, we should not insert another closing bracket, because it is already there, right? So that's what we're trying to accomplish here. At the high level, what we want to do here is 3 things. First, we extract the last few non-empty lines from the completion. Then we extract the first few non-empty lines after the cursor from the document, and check whether the end of that first thing that we extracted matches the start of the next thing that we have. So what we want to do is essentially a suffix of completion versus the prefix of document after cursor comparison. So let me just go ahead and split the completion into lines. Then we collect the trailing non-empty completion lines. And for that, we create a trailing array, and then we go over each of the completion lines .length -1 until, we've reached either one of those conditions. These might seem understandable now. What we're doing is, let's say our completion lines.length -1 is 4. We go until 0. Otherwise, as soon as we know that trailing.length is less than 5, or let's say it's greater than 5, we exit out. We've used similar condition before. So we are just walking backward through the completion line, and we're gathering up to 5 non-empty lines from the end. And why are we going backwards again? Because we care about the tail of the completion. Then I just check if completion lines at i.trim exists. In that case, I'll do trailing.unshift and pass in the normalized text. Why are we doing unshift over here? Because we are iterating backward, but we still want trailing stored in normal top to bottom order. So that's why we're doing unshift here and here itself. Otherwise, later on, we will have to call reverse and do all that sorts of things. Let's say in our example where we had return x and this. So the completion lines is return x as the first element and then the curly bracket as the second element, right? So the loop goes from I is equal to 2 or I is equal to 1 because we are going backwards. So it will first catch this curly bracket. It will keep that. Then it will go over this I is equal to 0. It will keep that return x. And after normalization, there'll be no spaces. So return x and curly bracket will be something like this. So this is our trailing. That's what we're doing. Okay. Now we move on to the next part. So the next thing is if the completion has no meaningful trailing lines, we want to stop. So we just put that early termination in. Then we want to build the document lines starting at the cursor. Essentially, we want to get the code after the cursor. So we'll have this comment, which just explains what I did. Build the list of leading lines starting at cursor. That means any text to the right of the cursor on the current line, then the next non-empty lines below up to 100. Similar to what we did in, similar thing that we did over here. Or in trim look or build look ahead, I believe. Yeah, somewhere in one of these functions, you might see where we have done something similarly. So let's do the first part, any text to the right of the cursor on the current line. And to do that, first we'll have the leading array. Then we have the suffix calculated, which is document.line at position.line.text.slice position.character, right? Because we've just seen this so many times. This is the same pattern we're using everywhere to calculate the suffix. And if the suffix.trim is present, that means there's characters after trimming, we push to this array the normalized suffix. Okay. As I said, this if there's spaces over here, it will become return x. Quite simple. So we've included the current line suffix. The next thing we want to add is the non-empty lines below, which is, the next 100 lines. So we'll have this end is equal to document.line count -1 position.line plus 200. But in the for loop, we are anyways checking if I is equal to position.line plus 1, I is less than equal to end, and the leading.length is less than 100, we increment I. Okay. So what have we done here? We scan downwards from the next line and collect up to the 100 non-empty lines that are present. So we scan at most 200 physical lines down, and we collect at most 100 non-empty normalized lines. These are just, caps that I thought of. You can change it. So let's take an example. If the document after the cursor is something like this. So we have this bracket, and maybe after that we have line 12 where we have console.log x. Okay. Then in that case, the leading would become this particular bracket, console.log x. This is what we've done. Just calculated the next 100 lines. Like, this is pretty trivial. We've done this so many times. Then we're checking if the document.line at i.text.trim is present. If it is, then we just push the normalized version into this, right? I mean, pretty standard. If you're looping over, we obviously want to push it to the leading array, and we push the normalized version. Yep. After that, we check if nothing meaningful is ahead. If there's nothing, that means the leading.length is 0. We just return false. If there's no non-empty text after the cursor, then trailing overlap is impossible. Then what we want to do is compare the completion tail against the document head. So we'll have this. So again, just a comment, we check if the last one line of the completion matches the first one line of the look ahead, or the last two lines match the first two lines, or let's say the last three lines match the first three lines. So we're just comparing the completion tail against the document's head. Again, coming back to our example, if the trailing is return X and this thing both are normalized and leading is equal to, let's say, this thing and then a console.log, right? Then max n that we are calculating here is going to be 2, and this is max n. We take the minimum value of trailing.length and leading.length. So if trailing has 3 elements, leading has 2, we go ahead with 2 because, we just want to find out the biggest possible overlap, and it's just the biggest overlap is limited by the shorter side. So that's what we have done here. And then we loop over and try overlaps of size n from biggest to smallest. So first we try the largest possible overlap and then we try the smaller ones. This is good because if two lines match, we can stop immediately without bothering with one line checks first. So what we do here is build the tail, which is taking the last n lines of the completion tail. For example, again, if we have return X and an empty bracket or the closing bracket after that, and if n is equal to 2, the tail is going to equal to, let's say, return X and an empty bracket. But if n is 1, in that case, the tail is going to remove that return X and just keep the closing bracket. So we're just removing the first n elements essentially, or we are actually keeping the first n elements, removing everything else. I mean, this is backwards, so yeah. Now what I want to do is compare with the first n leading lines. So let match is equal to true, for let I is equal to 0. We're just going over every possible index up until n, and then we just check, hey, if tail at 0 is not equal to leading at 0, in that case the match is equal to false and we break out. But if the tail at 0 is equal to leading at 0, we try tail at 1 is equal to leading at 1. If it's not, we break out, but if it is, then we keep doing it again and again. And if any n works, we just want to go ahead and return true, right? If any n works, we just return true. So even one matching trailing line is enough. Otherwise, there's no overlap and we just return false. Cool. So this is the entire trailing overlap check that we have. Let's say after all of this also, there's no overlap or anything. In that case, we'll again have return proceed true, right? I mean, no overlap exists. We don't have to stop deduplication anywhere. So we're good. And also this is a very simplified version. You might have noticed I went very quick with this because the tutorials are actually getting pretty long. I don't want it to be very long. And if you're not understanding certain aspects, I understand this is a bit difficult. You can ask AI, especially for this part, which I did not explain. I think it's a pretty cool algorithm, but it's just out of scope for this tutorial. All the other things, if I'm not able to explain it properly, you did not understand it, please feel free to leave the comment below. I'll try to explain it using comments, but I would actually encourage using AI to understand this if possible. So now that we have the deduplication service in, what I want to do is go to the inline completion provider. And here we are going to have our deduplication service created, private read-only deduplication service, which is of the type of deduplication service. And now we're going to take this deduplication service and initialize it. So we have this dot deduplication service is equal to new dedup service. And I'll run it directly after we've cleaned the completion text. So I'll have constant dedup result is equal to this dot deduplication service dot check. Then I'll pass in the document, the position, and then the completion text. Okay. And if the dedup result proceed is not true, in that case, I will just go ahead and return null. If you want, you can also log this out. So we have this dot log, and then we say deduplication rejected this part. And the reason for that is deduplication result dot reason text. And if reason text is not present, in that case, I'll just say no reason provided, something like that. Okay. Now we'll again have, let's say if the proceed is true, in that case, we'll have completion text is, or completion is equal to deduplication result dot completion. Okay, let's have completion is equal to this. Okay, great. So that means, if proceed is true, we just find out, okay, there was an overlap. We have the overlap given to us. We trimmed out all of the overlapping stuff. So this is our new completion text. The next step is we've removed any kind of deduplication things that were present, but I still want to compute the minimal diff. What I mean by computing the minimal diff is that many times the model will be asked to delete a particular region, right? I mean, if you remember, our prompt is something like this. We have a replacement region where the model can basically edit any part of that line. And if the replacement region is, let's say, something like this. Okay, let's have maybe console.log x, that is our replacement region. And the model decides, no, console.log x is bad. We want console.log and maybe we want hello world. The minimal diff here would be that you remove x and you just replace it with hello world. A more realistic example is something like this. We have constant age is equal to 10. The best replacement here would be something like, let's say the model predicts age is equal to 15. I don't want to show this thing on a new line because they're essentially the same thing. The only problem is this part that has changed, the 5 and the 0. The 0 has changed to this 5. So what I want to do is compute the minimal diff that will allow me to display it to the user, and we'll add that decoration manager later on. But what I first want to calculate is what is the minimal replacement over here. And the minimal replacement is we take the 0 and convert this to 5. And yeah, that's what we're going to get. Let me just remove this for now. And let's create a function to do that. I will have constant edit is equal to this dot compute minimal replacement. And then we are going to have the document passed in, the replacement region. And I don't have access to the replacement region. The replacement region is just completion context dot replacement region. And here maybe I'll just pass in range dot start, and then I'll pass in context completion replacement region range end, and I'll also pass in the completion as it is. Okay, so these are the 4 things we are passing in: where the replacement region starts, where the replacement region ends, the document, and what is the completion text till now. And we'll remove this edit because what compute minimal replacement is going to return is going to be of the type of replacement edit. Okay. So let me go ahead and create this function, and I'm going to copy paste this because it's a pretty big function and my hands are hurting. So let me just go ahead and paste this in. So I have private compute minimal replacement. That's the function we're creating. Then I'm going to have multiple types here. I mean the parameters. So the parameters are going to be document, the region start, the region end, and the new text. Whatever we passed in over here, this is the region start. Because yeah, wherever the replacement region is starting, that's going to be our starting position, and the replacement region dot end is going to be our ending position. Then the new completion that we have is like the new text that we have is the completion, and the entire document is also passed in. After that, we are going to go ahead and compute the replacement. How it works on a high level is that it will take in this new text, and the old text is currently what's in the document. That is the old text, right? So we'll compute this old text from the document, and the old text is essentially whatever is in the document from region start to region end. Think about it. If we have console.log in the replacement region, the region start, the region end gives us, what are the positions, and then document will help us compute it. So we get the old text and we just check if it's equal to new text. If it is equal to the new text, nothing has changed. We'll just return null. This is a waste of time. Okay. But if not, we're going to return a replacement edit by finding something else. So first, let's get the first condition in. First of all, let's just have a return type of this function, which is going to be replacement edit or null. If we don't have a valid replacement to be done, we're going to return null so that nothing is shown to the user. Now let's get the old text. So what's in the document right now? From cursor to the end of the region we are replacing, we just do document.getText, we pass in the VS Code region, and we're done. We get the old text. And if that old text is equal to this new text, we return null. Nothing has changed. But if something has changed, how do we find the replacement then? So the point here is that we find the longest common prefix. So what we do is walk from the start while characters match, and then whenever we get the first character that does not match, well, we just break it then. We're just trying to find the longest common prefix. And the point of finding the longest common prefix is that we'll get how many characters are identical in the beginning of old text, right? We just want to find out how many characters are matching from the beginning in old text and new text. So let's go ahead and calculate that prefix length. So we only look at as many characters as the shortest string has, so we don't go past the end. That's something we've done for a while now. And then we go ahead and find out how many characters are the same at the beginning. And we walk forward until they differ. So here we have prefix length. That's the main thing we want to calculate here. And then we'll go over while loop. So while prefix length is less than the minimum length that we calculated here, the minimum length is whatever is the minimum between the old text and the new text. If the old text is smaller, we'll just take the shorter route, right? Because if we try to do, let's say, old text at I and new text at I, if they're equal or not, but then maybe new text dot length is bigger than the old text dot length, we'll go out of range. And that's why we are just calculating the minimum length. And then we're checking while the prefix length is less than minimum length and the old text at prefix length is equal to new text at prefix length. As long as that is the case, that means the characters are the same and we are within the range. In that case, we'll just do prefix length plus plus. Okay, and now we'll do the same thing for suffix. We want to find the longest common suffix after that prefix. So we go ahead and have how many characters are same at the end. So just the opposite of what we did here, and we walk backwards from the end. Here we were walking forward until they differ, and we walk backward for finding the prefix, for finding the suffix. And what does end mean? End means after the prefix. So that means I'll have a variable suffix length, then I calculate the max suffix length, which is just equal to minimum length that we calculated here, minus the prefix length. To demonstrate why we need this, let me just go ahead and put in this line, okay? So take, for example, this thing. We have old text equal to this string and new text equal to this string. Obviously, this is not code, but it is directly related to code. I mean, you can just replace this with any code piece and you'll get the same result. However, let's say we have old text is this, new text is this. What's changed is this XYZ changed to 1, 2, 3. So step 1 is we find the common prefix. So from the start, we check is A equal to A, B equal to B, C is equal to C. Okay, that's good. That's happening. But then we check X is equal to 1. Nope. So what we do is find out that the prefix length is equal to 3 because 3 characters matched. Step 2, we find out the minimum length and the max suffix length. Both strings have length 9, so the minimum length is 9. Max suffix length, this thing, is equal to minimum length minus prefix length. That makes it 9 because that's the length of the minimum length of both the strings, and you subtract it by 3. And 3 is the prefix length, so that's equal to 6. So when we scan from the end, suffix length can grow at most to 6. If it goes to 7, that means it will again coincide with C, right? I mean, think about it. We are at this position, okay? And then we can only go up till 6 characters, because if we go to the 7th character, we go to C, and that is the common prefix we've found out. We want to find suffix after the prefix. So that's what this max suffix length helps us with. So that's done. Step 3 is we find out the common suffix, which is bounded by this max suffix length we calculated. And then we compare from the end for this as well. C is equal to C, B is equal to B, A is equal to A. And then we found out that Z is not equal to 2, right? Or Z is not equal to 3 actually. And that means we stop over there. So or the suffix length that we calculate is now going to be, in this case, 3 as well. So we found out based on the prefix what should be considered from the start, what should be considered from the end, so that we can find out the middle that has potentially changed. If the middle has not changed and they're differing from the very beginning, we found out that yeah, this is ABC and this is CBC. But then we go from back and then we find out from here what has changed, ABC and ABC. And then we find out, okay, so this entire portion has changed. The first 5 characters, the last 5 characters remain the same. And that means we found out a minimal replacement. Okay, so that's our logic. Now let's go ahead and calculate the suffix length, having understood all of that. So we'll just put a while loop similar to what we did with the suffix length, or the prefix length, sorry. So suffix length is less than max suffix length. We are bounded by max suffix length, and the old text is equal to the new text. Okay. And notice here I'm doing old text.length -1 because length is 1 indexed. I want to do 0 indexed. Okay. And now I'll just do suffix length ++. After that, I found out, yeah, what is the suffix as well. Now I want to identify the different middle. How do I identify the different middle? Well, for that, I'll find out what the old diff's end was, what the new diff's end is, because they can have different lengths, right? The comment, where does the different part end in old text and in new text? Everything between prefix and suffix, that's the middle I'm talking about. So here we calculate old diff end is equal to old text.length minus suffix length, and new diff end is equal to new text.length minus suffix length, because in our case both their lengths were 9, but they can have different lengths as well. If they have different lengths, they'll have a different ending position. So we just find that out. Once we have that done, we'll calculate the deleted text, the actual deleted text, and that's pretty easy. We go from prefix length to the old diff end, right? So let's just find out the bit we are actually removing. This is what we show in red when the user accepts. So this is the deleted text, the thing that is being shown as red. For example, like let's say this is the thing that is being removed entirely. Maybe we are doing prefix length ++. That's the model suggestion. So this entire thing is going to be, well, technically, if you're doing prefix length, our system will find out that suffix needs to be replaced with prefix. So let's just say this entire part, okay? Not the entire thing, just this part. Oh, let me highlight this properly. Okay, I can't. So we take this out and just replace it with prefix. Cool. We are going from prefix length, you know, wherever the prefix length starts. I mean, think about it again in our example, this particular example. Let me just indent it. So our prefix length was 3. So we start at 3 and then we go until old diff's end, because the old text is being removed, right? Not the new text. So we'll have to show that red part on the old text. So, I mean, we will be slicing off the old text, right? So we'll go until XYZ, because we start from prefix length, which is 3, and we go until the old diff's end, because old diff's end is just old text.length minus suffix length, which basically comes out over here, because old text.length is 9 and the suffix length is 3, so it is 6, so it goes up until here. So we calculate XYZ, that's the deleted text. Cool. Let me just cut this out again and we can go back to our paste. So the next thing is we turn character counts into line or column position, so we can tell the editor where exactly to delete. The point is we want to create a VS Code range, because that's what VS Code understands. It doesn't understand character counts. So what we do here is calculate the region start offset. So document.offset at region start, and basically we're just saying that, hey, this entire thing is going to start at region start. And now we can simply do actual delete start is equal to document.position at, and then we calculate region start offset plus the prefix length, because we found out our offset, where does the region start, and now we have the prefix length, which is wherever the region starts, you just add the prefix length to that. Okay, let me give you an example again. In our old text, you know, the region starts at A, for example. So we go and start until A, and then the position at region start offset, which is this part, and then we go until prefix length, and the prefix length is 3. So we basically start the delete range from here, right? So we've converted that, and the same thing will be done to find out the delete end. So we do position at region start offset plus old if end. That's what we calculated here. That's the ending position. Having done that, we are all ready. We have found out our delete range. That's something we want to return. We found out our deleted text, and we found out what exactly do we want to read out. Remember, those things are different. What we actually want to delete and what is our read part, that's something different. So let me just go ahead and return the replacement edit, which we'll have to edit first. So the first thing we are adding here is delete range. This represents replace from cursor to here. So editor needs the range to start at a cursor. So we pass in the range that, hey, the delete range is you start from the region start and you go to the actual delete end. So this delete range just basically replaces from cursor to here. That's the point. You replace wherever the cursor starts and you go until the actual delete end. This is different from another thing that we are going to add, which is actual delete range. And we'll talk about that. But we'll talk about the difference between the both. Let me just paste this in. So the next thing is insert text. What do we want to insert? And we go from 0 till the new def end. That's understandable. Then we have the deleted text, that's understandable. And then we have the actual delete range, which is only highlight this part in red. Just the middle we're deleting, not the whole range. And if deleted text is present, we're going to have the VS Code range as actual delete start and actual delete end. Otherwise, it will be undefined. So what is the difference between delete range and actual delete range? So this delete range is the range VS Code will actually replace when the completion is applied. So it must start at the cursor position. That's VS Code's requirement for inline completions. And it may be larger than the truly deleted part. It can include unchanged prefix text after the cursor because we are replacing a whole region with insert text. And what is actual delete range? This is the subset of delete range that is truly being removed or changed. This is required only for visual or decoration purposes. For example, the red highlight that we're going to add next. And it can be shorter or empty. If deleted text is empty, actual deletion range is undefined for that reason, okay? So the point is, this delete range is required so that we can give it to VS Code, and this is for UI purposes. Now let's go ahead to our replacement edit and find out the actual delete range. Or actually, we don't even have the actual delete range. So let me have delete range, which is going to be a VS Code dot range. And then we're going to have our actual delete range, which is also going to be a VS Code dot range. Okay. Now we come over here and our errors are not gone yet. It can be undefined as well. I forgot about that. So let's just have undefined here. Okay, sweet. And deleted text is actually also not present. Let me add deleted text here, which is going to be a string, right? I mean, what else can it be? We are not going to have start position in this replacement edit because that was something I added because, you know, I wanted to just show something on the screen. Otherwise, there's no need of starting position. Okay, so now we go back to activate completion and wherever these errors exist. And this now becomes delete range dot start. Okay, so this was the last completion position. We were using start position, but now start position is essentially the same value as whatever is the delete range's start value. Now let's go over here. We have pending completion dot edit. That is also going to be delete range dot start. Now let's go at the top, and here we have the activate completion with edit passed in. Okay, but the edit is argument of type replacement edit or null, and that cannot be the case. So let's have a condition here. The condition is that if the edit is null, in that case, there are no changes needed. So let's just return null completely. We're not going to activate any completion. So we have if there's no edit, or let's say the edit dot insert text dot length is at the end of the day equal to 0. because we've computed everything and then it turns out, yeah, the length is 0, or there's no edit, we return null instantly. That's what we did initially, right? We compare the old text and the new text, and if they were equal, we just returned null. So that can be the case. So we just return null over here. And if we want, we can log this out that, yeah, no changes detected in the completion. Cool. So that's it. And that also resolves the error. And we're actually done with the computing minimal replacement part. Now let's go ahead and see if that works out. I'll start debugging. Okay, cool. We have something now. Let's go ahead and test this. Maybe I can try a simpler example now. There's no need to be complex. So maybe I can have something like this, okay? Maybe I can have constant age is equal to 10, okay? That's good. And I clear off the terminal. And now let's say I do something like, or actually instead of this, I can do is adult is equal to, and yeah, we get the completion age is greater than equal to 18. That's perfect. But actually not very perfect. We still need age variable here. So let's have age. Okay, that seems good enough. And let's say this is a number. Okay, great. Now I'll clear off the terminal and let's say instead of is adult, I write is senior is equal to. So we do get age number, age is greater than equal to 65, but we do not get our minimal diff. That's probably because we have not even used it in inline completion provider. What we are having here is just the inserted text that's being used in activate completion, right? I mean, all we are doing is displaying the insert text. But as a test, what I like to do is, let me just go ahead and log out the edit. So I have this .log replacement edit, and then I can just have a backtick here, and then I do replacement or just the edit, okay? And also let's do json.stringify the edit. Now let's rerun this. Let's run start debugging. Again, I'll just set up the boilerplate code, and this time I'll actually save it. So I have constant is adult is equal to number, which is going to be of the type of, or actually age, which is going to be of the type of number. And yeah, it predicts age is greater than equal to 18. That's good. Now I'll open up my terminal and remove all the output. Now let's say I save this, then I'll do is senior. And here I get insert text is equal to this, deleted text is 18. As you can see, it correctly computes that we only have to delete 18 because the actual result is age number, age greater than equal to 65, because that's what senior is. And then it computes correctly that, yeah, the deleted text should be 18. And the actual delete range is line 0, character 41. If you want, you can go here. And as you can see, this is column 42 and number 1 is 43. So yeah, that's correct because this is one indexed, right? I mean, if you go over here, this is column 1. And in our case, character starts at 0. So yeah, this is working properly. Let me just close this. And now all we need to do is calculate the decoration range. I mean, by decoration, I mean, VS Code is obviously not displaying what all we need to delete. So we'll have to create our own UI to display all of that. So let me just go ahead over here and in the source folder, let me just close all of the files as well. And here in the source folder, maybe I can create a new UI folder, and within the UI folder, I can have something like a deletion decoration manager or deletion decoration.ts, something like that. And now we can create a class to show the actual deletion. So I have export class deletion decoration manager. Let me have decoration here, and let's just leave it at deletion decoration, which implements VS Code.disposable. This is going to be a disposable object because we are going to be listening for something. That's just one thing. So let's have import everything as VS Code from VS Code. Perfect. Now we will go ahead and implement the dispose, but for that we will need the disposables that we had everywhere. So private read-only disposables is going to be a VS Code.disposable list, which is going to be an empty list. After that, we're going to have something like this dot disposables dot for each, and for each disposable that we get, we're going to do dispose. Okay, so yeah, that's pretty much it. Now the next thing I want to do is have a tracking for the editor. That's why we need it. So what I want to do is track the active editor we are in right now, so that I know, hey, what is the editor or the document with the, where I want to apply this deletion decoration. So I'll have private active editor. Let me have active editor, which is going to be of the type of VS Code dot text editor, or it can also be null, and initially it is going to be null. After that, I'm going to have a constructor where I have the decoration done. For that, we will also have to kind of define the decoration type, right? And this is another VS Code specific thing. So we'll have private read only, and then we have decoration type, which is going to be of the type of VS Code. Let's have VS Code dot text editor decoration type, and here in the constructor I'll set this decoration type, which is going to be equal to VS Code.window.create text editor decoration type, and then I'll pass in the options. So the options are as follows. The first thing is going to be the background color. What is the background color when we are showing this decoration? It should be a light red background, because it's deletion, right? I want to tell the user that, yep, we are deleting all of this. So it's kind of subtle, but also visible at the same time. So we have RGBA, then we have 255, 100, 100, and then 0.3. Okay. After that, we have the text decoration. The text decoration is going to have a line through, which is essentially a strike through that will help indicate the deletion intent. So there's a red color on top of that. There's a subtle kind of line that displays the strike through. After that, we have the color, which is slightly dimmed text color to kind of de-emphasize, just design preferences. So we have RGBA with 150, 150, 150, and 0.9. Okay, that looks good. We're all set with the decoration. Now, the next thing I want to do is push to the disposables, the tracking that we're going to do. And we are going to check VS Code.window.onDidChange active text editor. Because whenever the text editor changes, that means the files have been changed. In that case, I would like to clear off any decorations that I've added, right? Because if the decoration persists, which it will, until we clear them off, the problem will be that, let's say the deletion range is shown to this particular thing, but my problem is, why is it shown to this particular thing? Because I'm coming from a different file. This is all right for me, but on a different file from line 10 to line 16, we had to show the deletion. And since this is not VS Code managed, we are putting in this particular deletion. We'll have to clear it off ourselves. So I'll just have clear decorations. Okay. Now let me go ahead and create this function of clear decorations. It's going to be a public function because we're also going to add it later on in the inline completion provider. So we'll check if the active editor is present now. In that case, this dot active editor dot set decoration, and then we'll pass in this dot decoration type, and then there's going to be an empty list passed in. Because the first one is decoration type and the second one is range. Well, we don't want any range, and that's why we're clearing it off. Also, I'll set this dot editor equal to null after this point. Also, in our dispose, maybe we can go ahead and call this clear decoration. So we'll have this dot clear decorations, and that's good. Okay. Also, let's just have this dot decoration type dot dispose, because yeah, that is also something that can be dispersed. So let's just not use that, right? I mean, it will free up space, but we are not causing any inconvenience through our extension. So what we want to do here is just clear the decorations when the selection range changes significantly. So this will catch cases where, users navigate away without editing anything. So yeah. let's have this dot disposables dot push. Then I'll have VS Code dot window dot on did change text editor selection. Once we have that, we're going to have an event, and then we'll check, hey, if this active editor is present, that's not null, and the text editor is equal to this dot active editor. And remember, we only want to clear if the user made a text selection, not just, if there's a cursor movement. Cursor movement is normal when we're during completion preview. So we'll have constant selection is equal to e dot selections at 0, whatever is the user selected. And if the selection is present, and let's say the selection is empty or not empty, sorry. If the selection is not empty, in that case, we are going to clear the decorations because, the user did not edit anything, but they selected this thing. In that case, we do not want to still keep showing them the entire deletion range. Awesome. And also note that we intentionally do not clear on document changes here. Document changes are handled by the provider, which knows whether the change was a completion acceptance or the user typing. Clearing here would cause race condition with VS Code's ghost text feature that they themselves allow, right? So now let's go ahead and show the deletion function. So let's have show deletion. That's the main function. We are going to have the editor VS Code.text editor. Then we are also going to get the range, which is VS Code.range. Awesome. It's obviously going to do nothing, but in the UI, it's going to do something. So the return value is null or void. Then we just clear off the decorations. After that, we check if the range is empty. In that case, we'll just return because we don't want to decorate empty ranges. This is pure insertion. Then we just, if the range is not empty, in that case, the active editor is equal to editor. And then we'll apply the decoration, which is editor.setDecoration. Then we'll pass in the decoration type and we'll pass in the range. The problem here is that this if condition is just done so that, the empty ranges are not decorated, because many times it's just insertion, deletion is not even required, and that will be most of the time. So why do we want to display any red whatsoever? So that means the deletion decoration is done. It was as easy as this. So let's just add it to the inline completion provider. So we have private read only, and let's call this deletion decoration, which is going to be deletion decoration type. Make sure you import that. Then we are going to do this dot deletion decoration is equal to new deletion decoration. Awesome. Now we can use this deletion decoration everywhere. The first place we'll be using it is in the activate completion, right? Because whenever the activate completion is happening, we are displaying to the user. So here I can check if the edit dot, let's say deleted text dot length is greater than 0, that means there's something to delete. If there is something to delete, what do? Well, we find out the editor we are in, which is VS Code.window.active-text-editor, not active terminal, active text editor. After that, I'll check if the editor is present, and let's say the editor.document.uri.toString is equal to the document.uri.toString. If both of them match, in that case, I would like to go ahead and delete, because the editor here is matching and whatever document we are in is the active text editor. So let's just add that. So we have decoration range is equal to, and then we have edit.actual delete range. And if actual delete range is not specified, then we just use the delete range. So this is kind of like the optimization version. And if that's not present, it will be present, but let's say if it's not, the delete range is not there, because actual delete range is only not specified when the deleted text.length is 0. But in this case, we have checked. But anyways, just to get rid of the error, because delete range is specified to be undefined as well, all we need to do is show the deletion. So we have this .decoration manager .show deletion, and then I'll pass in the editor, I'll pass in the decoration range, and yep, we're all set. So this should actually go ahead and delete. So now I'll run start debugging, and our entire document is gone. I thought I saved it. Or actually we are using the source folder, and that's why, whenever I edit here, this part also gets edited. So maybe I can exit this. Here I have test.ts, and in test.ts I can just go ahead and have is adult is equal to age number, and we'll return age is greater than equal to 18. That's good. That was considerably fast, but obviously we need faster, so we're going to switch to Groq and other LLMs. Now let's say I have is senior. In that case, as you can see, only 18 was highlighted, and now if I just press tab, it will do nothing. The reason it does nothing is because we have not told it to do anything. And also one thing I realized is even over here, I would just like to call clear decoration within inline completion provider. So let's go to dispose function that's present here. And actually we don't have a dispose within inline completion provider. So maybe we can create a dispose function here. So let's have dispose void. Here we're just going to dispose of the deletion decoration. Let's just call dispose on it. And since we're already here, let's just go ahead and dispose of other things as well, like completion cache. Then we also go ahead and dispose the API client. So we have that. After that, we'll go ahead and do LSP service, or not LSP service, intent tracker dot dispose. Okay. And maybe the context gatherer as well. I don't know in which ones I created the dispose function, but you get the point. You'll clear off everything from here. Then we will go to extension.ts, or actually not go to the extension.ts now. We again have to stay in inline completion provider. And the reason, the delete range doesn't pop up is because VS Code API, as I said, doesn't know about like the replacement stuff, because all we're doing in activate completion is just inserting the text. What I want to do is also add the deletion range. So I've added dot delete range here. Then what we are going to do is create the inline completion list. After that, we are going to, we just have in the create inline completion list something like this. The range is now specified. Initially it was null, but now it is specified. And now since the range is specified, we can pass in everything. So I think that should work now. Let's just start debugging again. I forgot to save the file again. Let me just have constant is adult is equal to age number, and then we have age is greater than equal to 18. Then is senior, and then as you can see again it cancels out. I hit tab, and even then it still doesn't work. So why is this happening? Well, we can close this and I can tell you exactly why that's happening. Now we need to go into the extension.ts and register the command. The command is that we create our own custom accept completion. Now we don't rely on VS Code's API to accept the completion because it's not able to do it correctly for us. What we want to do is create our own, and then we'll apply it. So let's go to package.json first here. Or not package.json, sorry, we are going to find out. Okay, yeah, it was package.json, my bad. Let's have our two key bindings added here. So we'll paste it in over here. So we have key bindings where the command is tab completion. And I think our tab completion is not like that. It's tab completion, and then again tab completion dot reject completion. So the command is this: we accept the completion. The key is tab. Whenever the tab is done, this command is basically triggered. When the condition when the key is active, that's editor text focus. So whenever the editor is in focus, that time the completion is active. Otherwise it doesn't work. And the same thing goes for reject completion. Okay, the user can accept or reject, right? And that is escape key. If you want, you can also add one for accept word, but I'm not doing that. Then we'll go to extension.ts. So let me go ahead and add that stuff in. So the first one is accept completion command. So we have vscode.commands.register command. That's the way we register a command. And in this case, it's going to be tab-completion.accept completion, the same one as package.json. Just remember that. I'll change it later on. Then we are going to have output channel.append line. Then, we're just appending to the log that here we have accepted the completion command, and yeah, we are executing it. Then we get the active text editor so that we can apply or insert and delete the section that we want. Then if the editor is not there or the provider is not there, the provider is this inline completion provider. In that case, well, there's no editor provider, we just return off, but that's barely ever the case. It has to be some rough edge. After that, we are going to get the pending edit. So in the inline completion provider, we are going to trap the pending edit variable that we were tracking, right? I mean, there was this pending completion variable. I'll use that to get the pending edit. So I can just create a getter here, which is like get pending edit, which is a replacement edit that's returned, or it's a null value that's returned. And then we do return this dot pending completion dot edit if that's specified. Otherwise, we just return null. So now extension.ts has the pending edit. Cool. Now, if that pending edit is specified, in that case, well, what do we do? If there's no pending edit, well, there's no pending edit. So there's no pending completion. We execute the normal tab behavior. So we have vscode.commands.execute command tab. And then we return out. There's nothing more to do in this particular callback function. But if the pending edit is there, then we say applying the edit. The delete is this delete range dot start line. Then we have the end line, the start character, and then we have the end line and the end character. So like we're just logging out, hey, where are we applying the edit exactly? So in inline completion provider, where I logged out, what is the the replacement edit, I don't need that anymore. It will be applied over here automatically. After that, we will apply the edit really. And to do that, we use editor.edit. So editor was this variable, the active text editor. We call edit function on it, which gives us edit builder, which we can use to build what we want to edit. And the edit we want to do is edit builder.replace, because we want to replace whatever is the pending edits delete range and add the insert text, right? I mean, if you hover over this, the location is where do we want to replace the text from and what is the value that we want to insert. So we want to replace the delete range. That's what we had calculated. And then the insert text. After that, we also want to add one more thing, which is undo stop before and undo stop after. So that means it adds undo stop before making the edit and after making the edit. So now this edit is treated as one block. So let's say something is displayed, which is like 15 characters, right? In that case, it would be treated as one character. So let's say I added something like await vscode.command, something like this, await vscode.commands.execute command. Now, if I, let's say, do command Z, it removes exec, whatever was there, then it removes exec, then it removes commands, then it removes vscode, then it removes await. These are all undo stops, because naturally, if you do it in, let's say, Google Docs, you do Control Z, it will remove one character. Here, it's removing the entire word or the logical chunk it can understand. The same thing is going to be applied here. Our edit is going to be thought of as one thing. So let's say I have this dot completion cache dot, and the model suggests set completion cache. Okay. If that happens, and let's say I do command Z, it will remove that entire set completion cache. That's the point of having this entire undo stop thing. So once we have that thing, it will return a Boolean value if it was a success or not. Did we successfully edit or not? If the success is there, then we edit, just log out that, hey, edit was applied successfully. And then we move cursor to the end of inserted text, because, we still have to change the cursor. This dot completion cache dot set, and whatever was provided by the LLM model after that, it will be added. It will be inserted into the document, but the cursor will remain at dot set. It's not going to move further away. I want to move cursor as well. And that's what I do here. So I'll calculate the insert lines, which is equal to pending edit dot insert line text dot split. So we get all of the lines. And then I just calculate the end position of that insertion. So if insert lines.length is just one, that means the delete range.start line and the delete range.start character is our ending position, because it's just one line. Where we started, that's where we're going to end. But if it's not one line, what we do is delete range.start line plus insert lines.length minus one. And this is insert lines at insert lines.length -1 dot length. Think about it. Pending edit.delete range.start.line is just, wherever is a starting line plus how many ever lines there are. That is going to be our starting position. And then our ending position, also this is 0 index, that's why there's -1. And after that we have insert lines, that's the ending position. And ending position is insert lines at, or ending, not ending position, sorry, the character position. So we have insert lines at whatever was the character length, we just put that in. Okay, so that's our the character name or the column number, whatever. So that's our insertion end position. After that, we just say editor.selection is equal to new VS Code.selection. And once we have that, we have our entire cursor shifted from insert end to insert end, right? That is because if the selection is insert end, that's just, the cursor has just shifted. So yeah, that's done. Now, what we want to do with accept completion is also record the intent tracker. Because if you remember, I told intent tracker has 5 states. We're only tracking 3 as of now. We're just tracking what was added, what was undoed, like all of those stuff. But we're also interested in, if the user accepted the completion, that's a valuable thing. And if the user rejected the completion, that's also pretty valuable. So let's record the accepted suggestion in intent tracker. So we get the intent tracker and we call the record accepted suggestion. So let's create the inline completion provider here. Now, if you want, you can just initialize the intent tracker here and pass it to inline completion provider, which should work the same way. The reason we are having intent tracker passed and we're not creating a new instance is because it will register new listeners, it will register everything new, and that will cause us problems. So we're just passing the same instance every single place. But as I said, it would be cleaner if you can just pass it and do it in extension. I just don't want to spend more time doing this. So I'll just have intent tracker returned, which is return this dot intent tracker. Awesome. Now that I have this, I can call the record accepted suggestion, and that's not present within the intent tracker. So we'll have to record that. Also, here we have editor.document.uri.file system path. That's the first thing, what is the URI. Then we also have the start line, and we are one indexing it because this accepted suggestion is essentially going to go into our prompt, right? And that's what intent tracker does. So I am one indexing it so that it is on par with the rest of the lines or the rest of the edits that are present, because there also everything is one indexed. And then we have the insert text. Now let me go ahead and create the function within intent tracker. So let me just go ahead over here. So let me create the function record accepted suggestion, which is going to have the file path. That's what we're passing in. Then there's the line number. That's what we're passing in. I think after that there was content, which is the string that it needs to be displayed. And then it's going to return nothing, obviously. Just like every other function, first we are going to have the finalize intent. Once we finalize the intent, we're going to create an entry and add the entry. So I have constant entry, which is of the type of intent entry, which is going to be an object. I'll pass in an ID. As always, the ID is going to be intent underscore dollar plus plus this dot ID counter. We've done that many times for this particular thing. Then we have type. What is the type? Well, accepted. After that, there's going to be a file path. Then there's going to be a line range, where the line range is going to have a start value of line and the end value with the line. So the line range is specified. It is the same line range. After that, the content is content.split. Then we have \n at 0. So there's only the first line that's displayed. Then we have the timestamp. Then timestamp is just whatever is the time right now. And then there's going to be a suggestion preview. And the suggestion preview can be truncated, but I'll just pass in content as it is. Then I can simply do this dot add entry. And actually it's just this particular part. So let me just add that. So this dot buffer dot push, we pass in the entry, and while the buffer's length is greater than 35, we do buffer dot shift, similar to what we had done before. Or actually, I don't think we need suggestion preview at all. We can totally remove this from our application. And what we can do is just have content dot, like, I guess just the content like that should be fine. I mean, it's going to be 15 lines or 10 lines, our model is at most going to give us 10 lines. We can just directly put in, but if you want, you can truncate it down and display that content. But yeah, that's good enough for me. Now I'll go to the intent entry and remove suggestion preview entirely. Yeah, I think that shouldn't matter. So now we have recorded the accepted suggestion. Let's say if the success is not there, what do? Well, else we say that the edit failed to apply and we're all set. Finally, after that, I would like to clear off the completion state. So if there's any decoration, pending edits, context, we just clear all of them because the user just accepted everything. We still don't want to display anything to the user, right? So let's go ahead to the inline completion provider and create that clear. So we can scroll down to the bottom and have something like clear pending completion, which is going to return nothing. And what we're going to do here is this dot pending completion is equal to null. Then we say decoration manager dot clear decorations if there are any. And yeah, that should be good enough. So actually we already have this function clear pending completion. Okay, we did have that. We only have to paste one more line. So let me just go to our clear pending completion function and add the other line. Here we go. I'll just paste this in, just clear off the decoration. The pending completion anyway set to null. And now the clear pending completion is called here, but it is private and only accessible within the class. We'll change that. It's now public. And now it can be used outside as well. So we are recording the accepted command. Now what I want to do is to the subscription, push this accept completion command. So I'll also have accept completion command. Yep, that looks good. And since we're already here, let's also go ahead and have the reject completion command, right? It's going to be quite similar to this one. So let me copy and paste it over here. Let's call this reject completion command. And this is going to be tab hyphen completion. Same thing over here. This is going to be tab hyphen completion. And let's call this reject completion. Let's make sure it's the same as package.json. Yep, it is. Now we append line saying, yeah, we reject the completion command. After that, we get the pending edit. And if the pending edit is there, well, there's no normal tab completion behavior. So maybe we can remove that line because, like if you click on escape, when there's no pending edit, what should happen? Well, if I press escape, nothing should happen. So yeah, I'm not doing anything here. If there's no pending edit, all well and good. After that, we append the line that, yeah, we have reject completion. I don't necessarily want to do anything other than track the recorded suggestion, right? I mean, we rejected it, so I want to record it. That's all I want to do. Other than that, except as like the escape is barely going to do anything, because if you're just clicking on escape, what should happen? VS Code should just take over. I don't have to do anything else. I just want to track whatever is the rejected suggestion. That's a very powerful thing. It's like a negative comment on us that whatever completion we showed is bad. So I'll remove this entire chunk, or actually this particular part, if and else condition. We still need get intent tracker, and I'll also remove this log. I'll just do .get intent tracker .record rejected suggestion, and then I can pass in the file system path. I'll have start line +1, and then I'll have insert text. Okay. Now, similar to what we did for record accepted, we are going to do record rejected. Let me copy and paste it over here. Then we have record rejected suggestion. I'll pass in the file path. We don't necessarily have to finalize the intent in rejected suggestion because the user just rejected it. I mean, what will you finalize? We don't need to finalize, or if you want, you can. I don't think we should. Then we have the entry with ID counter. Then we have the type as rejected. Then we have the file path. The line range is specified. The content is, well, just, content should be fine. Then we have the timestamp, and yeah, that's pretty much it. We just go ahead and add the entry now. Cool. So that's our reject completion as well. And let's register reject completion command over here. So once we have accept, we do reject. Awesome. Okay, now let's go ahead and see if that works. So I'll start debugging. I should have saved. I'll just quickly type it. And let me just change this to is. Let's change this a little bit. I'll say is teenager. And here, as you can see, everything works out. It correctly identifies that, yeah, this is age greater than equal to 13 and less than 18. So, this 8 wasn't really removed. We don't have a deletion operation here. It correctly identifies, computes the minimal diff and says, okay, we just need to add 3 and age is less than 1. And then 8 is already present, right? So that's pretty cool. I'll just hit tab and it works out. Now let me say this is senior now. In that case, as you can see, the deletion range shows up. I can hit tab and it changes to 65. That's awesome. It's working. And if you open up this part and try to find recent edits, as you can see over here, we have one test.ts constant, whatever. But then that is the very beginning. If you scroll to the end and find out the recent edits, here we have it. Adult is equal to age greater than equal to 18. That was 1. Then number 2 is, well, this thing. Then we edited is teenager. Okay, that's good. I'm just trying to find where accepted is, and accepted is over here. We accepted this part and then we edited this, and yeah, that's all looking good. Now let's try to reject something. I'll change this back to, let's say, is adult. And let's say I press escape. It escapes. Awesome. And if I open this up and let's say I try to find what was the latest thing, it doesn't show up yet. But if I, let's say, clear off this command and let's say I hit a new line, here we do have rejected. So the first time it does not show up because, we rejected it, but then no other completion ran. Because it would be pointless for us to run that completion again. If we pass the same thing to the LLM, it will just say, oh yeah, it will just output the same thing. Our temperature is pretty low for the LLM. It is just going to be quite deterministic. And this is the most logical thing to do. 65 should be changed to 80. But when I move to the new line, the context changed a little bit. And now we have also told, yeah, we've rejected this thing. And that's valuable because as you saw, the next thing it printed out, thanks to our recent edits, is it was trying to know, it understood that the user is worried about is teenager and all of that stuff. So if I just hit enter, you can see is teenager, is senior, all of that shows up. And also cache was hit, by the way, over here. That's pretty cool. Is teenager, is senior shows up, and that's thanks to our recent edits. That's awesome. It almost feels like magic because of this. So that's all well and good. Now, the only thing that's remaining from here is speed. It would really feel magic if it could be done very fast. The problem with doing it very fast is that we have to use cheap LLMs for that. And cheap LLMs are not good. They're terrible, especially the ones that are not even tuned for coding. But that's what the fast LLMs and the cheap LLM providers basically kind of support, unless you decide to pay a price. So we're going to add 2 providers. The first one is Groq. It generally operates at about 1,000 tokens per second from what I've seen, maybe even 500, 600. It's pretty fast. And there they don't have a code optimized version because it's a 32 billion parameter model. It's very small. For context, ChatGPT or Claude is something along the lines of 1 trillion to 2 trillion or even more. It's not probably publicly known, but this is 32 billion in comparison. Obviously, there's a lot of knowledge that's compressed within this model, but it's not as smart as those big models. So what we want to do is use that. It's not even code optimized. So there's 2 phases in LLM training largely. There's pre-training and post-training. Pre-training is where you give the model all of the knowledge, but post-training is where you kind of determine how the model is going to answer and stuff. I'm talking on a very general point of view. There might be more things I'm missing out on, but The point is that if you post-train on code-related activities, it will perform code better. So there are models that are available on other providers that are code optimized. They're known as Quen Coder models. If you search for them, there's all of this Quen Coder models and you can find them, but it's not available on Groq. It is available on another service that we're going to use, which is Fireworks, and we'll be using that. But the problem is it's paid, but we do get $5 to $6 for free. I'll be making use of that to show you how to use Fireworks, because Fireworks is exactly what Cursor uses as well. So first we'll add the Groq LLM support. I'll show you the speed, but I'll also show you its quirks. Then we'll switch to Fireworks. Then I'll show you the benefits of Firework, but then we'll still not get as good of an output as Cursor, because Cursor custom trains their model on Fireworks. So on Fireworks, you can basically train the model by yourself, what's called as fine tuning. You can do it so that, the model is trained on your data. For example, when I use Cursor, I press tab. When I like a suggestion, that's an indication to Cursor. Cursor is storing it just like we are recording the accepted suggestion, right? But we are just putting it into the prompt history. What Cursor does is that it tracks it in their database, and then later on it uses all of that data to post-train their model. And for the tab completion, that's true. Even for their composer models that do agentic tasks, that's also true. They do that for both. And the result is the model feels very fast. And then there's all sorts of extra features that we have not added to this tab completion, like jump support and all of that. You can do that with normal LLMs as well. But if you have your custom model, you just need one model instead of like stacks or layers of model, which basically slow down overall. But with one custom model, you can do everything. So enough talk, let's go to Groq.com and add the LLM support. Once we've done that, I'll show you the speed. Then we'll move on to Fireworks. I'll show you what all can be done there. And yeah, we're done after that. Let's get started. So to get started, what we're going to do is go to the API client.ts file, because that's where we had created all of our providers. If you remember, we had passed in the endpoints for, well, OpenRouter, Groq and Fireworks, but all of their endpoints are just Groq and Fireworks. What we want to do is essentially change this endpoint. So how do we find out this endpoint? Well, if you go to their website, groq.com, which is groq.com, you will find that we can click on this button here, start building. Once we click on that button, it will ask you to create an account or login. I've probably created my account. I'll use that one, but then after that, we'll be on the same track. So just make sure you're logged in. After that, we come on a dashboard that looks like this. As you can see, there are multiple models available here. The reasoning models, the text to speech, speech to text, vision, multilingual, safety or content moderation, and function calling or tool use related models. What we're interested in over here is Quen 332B. As you can see, there's no Quen Coder kind of model present here. It's just the normal Quen 3 model. It's not particularly post-trained on coding related tasks, so it's not going to perform as well as we want it to. If you want, you can try GPT OSS 20B, but I don't think we can turn off the reasoning for this. That's probably why I didn't use it in the first try, but you can give it a shot. And if you want, you can also use Kimi K2, but I think that's a pretty big model and you probably don't want to use that. So let's just go ahead and click on Quen 332B. Once we click on that, we'll see a playground showing up. If you don't even see the screen, you can click on this playground and you'll be over here. And then you need to shift your model. And the model we are interested in is, well, also you can use Llama 3.18B instant. Llama 3.18B instant is a really small model, so it will work really fast, but the output is not as good. It's released almost 3 years, 2.5 years ago, so it's pretty outdated. What we are interested in is, again, let's try to find Quen 332B. That's by Alibaba. Once we have done that, you'll find that Groq has their own SDK. We are obviously not using that, but if you want, you can. We'll shift this from Python to curl. Curl will give us the API endpoint, and we'll copy this and paste it in over here. Notice we are using the chat completions API everywhere. There's also a responses API, but we're not using that because that is really well performing when you have something like a chat system, like an agentic system. In this case, we only have like a single request to send every single time, right? We're not chatting with the LLM. So having configured that, we are all set. I mean, that's all we needed to do in our system. Now we have to find the API key, and the API key is passed through the configuration settings, right? I mean, through the VS Code settings. What another thing I would like to show you is the reasoning effort. Let me type in a message here. I'll send hi. Then I'll click on submit. And as you can see, the assistant thinks for a while and it gives us these XML tags so that we can extract that thinking, and then it gives us the real message. What I want is no thinking at all. So how do I stop that thinking? Well, if I click on these parameters here, I can set the reasoning to none. Once I set the reasoning to none, and maybe I can set the temperature to 0.1 because that's what we're using in our application, we will again try to do hi, click on submit, and as you can see, it shows up hello again, how can I help you? And as you can see, the tokens per second is 434. It's lightning fast. Also, the latency is 30 milliseconds, which is great. Generally, tab completions show up in like 300 milliseconds or something. This is relatively faster. And it also gives us, our particular context management stuff is probably going to take 5 to 10 milliseconds. It's not going to take a lot. We're not doing a lot because we are pre-initializing the AST service. AST service is a thing that would take a lot of time, but as soon as the user opens the VS Code terminal or the VS Code window, AST is being initialized, and because of that, we can work much faster. So that's pretty cool. Now let's go ahead and set this reasoning effort in our API client, right? So what we want to do is check here, hey, what is going to be the model provider? If the model is, let's say, Groq, so let's just check that. So if provider config dot get model is equal to, let's say, something like Groq, in that case, what do I want to do? Well, I'll just set the reasoning effort to null, right? So we'll have reasoning, or actually body at reasoning effort is equal to, and then I have none. This is important to do because, as you saw, by default, the value is going to be the default value, which means the reasoning is on. So I want to specifically go ahead and set reasoning effort to none. The reason I'm putting this if condition is because if you try to do it with OpenRouter or Fireworks, this will result in an error because other models don't provide the body of reasoning effort. Cool. So we're all set now. Let's just go ahead and extract the API keys. Please don't use my API key. I'm going to be deleting it. So you can create your own for free, but there's massive rate limiting if you didn't already notice in the sidebar that was shown. I'll show it to you again, but let me say Groq. That's it. I mean, I have only one API key as of now. So I'll copy it, click on done. Also, just to show it to you, if you click over here and hover over this, you'll notice that the limits are you can send 60 requests a minute. That's pretty generous, but if you look at the tokens, you can only have 6,000 per minute. 6,000 per minute is pretty less for our application because if we have a big file, we are going to be sending in a lot of tokens because like we'll have, let's say, 200 lines and then import lines, all of that. That is definitely around 6,000. So in a minute, we'll only be able to send one request. But if you want, you can pay for it and you'll obviously get much better rate limiting. So yeah, that's one. I've got my API key as well. Let me just run start debugging. And the way we've configured our entire system to work is that first it will check for the open router key, right? Over here, when we were having the get active provider, we mentioned that open router key, if it's present, we return open router. But in our case, we want to use Groq. So what I'll have to do is go to the system settings. Here, I'll write tab completion. And after that, I'm just going to go ahead and paste the Groq API key, but also I'll have to remove the open router API key. I won't be using that anymore. Okay. Now let me show you the speed of open router, or sorry, Groq. So let me go ahead and type in over here something like, okay, maybe let me just remove this return statement. I'll hit enter. Okay, and it says the model Archie AI Trinity large preview free does not exist, or you do not have access to it. That's fair. we have to set the model name over here as well. I forgot about that. Let me change the model name. The model name is Quen/Quen3 32B. You can also find it over here. So I'll just type that in, Quen3 32B. I'll hit enter. Our services should be changed. Now let me go ahead and run this again. It still gives us the think part. So that means our code is a bit incorrect, as you can see, but it was pretty fast. I mean, I hit enter and all the thinking stuff came through. And that was my mistake, because I just thought get model would give us Groq. That's my bad. It should actually be, what is actually the provider config, right? I mean, provider config at provider is going to give us the thing. So what is the provider? Not the provider config. Provider config just provides us with the exact model name we just typed in. So it should be provider if that is equal to Groq. So let me just close this and let's retry again. Now let me go ahead and restart, and as you can see, return shows up pretty quickly. I'll hit enter. Then let me just go to the tab completion. We'll see no changes detected in the completion yet. After that, let me just go ahead and have something like, okay, as you can see, it automatically suggested dog with speak. I can hit enter. We're done. Then I'll go ahead to the next part. Then I can say CLA, and as you can see, it passes in class cat. That's also pretty good. And now if I press tab, as you can see, in it also shows up speak is also present. We're all set. So as you can see, this was pretty good. Within a matter of seconds, we were able to get all of this boilerplate code in, and it follows kind of the convention that's present over here, right? I mean, if animal is present, species should be taken. I mean, species is specified here. So that's all pretty good. And we got it with a non-optimized coding model. Imagine what we can get with a coding model. And also, as you can see, the speed was pretty good. Let me just go over here and let's try something over here. Obviously, the output is going to be pretty bad here as well. I mean, not here as well. Previous one was pretty good, but this one is going to be worse, and you'll see that. So let me just go down and let's try to do something like, okay, I'll hit enter here and it says this.outputChannel.show. And if I hover over it, this show does not even exist. So it just hallucinated show out of nowhere. I mean, if you want, you can go ahead and add other layers of checks that, hey, we'll go into the output channel, which we get through extract identifiers. We find out VSCode.outputChannel and we just understand if the interface of VSCode.outputChannel contains the method of show. If that is possible, then we can show it, otherwise we'll reject it. That's totally possible. That's something you can work on to make this tab completion much better. Obviously, there are more features like jump tab, where you add something and let's say the import line doesn't exist, so it automatically goes at the top and tries to import it, right? That's something you can definitely do. Also, let me just go ahead here and try something. I press enter, nothing shows up. But if I open up my tab completion, my output, it says dedup rejected, completion duplicates existing code below cursor. And that's a problem with these models a lot, because they will just try to duplicate whatever is present above or below, because they're not able to reason very well. And that's why you should switch to Quen-coder type models. And that's why we're done testing Groq. I'll just close it. It was as simple as changing this line, the endpoint line for us. Now let's go ahead and try with the Fireworks API key. Similar to Groq, we'll go to Fireworks, which is called fireworks.ai. And as you can see, they work with a lot of big companies. Also, Groq is working with a pretty big company because they just got acquired by NVIDIA. But anyways, the point is we have all of the entire Groq setup. If you want, you should go around and play with like all of the other models and see which one fits your case. If you hover over this, you'll notice that Moonshot AI Kimi K2 Instruct is also present. You can try that out, but it's going to be a bit longer. Let me just show it to you. I'll say hi and I'll hit enter, and the tokens per second reduced. It was 450 earlier, now it's 364. The latency is 40 milliseconds from 30 milliseconds. And obviously, if we have a bigger query, things are going to change and it's just going to go down, because larger models is going to be difficult to run in a shorter amount of time. That's why we use smaller models for this task. Also, because the costs are relatively low. If you try to run Kimi K2, it is going to take, or you're going to be charged much more than what will be charged to you if you use, let's say, something like Quen or Quen Coder or anything like that, because they're just smaller and it just takes less compute to run them. Now let's get started with Fireworks. You'll have to create a brand new account, and as you can see, we have Cursor over here. Fireworks has been an amazing game partner for them, blah blah blah. But anyways, like if you want to read more about how Cursor does it, you should go and read their website, where they say how Cursor built fast apply using the speculative decoding API. So you can read that. Essentially, it's the point where, in something like instant apply and smart rewrites, most of the code is going to match what's below the cursor. So what they do is just take a speculation and tell the model to pre-compute the KV cache for them, and that's how it works. It's a lot more internal of the model infrastructure side, so I'm not getting into it, but you can definitely read through it, and yeah, you can use it as well. But we're not interested in that. What I'm interested in is just getting Fireworks up and running. So I'll just sign up with Google and see you after that. Also, if you want free $5 API credit, you can answer the questions here and you will get the $5 API credits. So just do that. And once you've signed up, as you can see, we have free $6 credits. But if you want to use that and with the model, what you'll have to do is first put in your credit card stuff. Once you've put in your credit card stuff, it will start working. Obviously, you won't be charged until you go over the limit of $6. So you have to be very careful with that. And that's why I have all of the code written out here so that I can simply plug in the endpoint that it gives. And then I can pass in the model name that it gives. And then I can just run it and quickly turn off the provider so that I won't get charged on my credit card. But yeah, you should never forget to switch off once you've started this infrastructure, and let me show you how. But first, just go ahead to your settings. After that, you can click on manage billing. Then you can click on this adjust spending limit, and then you pass in the spending limit of, let's say, $25, because that's the minimum you can set. So once you've set the limit to $25, the maximum they can charge you is $25, but after that it will just stop. However, I would recommend you be very alert when you're running it. Quickly close it. It's just for testing. Otherwise, you can simply keep using Groq and skip the tutorial, because this is the last part of this tutorial anyways. So go ahead, add the payment method if you want to follow along. Once you've added your credit card, you should go ahead to the playground or model library, whichever one you want. I'll go to the model library. Here, you can search for the models. What I'm going to search for is Quen Coder. And as you can see, there's multiple Quen Coder versions. There's a 480 billion parameter model, but only 35 billion is activated at a time. This is called mixture of experts model. Most of them are mixture of model at this time. I mean, most models today in the world are mixture of experts. What we are interested in is maybe something like Quen 3 coder or Quen 2.5 coder, whatever one you're interested in. And as you can see, this is called on demand. That means when you select this model, what it will do is run it on demand. So it will pull up infrastructure for you. It will pull up a GPU for you and run it on a real GPU for you. And you can run how many ever queries you want. Based on that, you can patch multiple of your customers' queries on this infrastructure. So yeah, that's totally possible. After that, if you want, you can also fine tune it. And they use LoRa to train a model, which is one of the techniques for fine tuning. But what we are interested in just deploying on demand. Cursor would probably go ahead and fine tune so that they can better customize the model for their customers, because they have similar queries, right? So once they understand what their customers don't prefer, they can tune it accordingly. Also, I told you that there's an accepted or rejected state, right? I mean, if I press escape in the tab completion, I'm giving an indication that this is negative for me. If I'm pressing tab, I'm saying this is positive for me. So they can use those samples to train better. But anyways, we can click on deploy on demand. And then we can give a deployment name, the base model, where we exactly want to deploy. If you want, you can change the model from here, because I can see that this model projects an hourly cost of $0 to $12. It can be any of these. So if you want, you can switch to Quinn 2.5 Coder 32B Instruct. Similar costs. If you want, you can find other variants like 30B, and you can see it just uses 1 GPU, or the minimal one, which is just $4. Again, it just uses 1 GPU, which is 880 GB. And this is not the latest NVIDIA GPU, by the way. I think the latest one is, GB300. I think this one is about, let's say, 10 to 15 times slower than that GB300 GPU. This was released in like 2022. So yeah, just random knowledge if you're interested in that. I'll just deploy it. And yeah, we have something running on a GPU. So once that's deployed, it will give us the name and the API key that we can use so that we can get our model up and running, and then we can use it. Also, if you notice, the minimum number of replicas is 0, maximum number of replicas is 1. We're not having multiple replicas here. If you have multiple replicas, multiple GPUs, and you have multiple customers, you can kind of do a distributed computing style pattern with this and get the most out of each GPU. That's obviously very challenging, but yeah, something you can work on. Also, this particular thing that you see, this is known as the model name, because it created a custom, based on my account, the deployment, and then gave me the name. So that is actually my account name, and on that particular thing, it's running my model. So this is essentially the model name. If you don't use their infrastructure and maybe run it on, let's say, like you don't have it on demand running and you just run it somewhere that they provide, the model name will be, let's say, as simple as Quinn 3 Coder, but since you've deployed it by yourself, this name is given to you. So let's try to refresh and see if anything's updated. It's not, so we can still wait. And by the time we're waiting, I'll just go ahead and find out the Fireworks API endpoint. If you search for it, you'll get it. And this is exactly the documentation where you'll get it. I'll just click on copy, and then I'll paste it over here. So instead of this, I have api.fireworks.ai inference v1 chat completions. And then for the model name, I'm going to pass in what Fireworks gives me. Now we can just start running with debugging, so that as soon as we get it, we can try and close it as quickly as possible. I just don't want you to get charged. If it's more than 1 hour, I'm sure you'll get charged. So just make sure you complete it pretty quickly. What I'm going to do is remove the Groq API key as well, because if the Groq API key is not there, it will use Fireworks. So let's pass in the Fireworks. Okay, we don't have the API key yet, but for the model name, we can change it to Fireworks AI inference. Okay, great. Now we can try to find the Groq API key, and notice that we don't have to change anything in our API client code related to body or streaming, because this is all OpenAI compatible. Other than just 1 or 2 fields that need to be changed, nothing really has to change. So we're all set on that part. And by the time we're waiting, what I like to do is go to the settings. Then you can click on this API keys sidebar. Then you can click on create API key. Then you click on this, API key. You enter the API key name. I'll just type in Fireworks, nothing too fancy. It will give you the API key, so ensure you copy that API key. I did not show you that part, but yeah, you should go ahead and copy that API key. For now, go to this part where you'll paste in your Fireworks API key. Once you've done that, close your settings and you'll be all set. Also, here I can see that the deployment is completed. I'll just refresh. It will give me, I think, a dashboard with the usage, requests, latency, tokens, infrastructure, all of that. So yeah, we can go ahead and try this. So let me go back to our animal class. Here, let me open up the terminal. Then I'll say, well, what are we dealing with? And it says model not found. And I found out that I made a mistake, a pretty silly mistake. I passed in the API key instead of the model name. So let me pass in the actual model name now. Ensure that your Fireworks API key is still present. After that, we'll just open up the terminal. Let's close everything and let's try again. So it says no changes detected in completion. Let me hit enter, and as you can see, it creates 2 functions, def test animal speak, dog cat speak. Okay, that's awesome. So that's pretty cool. Now let's say I want to create a class. So it goes ahead and creates a class of lion. That's awesome. So let me hit enter or tab, sorry, and we're all set. So that means Fireworks is also working, and the model should perform better in terms of code because we're using QuenCoder. Obviously, this is not the best test for it. The best test would be test.ts, and even better would be if we open up our repository and try to see what it suggests over there. So first things, let me just close this folder. So I've opened up the source folder of tab completion just like I did before. Now let me go ahead and test this with context gather, API client, AST service. I'm just opening up all the files so that they're indexed. And also let's try to do something like, prompt builder and completion cache. This is something you can improve on because we obviously don't want the user to go over every class and make sure that we index it. We should just index it behind the scenes, something you can work on. But what we are interested in right now is just testing this out. So let's say I pass in to the call completion API. Okay, here I have something like this. Let's see what it predicts. And it says DDA projected completion duplicates existing code below the cursor. That's good. Now let's say I go over here. What does it suggest? Again, it will not suggest anything because the most logical thing would be to do result plus equals chunk, and that's probably what it did. Okay, that's also working. Now let's say after this, there might be something else we might want to do, like, cleaning up more stuff. So I'll hit enter, and yeah, it still doesn't do it because it's just repeating everything. So let's hit enter over here and see, okay, it predicts return clean.trim. That's good. Then maybe we can come over here and hit enter. Again, it's the same thing. I mean, the point is, all of these functions are pretty complete, so it's not very helpful, but you can go to something that is a bit incomplete and tell it to do something. For example, maybe something after this, okay? Maybe after this if condition, it tries to put something. Okay, it says if the completion cache time to live milliseconds is not equal to this, it just suggests this. Okay, that's something that's understandable. So if I hit on enter, we do have completion cache in config, and we set it to time to live milliseconds. That's not a bad suggestion. Let's go over here and try to see what it suggests. So here it says on did change text document. It gets the URI, it invalidates the cache for this document and deletes the cache. Let's hit enter. And yeah, that's also not a very bad suggestion. So yeah, you can have all of these things. Let me just undo it because that's not the actual code we want. Just make sure you undo everything. Even over here, anything that has been changed, I just don't want to edit anything because that's the code you've written as well. So it will be good for reference. Maybe I can just remove this decoration line. I don't think it would be that dangerous. Let me go ahead and start again, and hopefully this time it works out. So I have deletion decoration.ts. Where was this line? Okay, in the show deletion function, I can hit enter and it says editor.set decorations with the particular range. That's awesome, right? It's working pretty well. The only problem here is the indentation, and I leave it up to you to fix that. There's also multiple other features that you might want to add similar to cursor, including the speculative decoding API that this like the Fireworks provides us with. Also, if I refresh over here, it shows the number of requests. Not a lot of requests were sent. Then the latency, it was 320 milliseconds for P50, P90, P99, meaning that 50% of the requests or 50% of the requests that came in were better than 321 milliseconds. Then P90 is 90% of the requests that came in were better than like 850 milliseconds, and P99 is 2220 milliseconds. So yeah, it is not pretty good compared to Groq or something, but it's better than Open Router. And obviously, if you want, you can make this much more efficient. That's totally possible. And for that, you'll have to add in more infrastructure and do all of that sorts of things. Also, as you can see, the total spend time is still like $0.46. And if you keep running it, it will keep increasing Also, here another thing I would like to show you is the latency prefill queue. So that means the time spent in the prefill queue. Prefill is essentially part of the model that's just trying to understand your context. Then there's time to first token. So the P50 for that is 98 milliseconds. So within 98 milliseconds, we got our first token for 50% of the requests or more. And then we have P90 140, P99 is 149. What this time to first token represents is that how much time it took for us to actually start generating the token. So 149 milliseconds, let's say for 99% of the requests when our first token appeared, and then it took in, let's say, about 10 times or 15 times more to generate all of the tokens. So yeah, that's all well and good. What I'd like to show you is how to disable it. Just click on this button. So you disable. Once you've done testing, just ensure you keep up to date with the kind of the credits, the metrics. Don't get too close to $6. You don't know what you'll get charged for. Have a safety net. So once you've disabled, you can go ahead and click delete. So you delete it, then you can go to your settings and remove the credit card details that you've provided. And I'll do that after I've shut down this video. Thanks for watching, and I'll see you in the next video.